Okay, so welcome to Euron everyone, and welcome to our very first lecture of Big Data Masters. And in today's lecture, which is our very first lecture for all of us with respect to a big data. So I would like to talk about what is big data, by the way. So what kind of a data we can say as a big data. So can we say a gigabyte of data or petabyte of data or maybe a terabyte of data is equal to a big data? What should be a correct definition for a big data? All of these things we are going to understand. So let me share my screen and let's try to talk about that. What is, by the way, a big data? As its name suggests, that big data means obviously a large volume of a data. But this definition is not true all the time. So let me write it down over here, that what is basically this big data is. So knowing the definition is very much important for any one of us who is getting started with the big data. And this is where we all are going to help each other to understand this philosophy, that what kind of a data is actually called as a big data. So initially, when people were trying to define a big data, so they have taken a 3 V's concept. And then in a later stage, as per the analysis or as per the different situations, so which has evolved in between, people have started talking about a 5V concept, a V, right? A 5 V's concept. So if some data set is going to fulfill this 5 V's philosophy, so I am going to label that kind of a data set as a big data. And those 5 V's philosophy I'll be talking about over here, so that I can make you understand that, okay, this kind of a data is actually called as a big data. So I'll not take much of your time, but yeah. So here, the very first V that we generally talk about is basically called as volume. Volume, or you can say the scale of the data. So the scale of data. So volume is a very first key factor, or you can say a very first V by which you will be able to define a data set as a big data. So for example, if I'll talk about a Facebook famous example, so Facebook generates on an average a 4 petabyte of a data per day. So this 4 petabyte or MB of a data or KB of a data, we can try to define a volume, right? With the help of these parameters, GB or T, even starting from like a KB. So KB, then MB, and then GB, then petabyte, then zettabyte, then terabyte. And by using all of these parameters, we always try to define the massiveness of the data, a volume of the data, or the scale of the data. Now, so when we talk about a volume, so obviously we talk about its storage, right? Because we have to store this much amount of the data. So obviously we need a massive storage, and after a storage, we need a computation, right? We need often a computation. So the reason behind talking about a volume is very simple, that, okay, so if my volume is going to increase, then what kind of a system I should put in between, by which I will be able to store it and by which I will be able to do the computation. And this is where the concept of Hadoop and concept of Spark comes into a picture. So whenever volume comes, so concept of Hadoop and Spark comes into a picture in general nowadays, right? So where Hadoop system, a Hadoop file system is going to help you out in terms of storing a data into a distributed manner. Now, many of us are not aware about like what is the meaning of distributed manner, but yeah. So distributed manner, and then again Spark is a data processing engine. So it is going to help you out in terms of processing a data. Now Hadoop is basically a file system which is going to help you out in terms of storing a data into a distributed manner. And then on top of it, so you can try to call n number of different kind of a engine. So maybe a MapReduce, maybe you can try to call a Spark itself, maybe you can try to call a Tej engine, and then you can try to process a data in a effective manner. So again, when I say volume means a size of the data, these are the system which will come into picture. And now this volume, which is one of the parameter, right, which is one of the parameter to define or to label any data as a big data. Yeah, in data as a big data. So volume is a very first parameter. Now, second part or second V is something called as velocity. So basically it's called as velocity. Yeah, velocity, a speed of the data, obviously. So the speed of the data. Yeah, so velocity. Now, so let's suppose we are receiving a data with a certain speed. Maybe we are like receiving a data maybe in a real time from a IoT sensor. So we have a lot of sensors in place. Let's suppose I am receiving a data from a CCTV camera, so which I have to process in a real time. So maybe a 60 frame per second or maybe a 30 frame per second. Maybe someone is trying to do a transaction through your card, and we have to detect immediately before even authorizing a payment that whether it's a fraudulent transaction or whether it's a non-fraudulent transaction. So all of these sums up towards a speed, towards a velocity of a data, that okay, fine, data is coming from this particular speed inside my system. And then on top of it, so we have to basically build a system so which will be able to process those data set, which will be able to store those data set in an effective manner. So velocity is again one of the factor by which you will be able to define a big data, right? So, and where like a real-time streaming and processing becomes very, very essential. And this, by using this velocity, so we can try to define any kind of a data set as a big data. Now, the third V, right? The third V is called as variety of the data. Variety of the data. So we are living in a world so where there are a lot of different system which produces a different kind of a data. For example, so we can try to even take example of a system like a Twitter or maybe a Facebook. So where you will keep on producing a different kind of information in terms of a tweets or maybe in terms of a comments, in terms of a post, in terms of a like, share, subscribe, all of these data. Or maybe we are receiving some sort of a data from a PDF kind of a system. Maybe we are receiving some sort of a like a Excel sheet kind of a data from some of the system. Maybe we are receiving a CCTV footage in terms of frames, in terms of images. Maybe we are receiving some sort of a sensor data, right? Or maybe some sort of a JSON data or maybe XML data. So there are different kind of a variety of the data we used to receive in a system. And we have to process all of those data. We have to process all of those data and store it somewhere so that someone will be able to run the analysis. Someone will be able to extract a meaningful information, and that variety, whether it's like a PDF or maybe from a sensor that we are receiving the data, JSON file, maybe a XML file. So basically a structured data or maybe a unstructured data or maybe a semi-structured data, all of these things falls under a variety. Yeah. So the diversity of the data I can write down over here, that the diversity of the data which defines a variety. Now, so there is a fourth part, and the fourth part is called as veracity. The fourth part is called as veracity. Now, these three, the very first three V that I have talked about. So basically this first three V was introduced in a very early stage to define any kind of a data set as a big data. Then this fourth and fifth V's was added, and the fourth V is basically a veracity, and fifth V is basically called as a value. Now, what is the veracity? What is the meaning of this veracity? So here, in a simple term, we can say that the trustworthiness of the data. So the trustworthiness data is been labeled as a veracity of the data. See, we are receiving a lot of data from a variety of the system. Even when you go and open up your mobile app, any app basically, and then you try to make one click, you are generating a lot of data even over there. Whenever you come to the web and then you click something, you are generating a data. Whenever you go and ask some question to the LLMs, you are generating the data. Whenever you are doing some sort of a social media like activities, you are producing a data. So every time whenever you are interacting with the digital world, you are actually generating a data. But does all of these data set requires to be processed? Does all of this data set is going to give you some sort of valuable information? No, not all the time. And does all of this data set you can trust? Because nowadays we have seen that with the help of AI, people are able to generate even a fake data, right? People are able to generate even a fake data, or you can say a synthetic data, a lot of fake data which is out there, right? And again, even like a majority of the companies are struggling a lot in terms of identifying the data set as a fake data. That's pretty much like we all are aware about it. So now the trustworthiness inside a data, a genuineness inside a data matters a lot. Otherwise, that data is of no use for me. Doesn't matter what is the volume of the data, what speed we are receiving the data, or in what format I am receiving the data. It is not going to matter at all if there is no veracity. Means if you can't put a trust on top of the data. Otherwise, it will become a kind of a fake news, right? A fake news, the way we have seen over a social media again and again with respect to a different kind of a event, which will always try to manipulate a humankind. And we don't want that kind of a data in our system. So trustworthiness is one of the very important factor, and this was the V which was added in a later stage. Now, so, and as the system grows, right, as system is growing, as system is getting bigger and bigger, more connected and connected, it's very difficult to literally find out a trustworthiness of the data. So sometime everything looks fine to us, and sometime everything looks false to us. And yeah, so again, we are living in an era where these events or these kind of things we see a lot many times, more frequently nowadays. So veracity of the data also you should consider. You should take it into account. So whenever you are trying to define any kind of a data as a big data, if there is no veracity, then you can't label that data set as a big data. As simple as that. Doesn't matter what is the volume, what is the velocity, and what is the variety. Now, the fifth V that I'm going to talk about is a value of the data, right? A value of the data. For example, so we try to scrap a lot of data from a website, right? From our internet. There are a lot of like a web scrapper companies which is available, which is like you just go and like put up their URL nowadays, and then you will be able to scrap all of those data set. But is this particular data adding some value to your business? Is that particular data adding some value to your day-to-day life, or maybe to your client, or in any way it is going to impact in a positive manner, obviously, to your company? If not, that data set is not having any kind of a value, as simple as that. So value means what kind of a value? The business impact. So maybe I have a trillions of records. That's completely fine. I have a billions of records. I have a petabyte or zettabyte of the data. But it's of no meaning unless and until it is not going to give me some sort of a value to my own business in which I am, right? Maybe that big data is going to be valuable for some other businesses. That's completely fine. I'm not worried about that. But yes, unless and until it's not generating a value for me. For example, so many people try to sell a lot of like phone numbers. Many people try to sell over the internet itself. You will be able to find out that many people try to sell phone numbers, or maybe a leads, maybe a email ID. Now, so maybe they have collected those leads, they have collected those email IDs for some different business, right? But they are trying to sell you, and maybe the lead which is available inside those data, right? Those data are not your right prospect. So in that case, even if you are going to acquire millions of records, millions of email IDs and phone numbers, it is not going to even give a dent in your business. Now, it's of no use, although it is having a volume. Let's suppose frequently you are receiving those data with a variety, and even with the trustworthiness that, okay, so those phone numbers and those email IDs are basically a legit one, but still maybe they are not your real customer. Maybe they are not your real prospect. So in that case, you will end up rejecting, you will end up discarding that big data, a huge amount of the data. So value, the business impact is very much important. Unless and until some data set is not going to give a business impact, you are not supposed to, literally, right? You are not supposed to consider that data set as a big data. So when you are going to combine all of these 5 V's all together, then this any kind of a data, you can label it as a big data. So whenever you are trying to check what kind of a data I can label it as a big data, always keep only one thing in our mind, that all 5 factor comes into a picture, and you have to evaluate your data set based on all of these 5 factor. Then only you can say, then only you can label any kind of a data set as a big data. As simple as that. So hope this is making sense to all of you guys, and with that I would like to conclude your very first lecture. I would like to welcome all of you in a Big Data Masters, where we are going to learn a lot of things going forward as per your syllabus. In a best possible manner, in a simplified manner. I'll try to explain you each and everything. We'll try to do more and more practical. We'll try to focus less on a theoretical part. So unless and until it's not very much required, so we will not try to involve any kind of a theoretical understanding over there. So with that, thank you so much. Welcome once again, and let's begin our journey for a big data. Okay, so welcome to another lecture of Big Data, guys. And in this lecture, so I'm going to teach you that what is the difference between a traditional system that we have been using. We are not using now, obviously. So because in a IT, in a hardware, so everything has changed. In infrastructure, everything has changed. But yeah, so what is the difference between a traditional system and a distributed system? Because when we are talking about a big data, so obviously it's all about studying and implementing a distributed system. So I'll try to give you a glimpse. I'll try to give you a comparison between a traditional system versus a distributed system based on a different kind of a parameter. So let's get started. Let me share my screen, and here it is. So traditional system. I'll not take much of time in this video, but yeah, so I'm going to explain you in a very crisp and clear way. So traditional system versus distributed system. So see guys, it's not like we are trying to process a data from today, tomorrow, or day before yesterday. So we are processing a data since a decade, right? You can say that since 1980s, 1990s. So yes, we have a IT infrastructure. It's growing on a regular basis, and we are generating a data. We are even processing a data. Now, so when we used to process our data in those legacy system, then what was a problem? And then why we have started talking about a distributed system? Because when I'll be talking about a Hadoop ecosystem or Spark, I'll be talking about, or maybe any big data system which I'm going to talk about in today's environment. So all of those systems are basically a distributed system. Almost everything works on a distributed manner. So you have to understand in a very first place that what was a basically problem with the traditional system. So let me talk about that one by one, based on the parameter basically, right? So the very first parameter which I'm going to consider is a architecture. So architecture, architecture. So based on the architecture, so how we can see, how do we see basically a traditional system and how do we see a distributed system? So based on the architecture, the traditional system, the legacy system that we have been using, so it was basically a centralized system. Centralized system means, so everything is going to happen in one single machine, maybe a small, maybe a big machine. But yeah, so whether it's all about the storage or maybe about the computation, everything is going to happen in a single machine. So for example, if I have to run a databases, maybe a MySQL databases, if I had to run previously before, right? So if I had to run a database, so I will try to consider one single machine with some sort of a configuration in terms of a GPU, CPUs, and in terms of a like a RAM, or in terms of a hard disk basically. And then we are going to build those machine. So architecture was compact and it was just a single centralized machine. So where we were trying to do all kind of a computation. So here architecture wise, if I'll talk about a traditional, so here we were having only one single machine and we have been doing all computation. Let me draw this picture in a better way. So let me delete this part. Yeah. So if I'll talk about a traditional system, so we have been using this kind of a traditional system since an ages, and here so we were having only one single machine. So where we used to do all kind of a computation, right? Where we used to do all kind of a computation. Example is a database, right? A SQL databases. Now, if I'll talk about a distributed machine, T-R-I-B-U-T-E-D, yeah, distributed. So if I'll talk about a distributed system, so here instead of having one single machine, so what we try to do is, so we try to take a multiple machine. So I'll try to take an example of a database itself. So let's suppose if I'm trying to create a database, so it's not going to be just one, by the way. So it will be a combination of a multiple databases. It's going to be a combination of a multiple databases. And yeah, so in this way, we are going to distribute our data. So there will be maybe a central system which is going to manage and which will be connected to all of these databases, which is managing basically, which is managing all of these databases. So maybe this is a central node, I can try to say. And in this way, we can try to store our data. So instead of working with just a one single unified small or big machine, so in a distributed approach, the architecture is going to be different. A multiple system will be connected. Maybe those different system will be available in a different country, different region, different places, different location. Depends how we are going to design the entire infrastructure. But yeah, so architecture wise, this was a very first difference that you will be able to find out. So we'll try to dig deeper and deeper as we will move inside the courses, because we have to understand the complete Hadoop infrastructure, which is all about learning a distributed system, a distributed machine, right? Now, the second part, right? A second part or second segregation, which I can try to do based on the parameter, is basically a scalability. Scalability. So what is the meaning of scalability, by the way? So let's imagine in this way that yesterday I had a requirement of storing 10 GB of data, but today my requirement has changed. Maybe it's 100 GB. Tomorrow my requirement is going to change. Maybe I have to store 1000 GB of a data, and then the day after tomorrow maybe 2000 GB of a data, because my data is growing, right? My data is growing. So I have to ramp up my storage, and similarly I have to even ramp up my computation, because storage is completely fine, but at the end of the day I have to process my data, right? So scalability wise, basically the traditional system that we have been using, so traditional system, let me write it down. So the traditional system that we have been using, so it was vertically scalable. Vertically scalable means, so let's suppose I have a machine. So let's suppose I have a machine which is having maybe a 10 GB of a storage, right? Which is having a 10 GB of a storage, and maybe a 16 GB of a RAM I'm trying to use, a main memory I'm trying to use, and then certain computation I'm trying to use. Now tomorrow, if my requirement is going to change, so what I will do is, I will try to maybe add, I will try to do what? So I will try to add maybe additional 10 GB of a hard disk. So 10 GB of a hard disk, I'll try to add more on top of this one, and maybe I can try to add 8 more GB of a RAM in the same system. I believe we all have done these things, or we have maybe not done that, but yeah, we thought about this one with respect to our laptop, that okay, my laptop is getting slow, maybe I need some sort of a faster computation, so let's do one thing, so let's go ahead and then try to add some sort of a RAM. But eventually we all have realized that it's not just about a RAM, or it's not just about adding a hardware, it's about the entire motherboard. So your motherboard is supposed to support, your clock cycle is supposed to support, your CPU is going to support, right? Then only you will be able to leverage this additional things that you are trying to top up on top of the existing infrastructure. And I believe we all have thought about that one. And this was a same philosophy that we have been following in case of a traditional system. And it was having a lot of limitations. So beyond a certain limit, you will not be able to add anything, right? So you have to replace a complete machine. then you have to do a data migration into a very, very big machine, and consistently you have to do that, right? But if I'll talk about a distributed machine, if I'll talk about a distributed architecture, so let's suppose, so basically this traditional system was vertically scalable. Vertically means, so whenever you have a more requirement, so you are going to add it on top of the same machine. But here, in case of a distributed, so let's suppose today I have a machine with maybe a 10 GB of a hard disk and maybe a 16 GB of a RAM, right? Now tomorrow if my requirement is going to increase, and day after tomorrow if my requirement is going to increase, what I will do is I will try to add another machine, over here. As simple as that. So it's basically horizontally scalable. So this approach is called as horizontally scalable. So horizontally scalable. So this is the horizontally scalable things that you will be able to find out in case of a distributed one. And here, so we try to add a dedicated hardware. Dedicated hardware means a expensive hardware we try to add, because it's just one single machine that you have to manage and your entire business is running on one single machine. But here in case of a distributed one, so we try to add a commodity hardware. Commodity hardware means a cheaper hardware basically, because even if it is going to like a fail, that's completely fine. We try to establish a fault tolerance mechanism, which I'm going to talk about now itself in a next segment. Yeah. So distributed system was horizontally scalable and traditional system was vertically scalable, and there was a bottleneck, there was an issue with the traditional machine in this way. Whereas whenever I want, in case of a distributed machine, we can try to add one more rake, we can try to add one more resources, and this is what we are doing now, right? This is what we are doing now. Now, the third parameter is, right? The third parameter is basically a fault tolerance. Fault tolerance. Now, what is a meaning of a fault tolerance, by the way? It's E, by the way. Yeah. So what is the meaning of a fault tolerance, by the way? So the meaning of fault tolerance is that how we are going to save, how we are going to maintain if my system is going to crash, right? If my system is going to crash. So if I'll talk about again a traditional versus this distributed approach. So in case of traditional system, let's suppose if I have a single machine, doesn't matter I have a big machine or maybe I have a small machine, but it's a single machine that we are talking about at the end of the day. Just a single machine that we are talking about. So if this machine will crash or this machine is going down, this database is going down, right? My entire business will be stopped, and that was a major problem, right? That was a major problem. Whereas, so in case of a distributed approach, right? In case of a distributed approach, what is going to happen? So I have a multiple machine and then I have a central node, so which is managing maybe all of these machines. So it is going to manage all of these machines. Now let's suppose I have a central node over here and then I have a worker node 1 and then worker node 2, I have a worker node 3. Now there is a chance that this will go down. Yeah. If this is going down, your entire business is going to be stopped. But let's suppose this is going down, this particular one is going down. Generally what we do is, so we try to apply a fault tolerance mechanism that if one single node is going to fail, right? One single node is going to fail, other node will start serving you. Now you are going to ask me a question that, okay, so what about a data which is available inside this node? Yeah. What about a task which this node is going to process? So see guys, what we try to do is, so we try to replicate a data. In this approach, in this traditional approach, we have just one single machine. So I can't replicate a data. Replicate means, so I can't keep a duplicate data into a multiple machine because I just had only one machine. But here in case of a distributed one, I have a multiple machines, right? I have a multiple machines. So whatever data that we are storing here, so I can try to store maybe in n number of other machines as well. So even if one machine is going to go down, it's completely fine for me. I know that, and this central node is already aware about that. Okay, the same data is available in some different machine as well, right? Which is called as replication factor. So in general, we try to consider a replication factor is equal to 3, means one single data I'm trying to replicate it into a three different machines. And when I'm going to talk about the Hadoop architecture, so I'll be talking about this replication mechanism as well, that how replication actually happens across a different node, a different region, or different rakes basically. I'll be talking about that. That discussion will come in the future. But as of now, just try to understand that how it is going to achieve a fault tolerance. Fault tolerance means if machine is going down, how I'm going to serve my client, how I'm going to process the same data. So in a distributed approach, we try to implement a replication factor that, okay, don't just try to store a data into one. Do one thing, store a data into a multiple places. So even though one machine is going to go down, not an issue at all. So I have a data safe and secure in some other places as well. Because now all the businesses are depending upon the IT infrastructure. Now, if my infrastructure itself is going to fail, just imagine that your bank data will be wiped out over the night, then what you will do, right? What you will do. So this is something that we will be able to achieve with the help of this distributed approach. Okay. So fault tolerance. Fault tolerance is another differences that you will be able to find out. The fourth difference that I'm going to talk about is called as performance and throughput, which is a very important part, right? Because we are living in a data heavy era where we have a tons of data, right? We have a trillions of records which we are trying to process on a regular basis, a zettabyte and petabyte of data that we are talking about nowadays, which was not the reality 2 decades or 1 decades back. But yeah, so now performance and throughput matters a lot. Performance and throughput. Now, so in case of traditional system, if I'll talk about, so traditional system was good in terms of a small throughput if I'm looking for, right? If I'm looking for, or maybe for a small business where we have a limited amount of data. But as I said that we are living in an era of era where we are generating trillions of record on a regular basis, a zettabyte and petabyte of data on a regular basis. So performance is not going to be satisfactory if I'm going to be relying, if I'll be relying on a single machine. So here, if I need a performance, so obviously I need a more compute power. Plus, I need a infrastructure, a kind of infrastructure. So where on a demand basis, whenever it is required, so I can try to add more and more compute. I can try to add more and more storage, right? So that my performance and my throughput is going to be increase as per my need, as per my requirement. This is what we are trying to do over all the cloud platforms. So whether you are going to use Azure, AWS or GCP, so you can try to add as many EC2 instances as possible as per your need. You can try to take as many CPUs, GPUs as possible as per your need, right? So this is what we try to do. So here, right, basically this distributed system has been designed with the philosophy that you can try to take any number of compute as possible and it's completely fine. No one is going to basically stop you, and as per your need, so you can keep on adding as many machines as possible, so maybe a machine number 1, machine number 2, machine number 3, machine number 4 with certain RAM, certain CPU and certain hard disk, and I can keep on adding as much as possible, as simple as that. So performance throughput, obviously it's one of the major factor in a today's environment, and yes, distributed system can handle it beautifully, gracefully, but if I'll talk about my traditional system, so obviously it is not going to do the same. Yeah. So these are the differences, guys, major differences you will be able to find out between a traditional system versus a distributed. There are other parameters as well that I can discuss, but I believe as we will move into a lecture, as we will try to explore more and more this entire big data system, so I believe that will give us a capability to understand things in a better way. With that, thank you so much everyone, and see you again in my next lecture. Okay, so welcome to the another lecture of Big Data, guys, and in this lecture I'll be talking about definition of batch processing and stream processing. That what do we understand by batch processing and streaming, as its name suggests. And I believe it's self-explanatory in itself, that batch means data that we are receiving on a particular interval, that is something called as batch, and the data which we are receiving in a real time, so that is called as streaming, right? And both of these kind of a data you will be dealing with in a big data industry or into a data industry nowadays. For example, so if I'll talk about a real-time streaming, so you must have observed, you must have felt that Instagram or YouTube or any other social media platform, based on your scrolls, based on your click, they will keep on changing your feed, right? So they are trying to track your clicks. They are trying to understand your retention rate on a particular video. They are trying to understand the CTR, a click-through rate, on a particular things that they are going to showcase, and immediately with the help of those data, it is changing your feed, right? And you feel like that everything is personalized. Everything is personalized as per my requirement in a real time, and that's the reason. So we are able to spend on an average 5 to 6 hours of time on just a mobile devices, and especially on a social media nowadays, right? Obviously it's not a good thing. I am against it basically, and I try to stop myself as much as I can in terms of using social media. But yeah, I think it's an integrated part of all of us life. So this is one of the real-time example. And this is not the only real-time example, I would say. Sensor data, so again we try to stream it in a real time. If I'll talk about a vehicle data, so in all the high-end vehicle, you will be able to find out that it is streaming your data, whether it's an engine health or whether it's a part health, or maybe whether it's a location. Each and everything you will be able to stream, and you will be able to see inside your app. So we are living into a more real world data, we are able to see now a more real world data scenario like we have not seen before. So here it's very crucial to understand that how we can try to segregate this streaming data, and we can try to segregate this batch data. Batch data simply means that the data that we are receiving on a regular interval. For example, if your manager is going to ask you about the sales report, so maybe your manager is going to ask you not like every second that, okay, give me a sales report, maybe on a daily basis, maybe on a weekly or monthly basis, your manager is going to ask for the sales report, or whatever activity that you are doing, maybe a task report. So your manager is not going to ask you like every second that, okay, fine, every second come and report me. And that kind of a data, such kind of a situation is called as batch mode or batch kind of a data. So segregation is very simple. So wherever time interval will be involved, so that is called as a batch. And maybe like that time interval can extend from a 1 minute to 1 hour to a week to a day to a month to a year. Depends situation to situation, depends business to business. But the data that we are receiving, right, the data that we are receiving on a regular interval, now that kind of a data in a real time, so that kind of a data is actually called as a streaming data. Now, so if I'll talk about a system, right, a system by which you will be able to process this real-time data. So you must have heard about a messaging system, for example, a Kafka. I'm not going to write anything in this one. So yeah, it's just like a theoretical video. So I'll try to keep it in this way. So you must have heard about a Kafka, a messaging system, right? A publisher and a subscriber. So from one end, someone can ingest a data, publish a data, and then from other end, you will be able to fetch a data, subscribe a data. So Kafka kind of a system, a Flink kind of a system, Apache Storm kind of a system, or a Spark structured streaming kind of a system. So these kind of a systems are actually required that we are going to study in this batch as well. So as a part of syllabus, right? So we have everything inside this particular batch. So this kind of a system is required to handle a stream processing, right? A Kafka, a Flink, a Storm, or maybe a Spark structured streaming. Now, what kind of a system we can try to use to handle a batch? I think we have tons of such kind of a system. Even we have a legacy system and a modern distributed system. So maybe I can try to use a Hadoop, right, where we can try to store. Hadoop is, by the way, it's a distributed file system. So where in a different node, it is going to store a data with the fault tolerance replications. So we can try to use maybe a Hadoop to store a data, and then we can try to write a program in a MapReduce, or maybe we can try to write maybe a Spark program over there, or a Spark batch program we can try to write. So which will look into a data after a particular interval, and it is going to process a data. We can try to use maybe a Talent over here. We can try to use maybe a Informatica over here. Maybe we can try to use even a AWS batch processing situation. So where we can try to process a data. For example, AWS Glue I can talk about, maybe a Google Cloud Data Flow I can talk about, ADF Azure Data Factory I can talk about. So all of these you can consider as an option, Azure Data Factory or maybe a AWS Glue, which is similar to Azure Data Factory. UI is different, provider is different, but yeah, it's almost similar. And I have that in your chapters as well. So Google Cloud Data Flow. So these are the system we can try to use under the hood, and so that I will be able to process a data which is available or which requires a batch mode processing. Means process it not immediately but in a interval. So hope all of you are able to understand a definition wise that what is the difference between a batch mode of data and a streaming data, and then what kind of a system that we are going to use, and everything we are going to study as we will progress inside your lecture. So with that, thank you so much. See you again in our next lecture. Okay, so welcome to lecture everyone, and in this lecture I'll be talking about what is the difference between OLAP, OLTP, lambda and a kappa architecture. So whenever we try to design any kind of a system, so we try to choose one of these architecture. So OLAP architecture, OLTP architecture, or lambda, or maybe a kappa, or maybe a combination of like these four. Now, when I say OLAP, it simply means that online analytical processing. Now, just try to focus on the word and you will be able to understand the difference. Online analytical processing. Now, what is the meaning of analytical processing? So wherever we are trying to generate a reports, we are trying to do a dashboarding, we are trying to do a reporting and all sort of things, it comes under, means a kind of a system which will be responsible for doing a reporting, dashboarding at the end of the day, or maybe a data mining. So where my data will come, it will sit for maybe a short period of time or maybe for a long period of time, and then eventually I will try to do a analytical operation, maybe dashboarding operation, maybe a data mining operation on top of it, and that kind of a process is actually called as OLAP, analytical processing, right? Now, the second architecture that we try to follow is called as OLTP, a transactional processing. For example, I'm going to Amazon website, right? And then I'm trying to add something to my cart, and then I'm trying to do a checkout, and then they will initiate my delivery. Similarly, so I go to any website to book a flight ticket or maybe a train ticket, and in a real time, so it is going to reserve my ticket, and then it is going to confirm it after doing a transaction, and then other person will not be able to book the same ticket. Now that kind of a system, or ATM system, right? So where we go swipe the card, and then I will be able to get my money, and same amount of money will be deducted from my account. So all of these systems falls under OLTP, transactional processing. So where immediately I want something to happen, immediately I want some sort of a changes. Whereas in case of OLAP, I was not looking for an immediate change, by the way. Yeah, I was not looking for an immediate change in case of a OLAP architecture. But when I talk about a OLTP architecture, so yes, I'm looking for a immediate changes. Now, if I'll talk about lambda architecture, right? Lambda architecture. So it's a combination of architecture which supports a batch processing of the data, which I have already discussed in my previous lecture. What is the batch processing? Plus streaming, a kind of a system. So where I'm looking for a batch as well as a streaming processing of the data. So that falls under what? So that falls under basically a lambda architecture. Now, if I'll talk about a kappa architecture, so kappa architecture is basically a real time one. Now, let me give you an example by sharing this screen. Let me give you a differentiation between all of these four, OLTP, OLAP. So OLTP, OLAP, and then a lambda, and then kappa. Okay, this line is built tilted. Okay. Now, what is a difference between all of these four architectures? So I have already told you, right, that basically this OLTP, so wherever we have to do a transaction, immediate transaction, for example, e-commerce or bank ATM or something like that. So at that point of a time, we are going to use this particular architecture, that okay, I'll try to follow the OLTP architecture. So here, wherever transaction application. Now, when we are going to use a OLAP architecture, so wherever we are looking for a dashboarding, we are looking for a reporting, we are looking for a summary, we are looking for a data mining. So for example, in a Power BI, in Tableau, so in multiple places, we try to build a dashboards, right? We try to do a lot of reporting over there. So for sure, we are trying to bring a data from some of the sources, from some of the databases, from some of the system. So that I will be able to generate more and more analytics. I will be able to generate more and more reports. So this one falls under reporting. So wherever we are looking for a reporting, I will be using OLAP kind of a architecture. So online analytical processing. Now here, so when I talk about a lambda, now when lambda comes into a picture, so wherever we are looking for a batch plus stream. So wherever we are looking for like a both of this, batch plus a stream. So wherever we are looking for a real-time data and a historical analysis, both. So in that situation, I will be using a lambda architecture. So same, like I think I talked about batch processing, and I talked about like a real-time processing. So here, lambda is a kind of architecture, so which is going to support both. So whenever I have to, process my historical data, which is already available inside my databases, and I have to combine it with a real-time data that I'm receiving, right? A real-time data that I'm receiving, and combining that. So I have to do some sort of a processing. I have to generate some sort of analytics. So in that case, I will be using this lambda kind of a architecture. Now, when I'm going to use a kappa kind of architecture, so wherever I'm looking for a real-time process. So whenever I'm looking for a real-time processing, I will be using a kappa architecture. So if someone is going to ask you a question that I'm trying to build a streaming system, so what kind of architecture you are going to use? A kappa architecture you are going to use. Now, I'll try to give you a tool example, some of the tool example, because I can't accommodate all the tools at this point of a time. We will try to explore more and more, but yeah. So here, if I'll talk about a tool, so in case of OLTP, maybe I can consider Mongo DB, or maybe a MySQL kind of a system which supports online transaction processing. Now here, so if I'll talk about a OLAP, so I can try to use maybe a Redshift kind of a system, Redshift kind of a system, or nowadays Snowflake is very much popular. Or I can try to use a Snowflake kind of a system. Now, when I'm talking about a lambda architecture, so here I can try to use a combination of Hadoop plus Spark plus Kafka. Hadoop for a storage, Spark for a processing engine, and Kafka for a real-time streaming messaging basically. Now, if I'll talk about a kappa kind of architecture, so here I can try to use maybe a Kafka kind of a system because it should be a real-time Kafka, or maybe I can try to use a Flink kind of a system over here, as simple as that. Now, so use cases wise, right? So where you will be able to see a use case of OLTP, OLAP, Lambda, and Kappa. So I believe understanding wise, it's very much clear that what is the meaning of OLTP, what is the meaning of OLAP, what is the meaning of a Lambda, and what is the meaning of a Kappa. So use cases wise, so wherever you have maybe a e-commerce solution, e-com, right? I have given the example of Amazon, or maybe Make My Trip you can try to consider, or maybe a ATM example, or maybe banking, right? Banking, or maybe any kind of a ERP solution, enterprise resource planning solution you are trying to build. So over there, we need OLTP kind of a solution. So when it will try to react whenever transaction is going to happen. Now OLAP kind of a solution. So wherever we are doing a Power BI tool, we are using a Power BI tool, maybe a Tableau, or maybe wherever we are doing a dashboarding, or maybe a reporting, wherever we are using this kind of a situation. So everywhere OLAP process will be applicable. Everywhere OLAP process will be used. Now, so a Lambda architecture. So wherever we have to, right? Wherever we have to combine a real time data, and plus we have to combine the historical data, right? historical data. For example, so if I'm trying to work for a disaster management, right? Disaster management, or maybe I'm working for basically disaster management, obviously, and maybe for a weather forecasting. So where I have to analyze a current data that I'm receiving, plus I have to even look into the previous data, that what was the changes from the previous one to the current one in a very sensitive area. So obviously I'll be using a lambda kind of architecture in that case. Now kappa architecture, so wherever we have a sensor kind of a system, or where maybe we are trying to generate some sort of a data from a vehicle OBD port. So in that case, we can try to talk about a kappa architecture. So wherever we have a real time or we have a streaming data, right? So maybe sensor I can say. Now here real time plus historical. So maybe a weather or disaster management. And now OLTP, so wherever we are looking for a dashboarding. So hope a difference between these four architecture is pretty much clear. So which one we are going to use in which particular situation, and accordingly we have to pick and choose. Now inside OLTP there are set of the tools. There are like a set of the tools you will be able to find out inside OLAP, set of the tools inside lambda, set of the tools inside the kappa. So you have to utilize such set of the tools, depends upon the architecture or depends upon the problem that you are going to solve. And this is what we all as a big data architect or we as a big data engineer try to see or try to use it. So hope this understanding is pretty much clear. So with that, thank you so much everyone. Take care and see you again in my next lecture. Okay, so welcome to another lecture everyone, and this lecture I'll be talking about different kind of tools and technologies which you can try to use in a modern big data engineering. So guys, there are hundreds of tools that exist in this ecosystem, and every tool has been designed and you are going to include it as a part of your architecture. Depends upon the need, depends upon the workflow, and sometime as a fresher or maybe a person who is trying to start in a big data industry, so we sometimes get overwhelmed by looking at all of these tools, which I think it's completely fine. It's a genuine thing, but yeah, I think we can try to mitigate that situation. So if we are aware about that, which tool is going to do what and for what purposes we are going to use which one. And this is what I'm going to clarify. I have prepared a beautiful documentation for all of you, which will be shared inside your dashboard as well. So here, a modern data engineering ecosystem layer by layer overview. So I'll try to start from a very first layer, which is a data source layer, because at the end of the day, we are talking about a big data. So obviously we have to process our data, and without processing, you can't do anything. So here, what is the purpose? So origin of the raw data, obviously this layer generates a data that enters into a pipeline, because in big data we always try to talk about a pipeline, means ETL, extract, transform, load, or maybe some other kind of a pipelines. So here data source wise, so whenever you are going to work in a project, so what kind of a data source you will be able to see. So maybe you can fetch a data from MySQL, Postgres, or maybe Oracle, maybe a DB2 as well. So I have not mentioned all the tools over here, but yeah, so apart from this, there are other tools which also exist, but yeah, from MySQL, Postgres, and Oracle. So that while you are learning something, so you should go through and you should practice at least these things once. Yeah, you should be aware about little bit about a MySQL, little bit about a Postgres. If you are aware of MySQL, I think Postgres, Oracle, DB2, all these things you will be able to deal with. So traditional databases, and then NoSQL databases wise, MongoDB, Cassandra, and DynamoDB. There are other databases which also exist like a HBase and all. Then logs and matrices, maybe you will try to fetch. So Prudent or maybe Logstash or maybe from a Prometheus, you will have to connect, and then from there you will try to fetch log and matrices, maybe APIs or maybe some external tool. So any kind of a REST API, it's a very generic term by the way. So anyone can give you a REST API, anyone can give you access of their data, and then you will end up fetching those data, maybe a GraphQL, QL. Again, Webhook is one of the generic approach, and Google Analytics. So from these sources also, you will be fetching a data from a cloud storage like a S3, Blob, Google Cloud Storage. You will be fetching a data from IoT devices sensor, MQTT protocol, or CoAP, Kafka producer. You will be fetching a data, and maybe from an application like a CRM application from Oracle, from a Salesforce, from a SAP, ERP from a SAP, e-commerce platform. You will be fetching a data. So these are some of the sample which I have mentioned from a very first layer, that okay, you will end up fetching data from any of these kind of sources in a real time, in a near real time, or maybe in a batch mode. Depends on the business situation. So once you are able to get a data source, then there will be an ingestion layer. So a layer, so where you will try to land your raw data, the data that you are fetching from part number one, step number one. So here, batch ingestion, if you are trying to do, so maybe you can try to use Apache NiFi, Apache Scoop, or Airbyte, Glue, or maybe a Talent. So these are the tool which is going to support you in terms of batch mode of ingestion of the data. If you are streaming a data, maybe from a sensor or maybe from IoT devices by using a MQTT protocol or some other protocol, so in that case, Apache Kafka, Apache Pulsar, AWS Kinesis, or maybe a Google PubSub system that you can try to use. Now, if you are trying to do a CDC, change data capture, so where things are like a changing like a frequently, right, on a particular record itself. So in that case, you can try to use a DBGM or Maxwell daemon, or maybe you can try to use a Fivetran over there. Fivetran is one of the famous one, by the way. I've used it multiple times. And ETL or ELT, so extract transform load or extract load transform connector wise. So Airbyte or Meltano or maybe a Stitch, you can try to use it. So these are the tools that can be used in a second layer. So when we are connecting with our raw system, fetching our data, right? So in terms of configuration. Then once we will be able to connect, then we have to store somewhere, right? We have to store somewhere. So storage wise, we can try to create a data lake, raw data plus process data. So AWS S3, data lake Gen 2, I can try to use cloud storage, HDFS, any of this system I can try to use, or maybe data warehousing solution wise, where we have to do a analytical processing. So Snowflake, BigQuery, Redshift, Azure, and Synapses. And Lakehouse unified wise, Databricks data lake, we can try to use Apache Hudi, we can try to use Apache Iceberg, we can try to use, or object storage wise, we can try to use a Mini IO chip, we can try to use, or Basavi, we can try to use. So these are again tools which is going to help you out in terms of storing a data. So just try to understand a chronology, guys. So we are connecting with the data sources from this one. Then with the help of these tools, we are trying to fetch a data. Then we are trying to store a raw data over here. Yeah, storing a raw data over here. Then we can try to do what? So we can convert, once we are able to store a raw data, right, in our respective system, then we are going to convert a raw data into a clean data, structured data. So again, batch mode, streaming, different kind of operations. So these are the tool which I have listed down. Some of the famous tools is Spark, obviously Beam, AWS Glue, Dataflow, Flink, Storm, Kafka, so for a stream processing, or maybe a code-based transformation. So Pandas, PySpark, or Colas or Polars we can try to use, or data quality check wise. So grid expectations, or maybe Soda, or maybe a DQ we can try to use. So these are the tool that you can try to use for a conversion. I have very clearly mentioned each and everything. For a data enrichment, you can try to use this one. Now for a data orchestration, means if you have to automate, if you have to schedule, if you have to manage the entire workflow, so that the entire thing starting from point number 1 till point number 4 can run in an automated mode. So I need some orchestration tool. So over there, the famous one is Apache Airflow. I can try to use, or maybe a Prefect we can try to use, or maybe a Dagster we can try to use, maybe a Lugi we can try to use, or maybe a Maje we can try to use basically. Apache Airflow is something that I'm going to discuss in your syllabus, that is already mentioned, right? I'll be talking about that. I'll be creating this entire like a end-to-end orchestration. So this is a meaning of the orchestration, by the way. Now, so if we have to store a meta information, about a data itself, like a track, or maybe we have to store some sort of a catalog, or any kind of a data which is a data of a data, which is called as metadata. So we can try to use all of these tool which is available over here for a data catalog, for a lineage tracking, for a data governance, for a access control, and a security. As simple as that. Now, so if we have to, right, if we have to do a serving of this entire like a data set that we are trying to fetch, so for that, what kind of a tool that we can try to use, so that other processes, if they have to run some sort of analytical operation, or they have to build some sort of application on top of it, so how they will be able to access it. So here ad hoc query wise, so we can try to use Presto or Trino, or maybe Dremio, ClickHouse. Data exploration wise, so Superset, or maybe a Metabase or Reddas, we can try to use BI tools wise, a Tableau, Power BI, Looker, or maybe a Quick we can try to use, or semantic layer wise, we can try to use a Cube.js, DBT matrices. Data API wise, Hasura or maybe a post REST, we can try to use GraphQL Federation, we can try to use serving and query layer wise if we have to do that operation. Now, if we have to apply some sort of a AI application, AI interfacing on top of that, right? So we can try to use basically all of these particular tool for a feature store, for a model training. A famous framework is TensorFlow, PyTorch, Scikit, and then Spark MLlib. ML pipeline wise, we can try to use a MLflow, Kubeflow, Vertex AI for a pipelining, and then for a inferencing, final like a job. So we can try to use a Seldon, Belton ML, Fast API, or maybe a TOSserve. So these are the tool when it comes together, right? Then we say that one complete pipeline we are able to build. Then obviously, last but not the least, we have a monitoring and logging as well. So for a monitoring and logging, so these are the tools that we can try to use, which I have listed down in this particular place. Now DevOps and infra layer wise, so these are the tools that we can try to use. Now, so I'm not going to discuss about these tools one by one for now, because anyhow we are going to use it. We are going to see all of these tools. So I don't think that if I'm going to talk about one by one individual this tool, you will be able to understand anything out of it, right? So that's the reason. So I have created this beautiful slide that whenever you are trying to prepare for a data industry, whenever you are trying to become a data engineer, right? Always keep in a mind that these are the things that you should go through. These are the pipeline that you will end up creating, and keep this entire PDF with you, so that it will keep on reminding you that, okay, where I am, which tool I know. And again, one more thing, from every layer, I'm not saying that you should be knowing about all the tools. No, it's completely fine. Explore it once and then leave it, because once you will start exploring, and once you will be like you will be able to complete maybe till 4th layer or 5th layer, you will be able to find out that yes, now I can try to play with any tools given out there, and I will be able to do the implementation for any tools. So keeping that in mind, this entire slides is prepared for you guys. So hope all of you will be able to make use of this entire slide. These are the layers that we try to create. These are the pipeline. These are the funnel that we try to create. So just try to go through each and every funnel. And this is what I will be doing in a class as a part of Big Data Masters as well. So I'll keep on discovering all of these things, funnel by funnel, pipeline by pipeline, layer by layer, one by one, so that at the end of the day, you will be you will become a perfect data engineer, a big data engineer, right? So with that, guys, thank you so much. This will be available inside your dashboard. And with that, thank you so much. Take care, and see you again in my next lecture again. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about a Hadoop architecture, but by telling you a story in a layman way. I'll try to explain you each and every component, so that you all will be able to remember it, so that you all will be able to give an answer when someone is going to ask you a question inside your interview, or maybe in general. And above all, so when you will try to execute any kind of a job, maybe a Spark job, maybe a Hive job, maybe a HBase kind of a job, maybe a MapReduce job, or whenever you will try to perform any kind of a read and write operation, you will be able to investigate into your job. You will be able to understand that what is happening on a lower level. So this is how I'm going to give you the explanation about entire Hadoop ecosystem in a complete layman way. So don't worry, leave it up to me, and just try to watch this entire lecture, and for sure you all will be able to understand a Hadoop architecture, that how it is going to work, by the way. So let me share my screen, and I believe my screen is visible to all of you. And let's start talking about HDFS, Hadoop Distributed File System Architecture, or precisely I would say Hadoop architecture. Yeah. So let's try to understand that how Hadoop architecture is going to actually work. So see, guys, Hadoop actually works as a master slave architecture. So basically, if I'll talk about a Apache Hadoop framework, or I will say a Hadoop framework, so it is basically a distributed storage and a processing unit. Now, what is the meaning of this distributed storage and a processing unit? How actually it runs a job, how actually it is going to store a data, how it is going to achieve a fault tolerance, how it is going to, or what is even a meaning of a fault tolerance, by the way, how it is going to maintain a replica, or how it is going to work on a commodity hardware. Commodity hardware means a cheap one, right? So which can crash at any point of a time. So how it is going to work and how it will be able to process a massive amount of data. So this is something that you all will be able to understand with the help of Hadoop architecture. So see guys, like I said that Hadoop architecture always try to follow a master slave kind of a architecture. Now, so master will be doing its own job and slave will be doing its own job. It try to follow a core principle that write once and read as many times as possible. So this is the core model, core philosophy Hadoop is going to follow. But everything we'll try to understand, so as we will progress inside this particular lecture. So first of all, let me introduce two major components inside this Hadoop architecture, or HDFS file system architecture, Hadoop distributed file system architecture, right? So the very first component that you will get to know inside a Hadoop architecture is called as name node. Yeah, name node, or you can say this one as a master, and it will be having some sort of a roles and responsibility. And the second kind of a component that you all are going to observe is called as basically a data node. So let me draw 4 data node over here. Yeah, so data node. So let's suppose we have a data node 1, we have a data node 2, we have a data node 3, and we have a data node 4. Yeah. Now, what this name node is going to do, or what this data node is going to perform. So what is the roles and responsibility of a name node? What is the roles and responsibility of a data node? Let's try to understand that particular part, and then eventually I'll be talking about basically a yarn resource manager as well. So a lot of things will come into picture. A secondary name node comes into a picture. Name node with high availability will come into a picture. Zookeeper I'll try to introduce you. So each and everything I'll try to introduce one by one, component by component, so that as a story you will be able to consume this entire Hadoop architecture. Lecture may be going to be a lengthy, but yeah, so once you are going to understand it, once you will be able to understand, believe me, for an entire life it will be with you, and it is going to help you out not just in big data but in many other places as well, because in many other places nowadays we are following a similar kind of architecture. Yeah, so name node we have, and we have 4 data node: data node 1, data node 2, data node 3, data node 4. Okay, fine. Now, what is the roles and responsibility of a name node? What is the roles and responsibility of a data node? All of these 4 data nodes that we have. So let me try to explain you with the help of one simple example. Yeah, one simple example. So let's suppose I have a file over here, right? So let's suppose I have a file over here, and file name is, let's suppose, text.txt. This is a file I have. And size of this particular file that I have written over here is, let's suppose, 300 MB. Yeah. So 300 megabyte of file I have over here. Someone has given me this file. Yeah. And they are asking me that, can you please try to write it down, or like store this particular file in this distributed system? Yes, in this particular distributed system. So how it is going to happen with respect to a name node, data node, and this is how we will try to understand our roles and responsibility of a name node and a data node. So someone has given me a file of size what? So file of size 300 MB. Fine. Okay. Maybe 1 GB, but yeah, I'm going to show you all the calculation with respect to 300 MB. Okay, that's cool. So someone has given me this 300 MB of file, and someone is asking me that, okay, write this file down into your system, right? And in my system, so let's suppose I have this computer. Let's imagine that as a computer, one single computer, although I can configure all of these things in a single computer itself. But let's suppose this is my computer number 1, this is my computer number 2, this is my computer number 3, this is my computer number 4, this is my computer number 5, just in a layman way. Yeah. So all of these computers are basically connected. How? So basically in this manner, so name node, let's suppose, is connected to all of these computers in this manner. So as you can see that these computers are not connected. There is no connection between like these computers in between, or I'm saying that data node 1, data node 2, data node 3, data node 4, but all of these computers are connected to a computer number 1. Kind of in this like a topology, or in this manner it is connected to each other. Now someone is asking me that try to write down this 300 MB of a file. Okay, 300 MB of a file. So Hadoop distributed file system, right? So what it will do, so it will try to distribute this particular file into a different data node, or maybe into a different computer. It will try to distribute it. As of now, let's imagine in this way. Yeah. So basically, whenever you will try to give any kind of a file to a Hadoop system, so it will try to break down these file into a small chunk, basically. Yeah, in a small chunk, so that read operation or write operation will be efficient. So if I'm trying to read a big chunk of the file, it is painful because it is going to consume a more RAM or main memory, you can say, and more CPU, a compute. But here, so Hadoop follows a basic principle that, okay, first of all, I'll try to break down this particular file, the file that is given to me, into a small chunk. Now, what will be the size of that chunk? So initially, the Hadoop initial version, so over there, so we have a configuration, we can configure it basically, but in an initial version, so it was 64 MB of a chunk that Hadoop system was trying to create for whatever file you are going to give. In a later stage, the modern Hadoop, if I'm going to talk about, so here, because now there is a Hadoop 3.x which is running in a market. So here, basically, the block size, it is going to like break down this particular file into a small chunk. And here, we call that as a block size. So in a latest version of Hadoop, so in a latest version of Hadoop, you will be able to find out that block size is 120, my bad once again. So block size is technically 128 megabytes. So one block will be having 128 megabyte, means if I'm giving 300 MB of file, so it is going to break it down in 128, 128, 128. As simple as that, right? So if I have 300 MB of file, so if I'm going to break it down, so I will be having a block 1 of size 128 MB, right? I will be having again a block 2 size 128 MB, right? And then remaining data, so block 3, yeah, block 3. So what will be the size? 44 MB. So if you are going to add it up, it will become what? It will become 300 MB. So I have given this 300 MB of file. Now, the very first thing it will do is it will try to break it down into a chunks, or technically into a blocks. It is trying to break it down in this particular manner. So 128, 128 and a 44 MB. Now, technically I have 3 blocks. So, and like I told you, so why it is trying to break down into a blocks? Because if I'm going to write sometime 1 GB of file, sometime 5 TB of file, sometime maybe a KB of file, it will be very difficult in terms of doing a read and write operation and allocating a equivalent amount of the resources to do that operation. So that is the reason. So what it will do, it will try to basically break it down into a blocks. Okay, that's great. So it is trying to break it down into a blocks, one by one. It is trying to break it down. Now, once it will be able to break down, it will try to take a block number 1. Yeah, it will try to take what? It will try to take basically a block number 1. And then it will try to perform a write operation for block number 1. Not for 2, not for 3 as of now. Let's just try to focus on block 1 of size 128 MB, which is a part of same file. The file which I have passed, basically this test.txt file which I have passed. So it will try to basically like store this particular file. So how this storage is going to happen by the way? So it will try to request, right? It will try to request to whom? It will try to request to a name node, saying that okay, I wanted to store this file, and obviously it has broken down this entire file into a 128 MB. Now name node is going to check. Name node is going to perform some sort of a check. Now what kind of a check it is going to perform? So the very first check name node is going to perform, that if file already exists. If file already exists, so in that case, it is not going to store the same file. As simple as that. Yeah. Then second one, if you are trying to hit a system, so whether you have a permission or not, you have permission or not. Yeah. So it will try to check for basically a permission. And then a third part. So if it is going to perform this to check that, okay, file doesn't exist. This is a new file which I'm trying to store in a particular location, because I'm going to give a location, right, that store this file into this particular directory, and that directory can exist inside my entire ecosystem, entire my Hadoop distributed file system. So once it will be able to perform this check, so it is going to return a list of the block location. So name node is going to return what? So name node is going to return this third number point. And what is this third number point? So list of the block, list of block basically means block number 1, block number 2, block number 3, that okay, this is the size of block number 1, this is the size of block number 2, and this is the size of a block number 3. And we have a multiple slaves, we have a multiple data node. So name node is not going to store, name node is a master. It controls everything, it commands everything, but it is not going to store your actual data. It is going to store a meta information, which I will talk in a later stage. So after some time, so I'm going to discuss about that part as well. So it is going to return a list of the block, for example, block number 1, block number 2, block number 3, and it is going to locate, or it is going to even send a location of a data node. Data node. So in which data node you can store a block number 1, in which data node you can store a block number 2, and in which data node you can try to store a block number 3. Now here comes another problem, right? That it is going to return a list of the block and a data node, but we are talking about a distributed computation, right? We are talking about the distributed computation. Not just that. So we are also talking about a distributed computation with a commodity hardware. Now, what is the meaning of commodity hardware? A cheap hardware, right? Not a very expensive one, not a very dedicated one. A cheap hardware we are talking about means that can go down, that can crash at any point of a time, right? Or maybe we are talking about a data center across a world in a different region of the world. Let's suppose we are talking about that kind of a situation. Now here, so if I'm storing some file, just a hypothesis, right? Just a hypothesis that if I'm trying to store a file into a data node 1, for example, a block 1 I'm trying to store into a data node 1, and if this data node will crash, if this will go down, right? If this will go down, then what? Yeah, then what? That is a reason, right? That is a reason. So it is going to store a data, but by default, so it will try to even replicate the same data across a different system. And that is called as replication factor. Replication factor. So by default, so you can again try to configure these things. You can try to make it 3, you can try to make it 13 or whatever you want. That's completely fine. But by default, replication factor will be equal to 3. What is the meaning of it? Meaning is very simple. That if I'm trying to store one single block, let's suppose a block number 1, if I'm trying to store a block number 1, so I will try to create a 3 replica of block number 1 across a different data node. It's a computer, right? It's a computer by default. Just like imagine that you have a laptop. You have basically 5 laptops. You have connected with each other in one laptop. Name node is working, and other laptop you have named it as a data node 1, 2, 3, and 4. Yeah. So replication factor is equals to 3. Fine. Replication factor is equals to 3. It simply means that it will try to store the block number 1 in 3 different data nodes, so that even one will go down, at any point of a time. I have 2 replica, right? I have 2 replica, and I will be able to create a backup immediately. We'll talk about that, like we'll talk about that story more and more going forward. But yeah, so replication factor. So technically it returns a list of the blocks and a data node, basically pipeline, data node pipeline. It try to return. What is the meaning of this data node pipeline? So whenever I'm trying to store some sort of information, right? So whenever I'm trying to store like this particular part of the information, so maybe my name node has returned that, okay, first try to go to a data node 2, then try to go to a data node 3, and then try to go to a data node 1. So this is the pipeline my name node is going to return, because just for block number 1, just focus on only one single block. I'm not trying to store the whole 300 MB of the data. I'm just talking about a block number 1 over here. Nothing much, just a block number 1. Fine. Just try to focus on block number 1. So it has returned a pipeline saying that okay, so you can try to store it into a data node number 2, data node number 3, data node number 1. Okay, that's cool. So if it has returned, so now this very first block, right, this very first block will go inside a data node 2, right? So very first block, so block 1 will go inside a data node 2, and here, so block BLK1, so block 1 will be stored. As simple as that, block 1 will be stored over here. Now, once it will try to store, once it will be able to store this first copy, so block 1, first copy, fine, first copy, first replica, right? Now, so what was the pipeline? Data node 3. So now go to a data node 3. Now it will be a roles and responsibility, right? So of this block 1, we have stored inside a data node 2. So it's a roles and responsibility of data node 2 to forward this block, because we have a pipeline, right? So data node 3 saying that okay, so I have stored one copy. Now you have to store a block 1 second copy. Fine. Now third one is what? Data node 1. So now it's a responsibility of data node 3 to store this one into a data node 1. So block 1, copy number 3. So all of these 3 is been stored. Now it will try to send a feedback to this one, block data node 3, that okay, I have stored. Then this will send a feedback to this one. This will send a feedback to this one, and this will send, right? This will send a feedback, or you can say acknowledgement, to finally a name node saying that okay, right? So after successfully writing this 3 copy into a data node 2, copy number 1, data node 3, copy number 2, data node 1, copy number 3. So after storing this 3 copy of only block, I'm just talking about block number 1, only this 128 MB of a data. So once it will be able to store this one, so it will try to reply back that okay, so basically it will try to send a ACK, acknowledgement. Yeah, ACK, acknowledgement, it will try to send, saying that okay, I'm able to store it, and same thing will go to my client. So let's suppose my client has given me this file, right, this particular file. So it will try to send back a feedback to the client saying that okay, I'm able to store all of these information into these particular node. So 3 replica I'm able to create. So this is how block 1 write operation will be done. Now same will happen for block number 2, and same will happen for block number 3. As simple as that, right? So for all of this block, whether it's a block number 1, block number 2, or block number 3, so one by one, it is going to follow the exact same process, this exact same process. And once it will be able to store the whole data, then I can say that my 300 MB of a data is been stored inside my HDFS system. So hope this is making sense to all of us, that how data write operation happens inside this HDFS system. Now here, right? So here, if you are going to observe, right? So here, if you are going to observe, so we are not storing any kind of information. We are not storing any kind of a data inside a name node. Name node is trying to do what? So name node is going to receive the acknowledgement, and it is going to receive the ID of the block, the meta information, because we have stored like a block 1 into 3 places, again block 2 into 3 places, block 3 into 3 places, right? So name node is going to store a meta information. Name node is going to store what? Name node is going to store technically a meta information. Fine. Name node is going to store a meta information over here, and technically that meta information is nothing but a block ID. Yes, technically it's basically a block ID, that okay, for this data I have like divided this data into this particular chunk, and now this chunk goes into this particular data node. So ultimately my data node is, which is technically a slave basically here, now it is going to do an actual task, it is going to do an actual work, and it is going to store the final data set. So here, to store this 300 MB of a data, 300 MB of a data, so we are trying to create a 3 replica. So in total we are occupying 900 MB of a hard disk space. Simple, yeah. If I'm going to change a replication factor, so obviously the storage requirement is going to change. It is not going to be same at all. Yeah, it is not going to be same at all. So fine here. So let's try to write it down. So block number 1. So we are able to store into a data node 2 and then data node 3 and then data node 1. Now block 2, we are trying to store, let's suppose, into a data node 1 and then data node 2 and then data node 3. I'm just assuming it. There is no hard and fast rule for this one. Then block number 3, which is having a 44 MB in size. So data node 4, let's suppose, data node 1 and then data node 2. So in this way, I'm trying to store a 3 replica of block 1, 3 replica of block 2, 3 replica of a block 3. And successfully, I will be able to store this. Successfully, I will be able to store it. And after storing it, obviously, I'm going to return an ID. Yeah. So I'm going to store, and then that ID will be available inside a name node. Yep. So this one and this, all of these operations are going to happen not one by one. So it is going to happen in parallel. Why I'm saying in parallel? Because when we have created this 3 block, so name node is going to understand that, okay, we have this particular task and we have a multiple nodes which is available. It will start sending one by one. Parallelly, it will start engaging all of these nodes. It will not wait for a completion of one block and then it will write second block, then it will write third block. So technically, it is going to do all of these operations in parallel. Yeah, it is going to perform all of these operations in parallel. Now, one more thing, right? One more thing. So here, I'm saying that name node is going to store a meta information. Yeah, this is what I'm trying to say as of now. No, it's not correct. Yes, it does store a meta information. I do agree with it, right? But it will not store a meta information directly. Means it will not try to take an update of this block ID directly. Now, what it will do and why it will not be able to take that meta information directly? A reason is very simple. Name node is a first interface or first point of contact, a POC, a point of contact, right? So point of contact for any kind of a job you are going to submit. Maybe a read operation, maybe a write operation, but yeah. So whatever you are going to do inside your entire cluster, name node is a master. So technically name node is a very busy entity or very busy person, right? Now, we are trying to write and we are trying to perform a read operation millions of times, right? Millions of times. So if it will keep on taking or keep on storing a block ID directly, its bandwidth will be choked and it is going to take a time, right? It is going to take a time and it will become slow. So what people have suggested that what if instead of updating an ID or this meta information directly to a name node, what if we can try to do the same operation in some different system and then on a timely manner? So when we'll be having enough meta information, not like one single update, but when we'll be having a update in a bulk, we will try to send it to the name node and then name node will try to, take a multiple update in a bulk. And this is where, right? This is where in this entire ecosystem, secondary name node comes into a picture. So many beginners thinks that secondary name node is an alternative of a name node into this entire distributed system. But again, that's not true. Secondary name node, it looks like name wise that, okay, so whenever name node will go down, maybe like a secondary name node will try to take a charge, but no, it's not going to happen in that way. Secondary name node has been configured. It's been written. So programmatically, it's been designed in such a way that it is not going to take a backup or it is not going to work on behalf of name node, but secondary name node has been designed for a specific purpose called as checkpointing. Now, what is the meaning of this checkpointing? CKPT. Checkpointing. Now, what is the meaning of this checkpointing? So I told you that whenever we are going to store one block, right? So we are trying to store a multiple blocks. We had actually one data out of that 3 blocks, and out of that, so we are trying to store 9 times, right? 9 times. So maybe 9 times we have to update, we have to acknowledge, and there will be a failure because of some like an unwanted situation. So we can't come to a name node again and again and again because it will be a very, very busy person, right? So keeping that in our mind, so people have suggested that, okay, so let's try to create a secondary name node. So where we will try to update a meta information. We will try to update what? We will try to update a meta information. How? Right? How? So inside a secondary name node, you will be able to see a 2 entity. So one entity is basically FSIMAGE, file system image. Its full form is basically file system image. Yeah. And then there will be something called as edit log. Yeah. So there are 2 entities which exist inside this secondary name node. Now, what is the meaning of this file system image, and what is the meaning of this edit log? Again, so let me give you a simple explanation for this one so that you all will be able to understand, right? You all will be able to understand FS image and edit log. So see, we have a lot of updates, right? We have to do a lot of updates, acknowledgement based on the acknowledgement that we are receiving on each and every operation. And this is a very frequent update. So let's imagine that I'm trying to do some update at time t. Yeah, at time t. So till time t, or t is equal to 0. So we have some information available inside my data node. Means we have some files which I have stored as a block inside this data node. So this file system image will be having that information, that meta information, that okay, fine. So in this data node, I have stored this particular block. Now for this particular block, so I have a replica in this data node, something like this. All of this information, all of this meta information will be available till time t is equal to 0. Yes, till time t is equal to 0. Okay. Now after time t0, so if I'm trying to store some sort of information, if I'm trying to do something, right? So all of these, that is something called as transactional log. Yeah, transactional log. So means whatever transaction which is happening inside my entire distributed system, so that will come inside a edit log, a transactional one, right? Transactional one. And basically what happens is that edit logs will be merged. So let's suppose from time t0, we have all the information inside this particular file. Yeah, just consider that as a file, a simple file, right? So till time t0, we have all the information inside this particular file. Now after time t0 till time t10, for this 10 seconds, let's measure that in a second, millisecond also you can measure, that's completely fine, up to you, but I'm just giving you like one scale. So time t is equal to 0th second till 10th second, whatever transactions happens, whatever information exchange or whatever like a metadata that system is able to generate, that will come inside a edit log. That will come inside where? That will come inside the edit log. And then it will be merged periodically. It will be merged means the information till time t0 and then information from t0 till 10. Yeah. And it will try to create a new FS image. Let's name it as T10 till time 10. So this is having an information. Now this operation, this merging, right? So merging this one plus this one is called as checkpointing. Checkpointing. Now this merger depends upon different rules. So we can try to configure that, okay, on this particular time interval, merge it. So it will merge it based on that particular time interval. Or you can say that, okay, so based on this size, so when edit log will be having like this much of size, then try to merge it. Ideally 64 MB we try to consider, right? So based on the time duration or based on the, so based on the time duration and based on the size. So if file size is going to exceed this much, then try to call the merger and then try to create a file system images. So based on that, it will try to perform and it will try to like create a new file system images. And it will be having all the information, the previous one as well as the new meta information which we have created between this time. Now this file system image will be having all the capability to answer all of those questions that has happened between this particular time or till this time, right? Till this particular time. And this operation is called as checkpointing. Okay. And this, all of this happens inside a system called as secondary name node. So hope all of you are able to understand that what is a roles and responsibility of a secondary name node. Okay. So here I'm able to create this file system image, right? Create the file system images. Now my name node is not having any idea that what has happened between this interval, right? My name node is not having, because I have not updated anything into name node, right? And name node always works based on file system image. So whenever you will try to spin your machine for the very first time, right? I'll show you, I'll show you that particular part. Yeah. So whenever you will try to spin your like a machine for the very first time, you will be able to see that it loads a file system image first, because that is the whole that gives a whole capability, right? This is how name node will understand that, okay, fine. So where is what is like available and where it is available. So what and where answer name node, which is my technically a master, will be able to get from where? From this file system image, right? From this file system image. This is like something which is going to happen, right? Okay. So how this file system image will be updated, by the way, how this file system image will be updated, because this behaves like a memory for my name node, right? If this file system image is not available, how my name node is going to respond back? So let's suppose I have a name node, right? I have a name node. So name node is having a file system image till time t0. Yeah, this old one. So old one it is having, fine. Now, so this secondary name node will keep on pinging that, okay, are you available? Are you available? Are you available? And once it will keep on pinging continuously, it will keep on pinging to a name node. So this is my what? This is my name node, a master node, right? So it will keep on pinging, and once it will be able to receive a acknowledgement that, okay, yes, I am available, right? Immediately it will try to update my name node with a file system image till time t0, for example. So immediately, and it will try to delete the previous one, fine. So now in this way, my system is trying to update with my new or latest file system image, and now it will be having a latest meta information. That is the reason I told you that every time it will not come to this name node and then it will try to, update this meta information. Yes, my name node is going to work on a metadata because that's a core capability. Otherwise, it will not be able to work. It will not be able to control the entire cluster, right? But here, right? So now it will be having a file system image, and once it will be having a file system image, it will be able to work. It will be able to work in an amazing way, right? It will be able to work, and it will be able to respond you back. It will be able to give you all the detail that which data is available where, which block is available where, each and everything, it will be able to handle it. So this is where this secondary name node comes into a picture, and this is something called as checkpointing. Yeah, checkpointing. Fine. So hope all of you are able to understand that what is the actual meaning of a checkpointing inside my Hadoop ecosystem. Okay, that's cool. So this is the roles and responsibility of secondary name node. Secondary name node is not going to behave as a backup of a name node. Now, next question you are going to ask me for sure that what if, right? So what if my name node is going down? See, if my data node is going down, that's completely fine. So it will keep on receiving, it will keep on sending a heartbeat, right? It will keep on sending the heartbeat, and if it will stop receiving a heartbeat, it simply means that this data node is down. And if this data node is down, so my name node is already aware about from its file system images, means technically a metadata that, okay, what was the data which was available in this node and where is the backup? Yeah, where is the backup? So it will start replicating it. It will start replicating it, right? So that it will be able to maintain replication factor is equal to 3, because this is something that it has to do. So based on the heartbeat, obviously it will keep on maintaining a 3 replica all the time, right? 3 replica, it will keep on maintaining. Now the question arises over here that what if my name node will go down? Now what will happen? Yeah. So as per the initial architecture, so if name node will be down at that point of a time, so manually people used to spawn the new machine, and then they are going to transfer a latest file system image, FS image, into that name node, and it takes time. So till that time, So your entire cluster will be available only in a read-only mode. You will not be able to execute anything new. Now, so people have suggested that, okay, to avoid this manual intervention, right? To avoid this manual intervention, what we can do? So we can try to introduce something called as high availability HA standby name node. So high availability standby name node. And how it is going to work, by the way? Yes. So how it is going to work, by the way? So there will be two name nodes. So one is, let's suppose, like a active name node. So where I will be having like a FS image. And there will be an alternate which is called as high availability standby name node, not a secondary one. It's a standby. Yeah. So please make sure I'm not writing as like a secondary over here, and don't get confused. Many people gets confused. So let's suppose, right? So let's suppose if my name node is going to be down. So here we have an active name node and high availability name node, and both we are going to connect with a state manager, you can say, called as Zookeeper. So there is a service we try to configure over here called as Zookeeper. Yeah. So whenever this name node will be down, this will be down. This will go down, right? So Zookeeper will be aware about it, because Zookeeper is basically a state or session manager. So Zookeeper will get to know immediately in a fraction of a second that, okay, so my name node is down technically, right? Name node is down. So immediately it will try to switch the entire name node to a high availability name node. And because at the end of the day, it requires a latest FS image, right? FS image. So based on the NFS or based on the general name node, so it is going to push all of those FS images immediately. So this is nothing but a Zookeeper, as its name suggests. So it is just trying to keep a track of each and every services over here. So if my name node service is going to be down, it is going to spawn this machine, and it is going to say that, okay, fine. So now it's your responsibility to behave like a name node. And this happens automatically. So there was a manual approach, and now this is technically called as a automatic approach. And in this way, it will be able to handle a failover of a name node, which is one of the major component inside your entire Hadoop ecosystem or Hadoop distributed file system. So we are able to understand that how we are storing a data, what is the meaning of a name node, what is the meaning of a data node, what is a meaning of a secondary name node, what is the meaning of a checkpointing, what is the meaning of a active name node, what is the meaning of a high availability name node. So now we are able to understand multiple things with respect to this one. Now, so there is another component which I would like to talk about, which is called as basically yarn. So let's try to talk about another component called as yarn. So YARN. Now, what is this yarn? So the full form of yarn is yet another resource negotiator. Yeah. So yarn is basically called as yet another resource negotiator. What is the meaning of this, by the way? So see, whenever we are trying to execute something inside our cluster, so where we have one name node and then we have a multiple data nodes. So this is called as cluster, right? Combination of these 5 components is technically called as cluster. So whenever we'll try to do some sort of a operation, or whenever we'll try to perform some sort of a data processing, for example, so we are trying to do some sort of a data processing, right? We are going to do some sort of a data processing over here. So data processing, and to do a data processing, so we can try to use a different kind of a engine. So one very popular engine is basically a Spark nowadays. Yeah. The previous one was, or initial one was a MapReduce, and even Hive. Likewise, we have a multiple data processing engine. So what we do, so we try to send a code, and data is already available across all of my data node. So we try to send a code, right? We try to send a code over there, and then it will try to execute a code inside all of these data node. So in between in between, by default, yarn comes into a picture. So yarn comes into a picture. So let's suppose I'm trying to process my file, and over there, so I'm trying to, maybe I have written a code inside the Spark, which is going to do some sort of a prediction based on my data, which is going to build some sort of a model, or maybe a prediction it is going to do, or maybe I'm trying to perform some sort of a ED operation, something like that, right? So I have written a code and I'm going to submit that particular code. Now, what will happen? So it will go through a yarn. So first of all, it will go to a yarn, and yarn is basically a resource manager. Resource manager, plus it will behave like a job manager, right? Job manager. And then in a bottom layer, I will be having a HDFS. So HDFS. Now this is just a storage layer. This is just what? Storage layer. So my data will be stored here technically into a data node 1, data node 2, data node 3, data node 4. So here my data will be technically stored inside this particular node. So just like we try to store our file into a Windows system, or maybe a Linux system, or maybe into a Mac system, right? So here, and now let's suppose if I'm talking about the all different kind of operating system. So into a NTFS file system or FAT file system, it is going to store the data, right? It is going to store the data. So similarly, we have a file system. So where in a distributed mode, it is going to store the data, as simple as that. Now, on top of this data, I'm trying to run my code. Yeah, I'm trying to call my code that, okay, try to process this data, because storage is one part. And then when we have to do processing, so obviously I need a main memory, technically a RAM, and I need a compute, technically a CPU, GPU, or maybe a TPU. Yeah, compute I need. So my storage is completely fine, right? My storage is completely fine. But to process any of this data, I need a resources. Resource means CPU and a RAM. Yes. So I need a resources over here. So what this yarn will do, so inside a yarn, right, inside a yarn, you will be able to find out multiple major components. So first component is basically resource manager. Resource manager. So basically it's called as RM and this will exist inside a master node. So wherever you are going to configure name node, so at that same point, so it will be available. Now what resource manager does, by the way, so as it will be available, as this is just a piece of program, I would say, right? So this service will be available inside a master node. Master node means wherever your name node will be, because name node is also a service, right? Name node is also a piece of code. So it will be available inside this master node, my master node, by the way. Yeah. Now what it will do, so it will be having, as it's a master node, so it will be having a global authority on all the resources, because resource will be available in computer number 2, 3, 4, and 5, right? All these are computer technically, and computer means, so every computer will be having a storage, every computer will be having a main memory, every computer will be having what? A CPU, a compute power. Yes, this is what your laptop will be having, right? So your laptop is being like one node. So we have just connected multiple laptop. Now it's become a cluster. Yeah, this kind of a cluster. If I'm going to attach it in this particular fashion, okay, that's again looks cool, right? Again looks cool. So here, what this resource manager will do, so it will be having a global authority, right? It will be having what? So it will be having basically a global authority. It will be having a global authority to manage resources, basically, right? Across all the cluster. So this is one of the component which exists inside your yarn. Yeah. So I'm talking about basically this middle layer, which is a yarn, and which is actually going to execute your job. So any kind of a code that you are going to submit. And function wise, right? So function wise, what it will do? So it will track. So it will track all the resources across a cluster. Across cluster means what is a resource available in data node 1, data node 2, data node 3, and data node 4 as of now, right? As per my this particular cluster. So it is going to track all of these resources. Resources wise, when I say resources, so I'm talking about technically a CPU, which is a compute power and a RAM. Yeah, compute power and a RAM. So this is going to track all of these resources. And then let's suppose if I'm going to submit a job means code. Yeah, job means I'm talking about the code, because technically that is something going to happen. So let's suppose I have written a code in a Spark to perform maybe a EDA operation, as we all understand this EDA operation, right? So the piece of Python code, let's suppose, or Java code I'm going to submit to perform this data processing. Now, so this EDA requires 2 V-core CPU and then maybe a 4 GB of a RAM, right? So this is the requirement of this particular job. Let's suppose I'm going to submit this as a job number 1. Yeah, job number 1 with some job ID. That's completely fine. So let's suppose I'm doing a EDA operation. So for that, I have written a Python code. Yeah, Python code. Now, if I'm going to submit a code, so that code requires, as per the file or as per the data that I have to process and like a kind of a code that I have written. So it requires 2 V-core CPU, 2 CPU and 4 GB of a RAM, right? That is a requirement. Then only this job will be able to finish itself. Now, there must be someone who should provide that like a particular resources, right? Who should provide. So this is where the Yarn comes into a picture, and inside Yarn, we have what? Inside Yarn, we have a component called as resource manager. So which is going to manage the resources. So it is having all the idea that, okay, fine. So in data node 1, 2, 3, 4, like we have this kind of a resources. So it is going to create a virtual container, means there is a possibility that resource is available in only one system. There is also a possibility that resource is available in a different system. So it is going to create a virtual container, which is a combination of multiple systems. And then it is going to allocate that much of resources, which is technically a 2 CPU and 4 GB RAM to that particular job. Right? So it is trying to leverage the whole capability of a cluster. So if resources are not available in one dedicated system, then virtually try to allocate it. Yeah, allocate it, right? And then the second task that it is going to perform, this resource manager is going to perform, that talk to node manager, right? To launch the container. Container means a virtual space which is having a 2 CPU and 4 GB of a RAM, which is required for this particular job. So what is this node manager? Because I haven't talked about a node manager. I'm talking about the resource manager, which is basically a global entity, which is a part of my master node. So in each and every data node, as a part of this Yarn, right? So in a master node, so there will be a resource manager, and Yarn basically controls all of this data node as well, and it is going to control it with the help of something called as node manager. Node manager. So there will be node manager 1, there will be a node manager 2 instance, there will be a node manager 3, and there will be node manager 4, which will be available across all the data node, which is also a part of your Yarn service. So Yarn service will be available even inside a slave nodes, right? And that is something called as a node manager. Now, what node manager does? So node manager is a local entity. So node manager, as its name suggests, so basically node manager, right? So here NM, it will be available per node. So in every node, this node manager will be available. Like I have written node manager 1, node manager 2, node manager 3, node manager 4. What it does, and it is also a part of your Yarn service. So Yarn is a service on a high level. Inside that, there is a resource manager, which is a global program, you can say. There is a node manager, which is a local program, you can say, right? So what it does, so basically in each node, right, in each node, it tried to monitor a resource uses, because see, it is trying to maintain the resource manager, right? At the end of the day, it needs someone, so which will be able to tell on a node level that, okay, what is the availability, what is not. So you can say that this is a lead, which is leading a team, and this is a manager, so which is having a multiple leads, and like it is managing a multiple leads, and lead is trying to manage its own resources. Simple, right? Just like a company structure. So here it is going to track the resource uses. It is going to track a health, that which one is going down, which one is up, and then a container container status. Container means, so whenever you are going to submit a job, so one virtual container will be spawned, one virtual container will be launched, and then someone is supposed to manage, someone is supposed to monitor that container. So if that container is going to fail, it simply means that my job is failing. And if job is failing, so I have to talk to my resource manager. I should say that okay, so this has failed. Now try to understand, or try to maybe launch it again, or maybe do something, right? Do something. So this is something called as node manager. Now the third component you will be able to find out inside this yarn is called as application master. Application master. So it's called as AM. Yeah, application master. So per application, it will be created. Now, what is the meaning of this? So see, resource manager means global. So it will be having access of all the cluster. Node manager means inside one particular node. So data node 1, 2, 3, 4, 5, 6 and so on. There will be a node manager. So node manager 1 in our cases. So technically there will be node manager 1, there will be a node manager 2, there will be a node manager 3, and there will be a node manager 4 on a node level. Now inside that node, so we are trying to do what? So we are trying to write, or we are trying to create a job, means we are trying to execute a program, right? We are trying to execute a code. So over here, there will be application manager comes into a picture. So let's suppose I have submitted one job, one application manager, or like a multiple job, multiple application manager. So on an application label, right? So basically it will be spawned, or it will be activated once per application or job. Simple, try to understand it in a term of job, right? So basically it is going to execute an actual job, it is going to track an actual job, and it is going to monitor, and if it is going to fail, so it is going to report back that okay, fine, so this job has basically failed. So based on the application master which has been created per application wise, means technically an ID which will be created per application wise. So if it is going to fail, so that application ID will be submitted, and it will be said that okay, fine, this application has failed technically. Yeah, this application has failed. So what application master does, so it will be activated, means application ID, it will be allocated per job, whatever job. For example, I have submitted EDA job number 1. So application ID will be submitted. Again, second EDA. So job number 2, that application master 2 will be activated, and then it is going to request. So it will try to request a container, because to run the job, right, to run a job, I need a resource. I already talked about it, right? To run a job, I need a resources, 2 CPU, 4 GB RAM, for example. Yes. So it is going to request a container from whom? From my resource manager, the very first entity. This is the global entity which is responsible for allocating the resources, right? And locally tracking the resources, there will be a node manager, right? There will be a node manager. So this is going to request a container from a resource manager. And last but not the least, so it is going to monitor the task, not all the tasks, monitor the task, the respective one for which it has been created, and it will always try to retry if task is going to fail. And the fourth is what? So fourth component is what? A container. I think I have already talked about the container. So container is nothing but a logical bundle of a CPU and memory. Simple. A logical bundle of CPU plus memory. Yes. So whenever you are going to run some sort of a job, so obviously that is going to run inside the container, means inside the real resources. As simple as that. Yes, as simple as that. So here, so if I have to talk about the complete flow, so let's suppose I have written a EDA code, EDA.python code, right? EDA.python code. And I have to process data which is available inside my HDFS, fine, which is available inside my HDFS. So it will go to what? So it will go to Yarn. Yeah, it will go to Yarn, yet another resource negotiator. Now, so Yarn, what Yarn will do? So Yarn will be having an understanding that, okay, fine. So where data is available, what is the volume of the data, what is the block of the data? It will be aware about each and everything from a name node, obviously, because it's a part of a master node itself, or master architecture itself. So now, so if I'm going to submit this particular job and I'm going to name it as a job number 1, fine. So I'm going to name it as a job number 1. So let's suppose if I'm going to submit a job number 1 in this Python file, and here I have written a code into Spark. Yeah, here I have written code into a Spark. So I'm using a Spark framework to write a code basically to process the entire data. So it will go to Yarn, and every job requires a resources. So CPU and a memory at the end of the day. So based on the data set that you have to process and based on the task that you have written. Okay, so it is going to estimate each and everything. So here your resource manager will come into picture. So from a Yarn itself, your resource manager RM will come into a picture. Now RM is already connected with a multiple, right? So multiple RM is already connected with multiple node manager, which is nothing but a part of a node manager. Yeah. So 1, 2, 3, 4, which is a part of your data node. Physical, like a system wise, if I'm going to talk about. So RM is already connected with the multiple node manager, right? So it will ask a node manager that, okay, so someone has submitted this particular job, and to execute this particular job, so I need 2 CPU, and basically I need a 4 GB of a RAM. So this is the requirement. Now who is going to give? So it will say that, okay, I'll give. It will say that I will give. Fine. It is going to say that I will give. Okay. So if it is not having a 2 GB, 4 GB of RAM, and it is not having a 2 CPUs, so maybe it is going to provide 1 CPU and then 2 GB RAM. Fine. And it is going to provide 1 CPU and 2 GB of a RAM, right? So it is going to combine these two, and it is going to basically call that as a container. And to track this container, so here there will be a application master, AM will be created, so that it will be able to track this particular application, which I am calling technically as a job number 1. As simple as that. Yeah. So this is the virtual container it is going to create, which will be a shared resources between a multiple systems, technically a multiple laptop, you can say, and it is going to execute your job, and it is going to again respond back to a Yarn saying that, okay, fine. So I'm able to do my task. I'm able to do my work. So this is how this entire ecosystem works, guys. In terms of like a Yarn, this is how Yarn is going to maintain the resources. I'm going to show you each and everything, even in my practical example, right? So I'm going to show you that where you will be able to find out all of these detail, but hope all of you are able to understand this entire Hadoop architecture in a very detailed manner. If you have any kind of a question, so don't forget to ping me. I'm here to help you out. I'm here to make you understand. If you're not able to understand any of this component over here, or if you have any kind of a confusion, don't worry. I'm here for you. Till then, take care, everyone. See you again in my upcoming lecture. This lecture is lengthy, but just go through it once. You will be amazed, and you will find it amazing. Literally very amazing. So with that, thank you so much, everyone. Take care. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about a Kafka architecture in very in depth by taking an example of the data set. And if you are going to spend maybe 15-20 minutes of time, you all will be able to understand a Kafka architecture for a very long time. Now, so Kafka is a system which has been developed by, or is a process which has been developed by a LinkedIn, and then in a later stage, it was made as an open source under Apache license. Basically, Kafka was developed to handle a streaming of the data, or kind of a data, so where frequency of in or maybe out is very high. To handle those kind of a event, to handle those kind of a situation, Kafka was developed at that point of a time. So technically, Kafka is called as a messaging system, and again, many big Fortune 500 companies are using Kafka on a regular basis to build a multiple different processes. And even in case of big data, so Kafka plays a very important role, because we have to deal with a lot of data, a huge amount of data, and that too in a real time, in a streaming. So let me share my screen, and let's start talking about Kafka architecture in a step-by-step manner. Like I said, I'm going to consider a data set, and with the help of that data set, I'll try to explain you that how Kafka internally going to work. So let me write it down. Kafka architecture. Okay. Now, so like I said, Kafka is a messaging system. It simply means that you will be able to ingest a data, right? You will be able to ingest a data. Technically, that is called as a producer. So there will be a different kind of a source you can try to attach, and there will be, right? There will be a different kind of a producer, and then you can try to attach on the other end a consumer which will be able to consume a data. And this entire Kafka architecture lies in between producer and a consumer, and everything happens in a distributed manner, a complete distributed manner. So now let's try to understand that we have a cluster. Cluster means we have a multiple computer, a bunch of a computer we have. So here, let me draw this part. So let's suppose we have a cluster, and inside that, so we have, let's imagine we have computer number 1, we have a computer number 2, and we have technically computer number 3. Yes, and it is called as, so it is called as broker. So broker. So let's suppose we have a broker number 1, we have a broker number 2, and we have a broker number 3, and this is called as cluster of broker. So we have a multiple broker, simply means that we have a multiple system over here. Yes, this is what it means, nothing like fancy over here. So we have a multiple broker, and let's suppose we are trying to produce a data. Now what kind of a data we are trying to produce? So let me write it down. So let's suppose there is a e-commerce website, and people are going over a e-commerce website, and they are trying to place a order. Yes, so we have Amazon, we have Flipkart, likewise we have multiple websites. So we go over there, we try to select a product, we try to add cart to the product, we try to do a checkout. So let's suppose we are like dealing with such kind of a scenario, so where frequently people are trying to go and they are trying to do the order. So whenever people will try to do an order, so obviously we'll be having order ID, right? We will be having order ID. So let's suppose order ID is 09182773. So I'm just trying to take a dummy data over here, and then there will be a customer ID. Let's suppose customer ID. So let's suppose customer ID is equal to 42. There will be amount. So let's suppose amount is equals to 1299. Yeah, dollar INR, whatever you want, you can try to select it. And then a status of the order. So basically order is placed. Yeah, order is placed. Now this is information which my system has received. So order ID, so in one packet, let's suppose, or in one message, so this is the kind of a messages which I am trying to receive. Order ID, customer ID, amount, and then a status of a particular order. Now how Kafka is going to deal with this particular message? And likewise, back to back, it will keep on receiving such kind of a messages, or it will keep on receiving such kind of a data. So how it is going to handle, how it is going to deal with it in terms of reading a data, in terms of writing a data. So first of all, write will come into a picture. First of all, it is going to write a data, and then someone can come and someone can try to read a data. But how that is going to happen? I have a cluster over here. Inside my cluster, I have 3 systems: broker number 1, broker number 2, and broker number 3. Just imagine that we have connected like somehow with one of the services, or 3 laptops together, or 3 computers together. In a layman way, let's think in that particular manner. Yeah. So we have to basically store this data, write this data, and then eventually someone will try to read a data. Maybe 1, maybe 2, maybe 3, or maybe n number of team, a different team will try to read this particular data to do their own analysis. Maybe some team is trying to process a data, so they will try to read the same order. Some team is trying to evaluate a revenue. Maybe your like a finance team will try to estimate the revenue, or they will try to check how much revenue we have done. So they will also read a data. Maybe some team is trying to find out some sort of anomalies, or maybe some sort of a fraudulent order, like a placement. So they will try to also read data. Means there can be a multiple team who would like to read a same data, exact same data, right? There is a possibility. Okay, that's cool. So first of all, I will try to write a data, and then eventually different team will try to read a data, which we say as a consumer, right? So as a producer wise, so very first component, which is nothing but producer. So who is my producer? So producer is my e-commerce website, so which is trying to produce a data continuously, and this is the data it has produced. This is one of the data, and back to back millions of transactions I will try to receive. Now, so how I will be able to write down? Like I said, we have a 3 clusters. Now, why we have 3 different clusters? So that we can try to increase a parallelism, right? Another part is, so we can try to create a multiple replica of the data set, so that I will be able to achieve a fault tolerance, because if one broker is going down, I should not lose a data. I should not stop my business. My business should be up and running, and that is possible. So when we have a multiple replicas of the same data. So all of these things we will be able to achieve with the help of this kind of a Kafka cluster. So here, if I have to tell you that what are the major component which comes inside a Kafka. So the first component is nothing but a broker. So broker is nothing but a machine, right? A machine, a server. So let's suppose we have a broker like a 1, 2 and 3. So we have, in our case, we have broker number 1, we have 3 machine, right? Broker number 2, and we have a broker number 3. Okay. Then the second thing come into a picture is called as topic. Now, what is a topic, by the way, right? So topic. So let's suppose we are trying to capture this data. We are trying to store this data, and this is coming from a e-commerce website. So I will name that as a order data. This is the order data, right? So I will name that as a order data. So in this case, topic will become a virtual name that we are trying to give to that data. So this is technically going to be my order data. Yeah, this is going to be my order data. Now there is another thing which comes over here called as partition. Partition. Now what is a meaning of a partition, by the way? So let's suppose back to back, I'm generating a lots of order. So technically a thousands of order I'm trying to generate. Now I have to make this entire process very fast. So to make this entire process very fast, I can't keep all of this data, right? I can't keep all of this data maybe in one single, or I would say in one single, maybe a broker, or maybe in one single row. I can't keep all of this data. So what I will do, I'll try to divide this data, right? So let's suppose if I'm receiving a thousands of such order per second, right? Per second, thousands of order per second if I'm able to receive. So what I will do that to make this entire process faster, I'll try to divide this data into a different partition, a logical unit, you can say, in which I'll try to divide this data. So here, let's suppose I'm going to like say that, okay, so let's try to, and for every topic, right? So for this particular topic, the order topic which I'm talking about, the order topic. So let's suppose I'm going to create P0, P1, P2, P3, P4 and P5 as a partition. So in 6 partition, I'm going to divide this entire data set. Now, so which data will go where? We'll try to understand that particular part, that which data will go in which partition. So it's nothing but, let's suppose it's nothing but technically a book shelf. Let's suppose we have a book shelf, and inside a book shelf, so we'll be having so many different kind of a sleeves, right? So many different kind of a sleeves. So where we can try to place a books, right? Where we can try to place basically a books. So here this sleeves is nothing but a partition. So we are trying to store a books into a book shelf, right? Into an entire book shelf, and the sleeves is going to behave as a partition for me. So here, whatever data will come into a picture, so either go into a P0, P1, P2, P3, P4 or P5. Simple, right? As simple as that. Now, there will be something called as leader and follower. Leader and follower inside a Kafka. So see guys, we have to maintain a fault tolerance. Fault tolerance means even if one system will go down, right? Even if one broker is going down, which is technically a machine for me, I should not lose a business. It must it must be configured in such a way that my business should be up and running. Now to do that, I have to create a replica of the data set. In one broker, if data is available, so maybe I have to maintain and I have to make sure that its replica must be available in other broker as well, right? In other broker as well. So this is the place where leader and follower comes into a picture. So wherever we are going to store a first copy, right? Wherever we are going to store a first copy, that will become a leader. For example, we have one message, only one, right? And thousands of such messages we are trying to process. So here, this message, if I'm going to store into maybe a broker 3, right? Broker 3 in some partition, right? In some partition. So this will become a leader. So this will become a leader, and then let's suppose a second copy I'm trying to store into a B2 and B1. So that will become basically a follower. So first copy I'm trying to store into a broker number 3, and that will become a leader, first copy of the data. Now, so here, basically who is going to control that, who will become a leader, who will become a follower for a particular data set, whatever data set that we are going to store for a particular data set. So there is something called as controller quorum. So previously it was zookeeper, which tried to maintain the states, but now in a modern Kafka, you will be able to find out something called as controller quorum. It's called as K-Raft basically. So what it does, by the way, so it try to control the election of a leaders, and it will always try to maintain the meta information or information about the data itself. So all this metadata will be managed by controller quorum. And then producer, we have already discussed. So producer is someone who will try to produce the data. So let's suppose I have an e-commerce website that will eventually behave like a producer for me, right? Which will keep on producing this order, this particular order. And then there will be a consumer. Yeah, there will be a consumer. So like I told you that we have a data over here. Now it is possible that this data will be consumed, this order data, right, will be consumed by a order processor team, This data can be consumed by a finance team, right? And this data can be consumed by my fraud team, yeah, my fraud detection team. So all of these are this is consumer, this is consumer. So we have, let's suppose, 3 consumer, and likewise we can have a multiple consumer who will be looking for a similar kind of a data. So all of these consumers independently will be able to fetch a same topic, the order, right? The order topic which I am trying to process. So these are the main component you all will be able to find out at any point of a time. Now let's try to understand that how this data will be technically stored. Yeah, this data will be technically stored. So we have this data, right? We will try to store this particular data itself. So how we are going to store this data one by one, let's try to understand it with the help of story. So producer has produced the data, and this is the data which is in my hand. Yeah, in my hand. Now I have to make a decision that I'm going to keep, let's suppose, copy is equals to 3, right? So copy is equals to 3 means replica is equal to 3. Let's suppose replica is equals to 3. Replication factor is equals to 3. Let's suppose this is something which I set, right? I can try to change it to 1. I can try to change it to more than 3. But in general, in an ideal situation, you will be able to find out in a default configuration, replication factor is equals to 3 means same data we are trying to keep inside a system as a 3 copies, 3 different kind of a copies. So this is the data, this order data I have received. Now I have to decide that this will go where, here, here, or here. Again, I have to decide, right? Again, I have to decide that it will go in which partition, because we have 6 partition, right? We have 6 partition. So first I have to decide that this data which is coming over to me, it will go in which system, and inside that system, inside which partition it will go. And then we have to decide that which one will behave as a leader for that particular data, which one is going to behave as a leader, and which one is going to technically behave as a follower. Yeah, which one is technically going to behave as a follower. Fine. So let's try to decide that particular part. So here I'll try to give you this explanation with the simple calculation. Yeah, with the simple calculation. So let's suppose we are receiving a this particular data. Inside that we have a consumer ID. Consumer ID is equals to 42. Now based on this consumer ID value, if I'm going to decide based on this particular key, if I'm going to decide that where my data will go, right, where my data will go. So what I will do, so first of all, I will try to, right, first of all, I will try to basically like select a partition choice. So how I'm going to select the partition? So technically I have 6 partition P0 till P5. Okay. So in which partition it is going to go? Technically in which shelf it is going to go? In our entire book shelf. So we have a multiple sleeves, and in which sleeves it is going to sit, it is going to go. So this is something that I have to decide. So here we are going to make a partition choice. Yeah. And let's suppose this is my key. So this is the key which I have decided that, okay, fine. So I'll try to use this particular key. I can decide something else as well. That's completely up to me, right? So here I have decided that, okay, fine. So this is going to help me out in terms of partition. So here we are going to call hash of basically a key and then percentile of total number of partition, which is 6, right? So this is going to give me a remainder. So if you are going to do 42 remainder 6, it is going to give you what? 42 remainder 6 is going to be 0. So where this data will go? Technically where this data will go? So this data will go into partition P0. As simple as that. Yeah. So this data will technically go inside partition P0. Now, so here partition P0 is completely fine. Yes, partition P0 is completely fine. But in which broker it will go, in which system it is going to go, right? Where this partition, like for this particular data, so which one is going to be a leader broker and which one is going to be a follower broker, that we have to find out. So here, this is the place where this k-raft comes into a picture, the controller quorum comes into a picture, which I have already highlighted. So this is going to assign a leader to each and every partition. So let's suppose I have created 6 partitions. So it is going to assign a leader and it is going to assign a follower. So maybe there is a possibility and there is a chance that it is going to create this kind of a table internally. Yeah, this is going to create this kind of a table. So here, let's suppose I'm talking about this table. So here we have partition, replicas, and we have a leader, right? So we have partition P0, then we have P1, then we have P2, then we have P3, then we have P4, and then we have P5. So replicas will be B1, B2, B3. So previously, in a previous version of the Kafka, it was decided by zookeeper, but now it's technically a controller which is going to decide, or k-raft which is going to decide. So B2, B3, B1, and B3, B1, B2, and then maybe B1, B3, B2, B2, B1, B3, B3, B2, B1. So leader is going to be the very first one, right? So B1, B2, B3, B1, B2, B3. Yeah. So this is going to be the leader, means very first copy will be stored over here, and then it is going to forward a next copy to the next broker, right? Next broker, just to maintain 3 replica. If replica is going to be 7, so in that case, obviously, like it is going to be the 7. The list is going to extend as a 7. So here, let's suppose for a partition P0, right? Partition P0, who is a leader? So basically B1 is a leader. So a very first replica, right? A very first replica of this particular data set, will go where? So it will go over here, right? It will go over here. So order ID 0918273 will go over here, and it will be partition P0. So in a broker 1, it will go, and as a partition P0, a first copy. Now where this second copy will go? Second copy will go into B3 and third copy will go into, second copy will go into B2 and third copy will go into B3. So second copy will go here, right? second copy will go here, and third copy will go here again by maintaining partition P0, and here this is a second copy, this is a third copy, and all of these informations are technically a meta information, information of information, right? That is something called as meta information. So all of this information will be managed and maintained by whom? Your controller, a K-Raft, right? So by K-Raft, it will be maintained and it will be managed, which I have already mentioned. So in this manner, this order will be stored, broker 1, 2, and 3. Let's suppose I have received a second message, right? Let's suppose I have received a second message, and let's suppose over there consumer ID is equals to 43. Now what is going to happen? So again, we'll try to find out the partition choice. So 43 remainder 6 is equals to 1, right? 1. It simply means that it will be stored into where? It will be stored into partition P1. Yeah, partition P1. The another message, right? Partition P1. So who is the leader for partition P1? B2. The very first copy will be stored for partition P1. The very first copy will be stored. So first copy in partition P1 for the second message of this order or topic, right? Order topic will be stored here. Then there is a B2, then B3, and then B1. So second copy. So this is basically partition P1, second copy, and then third copy. So partition P1, right? And this third copy of this data will be stored here. So in this way, this particular data will be stored. So as and when this data will keep on coming, this data will be splitted across a partition, right? Data will be splitted across a partition. Just try to connect all of these things now. So data will be split across the partitions, right? And here, so for every partition, controller has already decided that which one is going to be the leader broker and which one is going to be the follower broker. Yeah, which one is going to be leader broker and which one is going to be a follower broker at any point of a time. So this is how this write operation is going to happen. Now try to understand one more situation, one more scenario over here. So let's suppose I have a key, a customer ID key, and here, so customer ID is equals to 48, right? Customer ID is equal to 48. Now, so if you are going to do like find out the partition of this 48, so 48 remainder 6 is equals to again 0. So technically it's a partition P0, and we know that for partition P0, the follower is going, like a leader is going to be B1 and follower is going to be B2, B3. So obviously this message, the order number, like order ID with the customer ID 48 is going to go inside where? Inside partition P0. And like I said, partition is like a sleeves. So in one sleeve, there can be a multiple books, right? I can keep a multiple books. Let's suppose this is one of the partition. Let's suppose I'm calling it as a P0. Yeah, I'm calling it as a P0. As you can see over here, I'm calling it as a P0. Now, I can have a multiple books here, right? I can have a multiple books here. So now we have find out that this message, the new message or the new data which I have received. So technically it should go to the partition P0. Yeah, partition P0 for the same topic. So here inside a partition, you will be able to find out a concept of offset. It's very simple, right? It's very simple. So let's suppose I have received a first message. So offset is equals to 0. Now I have received a second message. So offset is going to be what? 1. Third message, offset is going to be like a 3. Fourth, 4, right? So offset will be like a done in this way, starting from 0 till the next one. So every message will come and it will be appended inside that partition, just like a book slave. Yeah, just like a book shelf. You can just imagine like a book shelf. Yeah. So we have a book. So 1, 2, 3, 4, 5, 6. So in that partition, in this way, we are going to order. So offset is technically a partition wise entity. For every partition, it is going to start from 0. So technically, and offset of basically like a partition P0 is going to be different from offset of the partition P1. So at offset 5 of partition P0 will be a different data. Offset like a 5 of P1 will be having a different kind of a information. So this is how like a multiple messages will be accommodated inside one single partition, because there is a possibility I am receiving a millions of data, right? So and I just have a 6 partition. So all of this data will go into 6 partitions. It simply means that multiple data is holding inside the 6 partition. So basically we try to give a numbering starting from 0 and we'll keep on increasing by 1 each and every time when we receive a new data set. So technically that is called as offset. So now we are able to understand that how we are going to store message with the customer ID 42, 43 and a 48 inside this entire system, right? Inside this entire system. how it will be stored at the end of the day. So this is basically like a write operation, right? So this is technically a write operation. So now we are able to understand that, okay, how write is going to happen. Now let's try to understand how read is going to happen, and read is technically like a easier than a write operation. Yeah. Because at the time of a write operation, so we are doing all of this processing. At the time of read operation, it's nothing like a fancy, I would say, or nothing complex. We have, let's suppose, a consumer group, this one, and this one, and all of these three are trying to perform a read operation from this particular topic called as order topic, right? So my order processing team has to process the order, my finance team has to calculate the revenue, and my fraud detection team is supposed to detect any kind of an anomaly if there is something in my entire like a order which has been placed. So here, right? So here, let's try to understand how read is going to happen with respect to three different kind of a consumer groups. Here, in terms of reading and information, so as we know that for one single data, so we have a three different kind of a copy. Now we have a consumer over here. So let's call it as a C1 consumer. Let's call it as a C2 consumer. Let's call it as a C3 consumer. So there is a possibility that when this order processing team will come, so they will be able to get maybe information that, okay, this like a order, right? This order is available inside this partition, or maybe this partition inside this particular broker. Then the second consumer will come and they will be able to see that, okay, fine, it's available over here. So they will be able to get an access of this one, and maybe the third consumer will come and they will be able to get an access of this one. So in this way, parallelly, they will be able to read the entire information. Yeah, it will be able to read the entire information at any point of a time. Fine. Now here, so there is something called as retention policy. So in case of a Kafka, we try to define even a retention policy. Retention policy means, so we can't keep all the data set. It's a streaming, it's a messaging system, right, that we're talking about. So generally we try to decide 7 days as a retention policy. Means once data will come, right, once data will come over here, data will be available over here for next 7 days. Yeah, from the day of arrival. Apart from that, right, apart from that, couple of more information I would like to give you over here. So as we are trying to maintain an offset, right, as we are trying to maintain an offset. So whenever consumer will start reading a data, maybe consumer 1, maybe consumer 2, maybe consumer 3, all three in parallel, maybe one by one, depends, right? So whenever they will try to consume the data, and if there is a possibility, right, that there will be a blockage or like there will be a connection blockage situation. So where consumer will stop consuming the data. So with the help of offset for a particular partition, it will be able to remember, it will be able to store a meta information that till what offset we were able to read a data. And whenever consumer will come from the next time, right, it will be able to resume from the same offset from the same particular place. So this is all about a Kafka architecture, guys. So hope all of you are able to understand it and all of you are able to relate it when I'm going to teach you Kafka in practical. And very soon you will be able to see a lecture even with respect to a Kafka practical. But yes, these are the technical things which you are supposed to be aware about. So with that, thank you so much everyone. Take care and see you again in my next lecture. Okay, so welcome back to lecture once again, guys. Now in this lecture, I'm going to talk about a Spark architecture and in very depth. So there are a multiple component which falls inside a Spark, and one by one, I'll try to break down each and every component. That's a part number 1. Now, before that, so we have to understand that why we are going to use a Spark and where we are going to use a Spark. So see guys, a Spark is almost 100x faster than a conventional data processing engine. Technically, Spark is a data processing framework or a data processing engine. So whenever you are dealing with a huge volume of the data in a distributed system, this is the place where a Spark framework comes into a picture and it is going to make your life easy. That's a part number 1. Spark supports basically different programming languages. Spark supports Java, Spark supports Scala, Spark supports R programming language, Spark supports even Python programming language, which is called as PySpark, which we are going to explore. So doesn't matter from which like a programming background you are coming from. So obviously you will be able to use Spark. Not just that. So inside a Spark, you will be able to find out a core Spark module. You will be able to find out a Spark SQL module. You will be able to find out a Spark streaming module. you will be able to find out a Spark machine learning module as well. So it doesn't matter whether you are working as a data scientist, you are working as a big data engineer, or maybe you are just a SQL guy, or maybe you are trying to do a real-time data streaming, you will end up using a Spark. This is how powerful Spark is. And if it is that powerful, so obviously it must be having a sort of architecture, right? To process a data set at the end of the day. And I believe we all should understand and we all should know about that architecture. And that is something which I am going to discuss in this entire lecture. So let me share my screen and let's start talking about it. Plus, you will be able to understand more and more as you will go in depth of the practical, or you will start writing a code, you will start processing a data. But yeah, it's one of the fastest framework, one of the fastest framework available on this planet, so that you will be able to process a huge amount of data in a distributed mode in a easiest possible way. So let me write down over here, guys, that Spark architecture. Yeah. Now, so whenever we talk about a Spark architecture, so the very first component which will come in your mind is called as RDD. So what is the full form of this RDD? So full form of RDD is resilient distributed data set. Now, what is a meaning of this resilient? What is a meaning of a distributed? And what is a meaning of a data set? One by one, let's try to understand. Because whenever you are going to process a data inside a Spark, this is a basic data structure Spark is going to use, and it is going to process your data set. So this is the teeny tiniest, smallest component that you are supposed to understand before understanding a full Spark architecture. So let's try to understand this. Okay, so first of all, what is the meaning of a resilient, by the way, right? What do we understand with this particular meaning called as resilient? So resilient in English, right? So resilient in English, it simply means that a kind of an entity or anyone, so who will be able to recover quickly from a setback or from a difficulties, and that is something called as resilient. So we'll try to understand that why people have given this name as a resilient, right? So why it will be able to, or Spark will be able to recover quickly from any kind of a setback, or how, why and how. So it will be able to recover from a setback quickly. Plus distributed means, so data is available all across a different kind of a system, or different node you can say, or workers, and it will be able to process those data set in a fastest possible way. So here, to understand this resiliency, to understand this distribution, so we have to understand our properties one by one. So see guys, the property of RDD, if I'm going to talk about, so obviously the very first property is what? It is resilient. So it will be able to come back from a setback or from any kind of a disturbance. Technically, it means that it is a fault tolerance that we are talking about. So fault tolerance simply means that let's suppose if I'm trying to perform some operation, for example, so let's suppose I'm trying to process a data. So I'm trying to perform the data read operation, and then maybe on top of that, I'm trying to perform some sort of a filter operation. Then on top of this data, I'm trying to perform some sort of a mapping operation. Then on top of that, I'm trying to perform some sort of maybe count operation. And then I'm trying to maybe print this entire data after processing this entire things. Means reading, then filtering, then mapping, then counting, and then I'm trying to print this data. Now, there is a possibility that when it is trying to process this entire pipeline, so it may break down. Right? It may break down in between. So maybe system will crash, maybe the entire code is going to crash. So till map code is working fine, but when it comes to count, so it is going to crash. Maybe the entire system is going to crash. So when it will try to resubmit a job, or it will try to re-execute a job, so it will be able to come back from a setback automatically. So it will be able to execute, right? So it will be able to start the execution. So it will try to start the execution from a beginning automatically. And this is where this resiliency factors comes into a picture, and how it will be able to achieve it, by the way, how it will be able to achieve a fault tolerance. So basically, whenever you are going to submit a job, for example, this is one of the job I'm talking about, right? So this is one of the job which I'm talking about. So whenever I am going to submit this kind of a job, so internally it is going to create this entire flow that I have created over here. And this entire flow is called as lineage, Lineage, lineage. So this is something called as lineage graph. So whenever you are going to submit any kind of a job, means program obviously, so it is going to create a lineage graph in a very first place. It will not start executing a job one by one. No, not at all. So first of all, it is going to create a lineage graph, and based on that, right? So based on this lineage graph, it is going to create the complete logical plan. It is going to create a complete physical plan, and then it is going to execute your job. So we'll try to come to this logical plan and a physical plan in a later stage. But first of all, try to understand this resiliency property and how it will be able to achieve it. So how it will be able to achieve it? By creating a lineage graph, right? Lineage graph. Now, what is a lineage graph? Nothing but a kind of a logical plan that, okay, I will be doing this, then 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 I will be doing this, right? And it will keep tracking of it that, okay, so this is done, okay, this is done, okay, this is done, okay, this is not done. So it has broken somewhere in between. So it will try to re-execute a job once again because it has already created a lineage graph, right? It has already created a lineage graph. So it will try to take a help from a lineage graph, and it's called as basically fault tolerance, right? It will be able to achieve that fault tolerance. Now, so this is one of the property that you will be able to find out. Now, the second property and the most important property I would say is called as lazy evaluation. Lazy evaluation. So in general, so if we'll talk about any other framework, so what it does, whenever I'm trying to perform, or I'm going to write a code like read a data, right? So it will read a data. Doesn't matter that what we are doing with that data, like a reading. So there is a possibility, right? There is a possibility that I'm trying to read a data, but after that, I'm not doing any kind of a process, right? So in general, I will end up exhausting my resources. In general, I will end up exhausting my network IO. In general, I will end up exhausting my compute, and then even our main memory, right? If I'm loading a data and if I'm not doing it. Plus, let's suppose I have loaded a data, but certain columns or maybe certain records are not required. Maybe I have to apply the filter beforehand before reading a data. So even in that way, I will be able to save a lot of compute power, a lot of network IO, and lot of main memory. So other framework are not handling in that way. But in case of Spark, so like I said, whenever you will try to read a data, so first of all, it will try to create a data structure, which is technically a RDD, and property of RDD is one is resilient, right? By which it will be able to achieve the fault tolerance by creating a lineage graph. The second property is lazy evaluation. Lazy evaluation means what? So let's suppose I'm reading a data, right? But what I will do if I'm just reading a data, so if I'm not doing any kind of things with respect to that data, it's like I'm not doing anything, right? So, and then I'm trying to perform a filter operation, but what after that, right? So basically, I'm trying to read a data, I'm trying to filter a data, I'm trying to perform a mapping operation with respect to this data, I'm trying to perform a count operation with respect to this particular data, right? So basically, this map operation is technically called as transformation operation. So we are doing a data transformation by mapping a data, by filtering a data. We are just trying to perform a transformation operation. So in case of a Spark, there are two kind of operation exist. So one is basically transformation operation. For example, a map operation, filter operation, reduce by key operation, or maybe a flat map kind of a operation, right? So this is basically called as transformation operation. Now, whenever you are trying to perform a transformation operation, so a Spark will never go ahead and execute it because you are not looking for any kind of a final outcome, right? You are not looking for final kind of a outcome. Now, so when it is going to execute a job, so simply means that when I'm trying to call a filter operation, when I'm going to call a map operation, it is trying to create a lineage. Only it is trying to create a lineage graph, nothing more than that, right? But it is not actually executing your data. Means it is not actually reading your data. It is not actually filtering out anything out of the data. It is not actually trying to do any kind of a mapping operation with respect to the data, because these are the transformation operation. So it will try to execute it. So when you are going to call any kind of a action on top of this, and what are the action operation? For example, I'm trying to perform a count operation. I'm trying to perform a collect operation. I'm trying to perform maybe some kind of a saved as a text file kind of operation, right? So these are basically a action. Action means the operation, so which is going to give you the output, right? So this is called as lazy evaluation. Lazy evaluation simply by definition simply means that unless and until I am not looking for a final output, right? So unless and until I'm not looking for a final output, I am not going to execute it. Very simple. So it will not execute this one. It will not execute this one. It will not execute this one unless and until you are not calling this one. It will be a part of lineage, but it is not going to execute it, because execution simply means that you are trying to occupy a resources. You are trying to occupy my network IO. You are trying to occupy my RAM, which is main memory. You are trying to occupy my compute power, right? A CPU, my GPU, you are trying to occupy. So this is how Spark again try to optimize the entire resource planning, right? So RDD is technically a resilient. Resilient means fault tolerant. So even if like it is just going to crash, it's completely fine. With the help of lineage graph, it will be able to recover and it will be able to execute the job. RDDs are technically a lazy execution like a data type. So which simply means that it is not going to execute it in a transformation. So unless and until you are not looking for the final output, technically that is called as action operation. Yeah. So once you are going to basically call the action operation, it is going to execute it, as simple as that. Yeah. So hope all of you are able to understand the lazy evaluation. The third property of RGD is basically distributed. Resilient, second word is basically distributed data set, right? So distributed. Now, what is the meaning of this distributed, by the way? Yeah. So let's suppose I have a cluster, right? I have a cluster and I have a data into a different node. So basically it is going to create the RDD. So maybe I have a data here, 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 here. So technically RDD is going to combine maybe each and everything as per the need, and then it is going to process it. Simple. So from the different system, right? So maybe from system 1, maybe from system 2. So it will try to bring the data and then it will try to process a data. So RDD is basically a distributed. And again, so distributed means I will be able to like get a huge amount of a computation without giving a load on one single machine. So I will be able to execute a process a data set, right? So this is where this distributed comes into a picture. Now, so RDDs are technically immutable. So immutable simply means that the transformation that you have created over here, the lineage graph that you have created over here, you can't change it once you have created, right? You can't change it once it has been created. So maybe you can create a new, but you can't change it. So this is the reason it's basically called as immutable. Immutable. So RDD is technically a immutable entity, means once that lineage graph has been created, once that RDD has been created, you will not be able to mutate it at all. Yeah, you will not be able to mutate it at all. So, okay, this is the property of a RDD. Now, let's suppose I'm trying to process this data, right? I'm trying to perform this operation. So how this operation, let's suppose I have written a code. Yeah, operation means what? So operation simply means that I will write the code to read the data, then filter, then apply, then count, and then maybe try to print it or maybe try to save it. Yeah, this is the meaning of it, right? So let's suppose I'm trying to perform these operations. So how end-to-end Spark is going to perform this entire operation? So let me explain you in a very, very detailed manner now, because the core component we are able to understand. Okay, so let's try to understand the final like overview that how a Spark is going to execute. So let's suppose I'm writing a code. Yeah, so I have written a code. Code for what? So code for the above process. So first of all, read a data, then apply the filter, some sort of filter on top of the data, then map the data, then count, and then maybe try to print it or maybe try to save it. So first of all, I will try to write a code. Now, what will happen with the code? So I'm going to submit this code into a driver program or into a driver, or it's something called as Spark session. So a Spark session is an entry point for any one of us for the very first time whenever we are going to execute a job. So here we are going to submit it to the driver. Driver is nothing but a Spark session, right? So I have written a code. I'm going to submit to a driver program. Now what it will do internally? So internally, right? Internally, it is going to create a logical plan. It is going to create a physical plan for my entire job. Let's try to understand, and then one by one, I am going to break it down that what is technically a meaning of a logical plan, what is technically a meaning of a physical plan, by the way. So here, it will go inside the Spark session, so means a driver program, and then over here, right? Then over here, so it will try to call a catalyst optimizer. So CATALYST, catalyst optimizer. Catalyst optimizer it is going to call. Now what this catalyst optimizer is going to perform? So it is going to create a logical plan. Yeah, it is going to create a logical plan, you can say. And then it is going to call, so then it is going to call a tungsten optimizer. Tungsten, or you can say code gen optimizer. So which is going to basically generate a byte code, which is going to generate a byte code of a physical plan. So this is technically called as physical plan. Yeah. And after this, so once this will be done, so it is going to create something called as direct acyclic graph. So DAG scheduler, it is going to invoke. And then once this DAG scheduler will be like invoked, so this is going to invoke basically something called as task scheduler. Now once this will be done, then it is going to call the executor, right? And inside that, it is going to basically execute the final job, or you can say it is going to call something like a resource manager executor, right? So basically resource manager is going to allocate our resources, and then eventually executor is going to execute it, where internally it is going to run the entire task. It is going to manage the entire block. Now one by one, let's try to connect each and everything and then try to understand each and everything. Yeah. So I have written a code that's cool. That's completely fine for me. Now, so once I'm going to submit a job, once I'm going to submit a code, so obviously a Spark session will come into a picture, and it will try to instantiate a Spark session saying that okay, so I have to execute this particular job. Yeah, I have to execute this particular job. Now, once it is going to say that I have to execute this particular job, then this logical optimizer, which is nothing but called as catalyst optimizer or catalyst rule based step or catalyst optimizer, comes into a picture, and which is going to, right? So which is going to optimize your entire code base or your entire plan in a logical level, right? So basically logical level, it is going to optimize each and everything. For example, right? For example, so if you have written somewhere like, so how logical is going to execute it? So let's suppose if somewhere I have written 1 plus 2, so automatically it will try to replace it with 3, right? Automatically it will try to replace it with the 3, or maybe, so it will try to apply a filter automatically. So let's suppose if you have written something called as greater than 100 or lesser than this one, so it will try to apply those filter automatically, or it will try to filter the entire expression. For example, if I have written, I'm just giving you example, couple of example that how it is going to execute it. So let's suppose if I have written where a is equals to 5 and true, right? True. So internally what it will do? So it will try to convert this entire lengthy logic to where A is equals to 5. Simple. So into a simple logic. So this is how this logical plan comes into a picture. So it will run through the entire code, and technically it will try to convert your entire logic that you have written in an optimized way. And that's the reason. So it's called as optimizer. So our name is Catalyst Optimizer. So it is going to optimize your code in a logical manner. Then once it is going to optimize your code into a logical manner, then there will be a physical plan comes into a picture. Now, what is the meaning of this physical plan, by the way? So this physical plan is nothing but, so here, the entire code, right? The entire code. So what this tungsten optimizer or code gen optimizer is going to do? So this tungsten optimizer or code gen optimizer is going to turn the entire operators into a optimized Java bytecode, so that my code is going to be very, very fast. Let's suppose if I have written code into a PySpark or maybe into R, maybe into a Java. So at the end of the day, it is going to convert your entire code into a optimized Java bytecode. Yeah, it is going to perform, or it is going to optimize this entire code into a Java bytecode. So now if my code is available into a bytecode, so obviously on a low level, it will be able to execute it in a fastest possible manner, right? And this is where the power of, again, Spark comes into a picture. So one from the logical and one from this particular physical. And again, RDD, the basic component that we have already discussed about, right? So here it is going to use a project. So there was a optimization project called as Tungsten project. So here Spark is using a Tungsten project so that it will be able to optimize a heap memory. It will be able to do a better garbage collection, by the way, right? So better garbage collection. It will be able to build even a better cache friendly data layout, right? And eventually it is trying to convert your entire code into a bytecode. So obviously your code will be very, very fast. So this is something that it is going to perform. This is something that is going to perform. Now, once this will be done, right? Once this will be done, then what it is going to do? So till this step, right? Till this step, you can say, till this particular step, you can say that, okay, so it is going to keep, or it is going to happen inside the RDD, right? It is going to happen inside the RDD. For example, so if I'm going to submit the code, so here it is going to read a data. Let's suppose from a distributed system, it is able to read a data and it is able to create a RDD. Now inside that, so obviously it will try to do a logical optimization. It is going to do a physical optimization. So now I have a bytecode which is available to me. Yeah, bytecode which is available to me. Now, so once my bytecode will be available, right? Once my bytecode will be available. So here what it will do. So let's suppose we have to finally process the data, but immediately it will not go for a data processing. What it will do, it will try to create something called as DAG scheduler. Yeah, DAG scheduler. So let's suppose I have a job, right? So I have a job. I'm going to submit a job. Now what a DAG is going to do internally. So let's try to understand DAG a little bit before going into this particular flow. So how DAG is, and what is basically a DAG. So if I'll talk about a full form of a DAG, so it's called as directed acyclic graph. So directed acyclic graph. Now, what is the meaning of directed, by the way? So basically a meaning of directed is execution flow in one direction, right? In one direction, not in two direction. So from input to output, one direction. So this is basically a meaning of a directed. Now, what is the meaning of acyclic? No cycle, means no loop. And graph simply means that there will be a multiple node which is trying to represent a different kind of a job. So this is technically a full form of a DAG. Now where this DAG comes into a picture, so as per my previous diagram, so once our physical plan will be ready, right, then DAG comes into a picture. Now what we have done till physical plan, so we are pretty much sure that we have converted our entire code into a bytecode. This is what we have done till this stage, right? This is what we have done till this particular stage. And then DAG is coming into a picture. This director, like a directed acyclic graph coming into a picture. This DAG scheduler technically coming into a picture. Once we are done with the physical plan. And we now know that, okay, so what we are doing till a physical plan, converting our code into a byte code. So very low level optimization we are trying to perform over here. Okay, so here, after this RDD, which I'm trying to represent, so this DAG will come into a picture. DAG, directed acyclic graph, will come into a picture. And what this directed acyclic graph is going to perform, right? What this directed acyclic graph is technically going to perform. So let me explain you that what it is going to perform inside this entire Spark component one by one. So here, let's suppose we are trying to process our data as per the above requirement. And for that, we have submitted the code. So we are trying to perform these operations, right? And for that, we have written the code. And finally, my code is available into a physical plan. Means code is available as a byte code. Now, the entire Spark is going to listen to a DAG. Whatever way DAG is going to create the execution, right? It is going to execute it. So maybe like some data we have to execute it before, some data we have to execute it after, some data or some code we have to do it maybe at some point of a time once both of this data, both of the previous data will be executed. So this is where this directed acyclic graph comes into a picture, and it says that okay, so I'm going to take a physical plan, means I'm going to take this output of this byte code, right? Output of this byte code. And then I'm going to split it into a different small stages that, okay, first I will execute this, then I will execute this, then I will execute this, then I will execute this. So it is going to split it into a small stages, and it is going to arrange it, right? It is going to arrange it, saying that okay, so this will be executed first, this will be executed second, this will be executed third, this will be executed in a fourth place. This is what this entire DAG operation is going to perform. So simple, right? Simple. So if DAG is saying that okay, so you and you will be executed together, it will be executed together, right? If it is saying that you and you will be executed together, it will be executed together. If it is going to say that you will be executed alone, right? And maybe you will be executed here as well. So it is going to execute in this particular order, and this job will be scheduled as per the DAG. Now this DAG scheduler, DAG scheduler, DAG scheduler is going to arrange your entire job, and then this will go inside your cluster manager at the end of the day. Cluster manager. So if you are running your job into your laptop, so in that case it is going to be standalone. If it is a single machine, it is going to be standalone, or it is going to use Yarn, it is going to use a Mesos. If you are using a Hadoop infrastructure, then obviously Yarn, it is going to use it as a cluster manager, and cluster manager will be responsible for, right? Responsible for allocating you the resources as per the plan that you are going to submit. And how I'm submitting a plan? With the help of DAG. And finally, it is going to do the execution, right? Execution. And then you will be able to get what? So you will be able to get technically a output. So this is a flow Spark is going to follow. This is the complete flow Spark is going to follow. So first of all, it is going to build the RDD, right? Resilient distributed data set. So which is going to be the building block, I would say, for any kind of a operation that you are going to perform inside Spark. Then it is going to perform a DAG, but before performing a DAG, it is going to basically call a catalyst optimizer, which is going to optimize it logically. And then it is going to call a tungsten or CodeGen, you can say. So which is going to convert your entire code into a byte code. And then it is going to create a DAG. So it is going to make an arrangement that, okay, so which one will go first, which one will go second, which one will go third. So in a one direction, in a unidirection. So it is going to create the entire graph. And then finally, it is going to submit it inside the node manager, or you can say a cluster manager. Sorry. So cluster manager, and then it will go for the execution. So once it is going to get the resources. So this is how, right? So this is how this entire process is going to happen, guys. Yeah, this is how entire process is going to happen. And finally, you all will be able to get your output. So this is a complete holistic overview of a Spark architecture. And these are the components you will keep on listening again and again and again. And when I'm going to execute a Spark job, I'll try to show you even all of these components inside a Spark UI. It's possible. It's possible to track each and every stage and what kind of a DAG it is trying to create, what kind of a RDD it has created, and how it is trying to, get resources, how it is trying to execute it, how it is going to give me the output. If job is failing in between, then how this resiliency comes into a picture, which is going to help me out in terms of achieving a fault tolerance. Each and everything you will be able to see it inside a Spark UI, which I'm going to show you. So while taking a practical lecture. So till then, hope all of you have enjoyed this entire lecture. All of you are able to understand this Spark architecture. With that, thank you so much, everyone. Take care and see you again in my upcoming lectures. Okay, everyone, so another lecture about big data. But here, so in this lecture, we are going to talk about a setup. So guys, see, whenever you have to practice a big data, so obviously you have to do a system setup. So where you need a HDFS layer, the lower layer, file system layer. And on top of that, so you need maybe a data warehousing, for example, a Hive. On top of that, so maybe you need a NoSQL based databases, maybe a HBase. You need some other services called as Scoop, called as Flume, maybe to submit a job or to schedule a job, you need a UG. So there are like so many requirements that comes in between. So whenever we try to practice a big data, and that creates a bottleneck because it's very difficult to get all of these things in a local system at once. But I'm going to show you that. I'm going to give you a file. I'm going to share a file with all of you. So where quickly you all will be able to do a setup and you will start doing a practice. Now going forward, I'm going to even teach you that how over a cloud platform, for example, inside AWS, there is a service called as EMR, Elastic Map Reduce. And technically with the help of that EMR, you will be able to set up the entire Hadoop cluster and you will be able to configure without any kind of a hustle. Literally without any kind of a hustle, you will be able to configure the entire cluster and a respective services. So whether it's a Hive or maybe HBase, maybe a Spark, maybe a Flume, maybe a Scoop, everything on top of the HDFS file system layer, you will be able to do it. So that is something called as EMR, which comes inside AWS. Now, if I'll talk about Azure, so inside Azure, so there is something called as HD Inside. So again, you will be able to build a cluster and all of these services you will be able to provision. That will come into a later stage. But as of now, as a beginner, so if I'm going to start, so obviously I have to do a local system setup. And this is the configuration which I'm going to show you is going to come handy for all of you. So where without even investing one single rupees, you all will be able to, you all will be able to do a system setup. Plus this file is not available over the internet as of now. So I'm going to share this entire file with all of you. I'll talk about that. So what file I'm talking about. Yeah. So let's get started, guys. So first of all, I'm using a Windows machine. So there is a possibility that you are using a Linux or maybe you are using a Mac machine. That's completely okay. Minimum 8 GB RAM is required. So if in your system RAM is less than 8 GB, this will work. Maybe this will launch itself, but it is not going to work. It is not going to work in a smoothest possible manner. So make sure that your RAM is 8 GB. Now, if that condition is fulfilled, then very first step that you have to take over here is to download Oracle VM or Oracle VirtualBox. Yeah, so Oracle VM VirtualBox. Now it's available for Windows, it's available for Mac machine, it's available for all the other Linux variants as well. Yeah, so you can try to download a Windows installer over here. Now, once you are going to download this Windows installer, right, which is like a 119 MB in size, not a big one, I would say, right? So then try to execute and install it. Simple, right? So one by one, just execute and install it. So like the way I'm installing it, and click on yes, click on next, click on install. So I have already installed it, but yeah, so with this installation, so I will end up installing a latest version of a VirtualBox. That's a whole thing which matters, right? So once you will be able to install this VirtualBox, which will not take much of your time, then what we need, we have to create, or we have to practice inside a complete Hadoop kind of a ecosystem, right? Where everything is available at one place. Yeah, everything is available at one place. So I have basically something called as Cloudera Quick Start VM. So Cloudera Cloudera was providing a distribution. So I have that distribution. That distribution you will not be able to find out anywhere over internet as of now. So I have already tried. It's available with me since many years, and for teaching purposes I'm using it. And then, like I said, so eventually we'll move into EMR, eventually we'll move into HD Inside. We are going to use even a Databricks for a Spark. But yeah, to do a basic practice, you need Cloudera. And I have Cloudera inside my system. So Cloudera Quick Start VM, and file size is a little bit bigger. Yeah, file size is approximately 6 GB of file. So I'm going to attach a drive link so that you all will be able to download it. But yeah, so once you are going to install a VirtualBox, then try to download a Cloudera. Once you are going to unzip it after download, right, you will be able to see two files. Just click on this first small file. So just double click on this first small file and it will start launching, right? It will launch it automatically. So what it is going to launch? So it is going to launch a Quick Start VM. So how you will be able to launch it? Simple. You will be able to see Cloudera Quick Start VM. Click on Start. So once you're no need to do anything, right? No need to do anything. Everything will be done automatically, right? Everything will be like done automatically. It will take some time, right? It will take some time. So maybe like a 45 second of time, or maybe depends upon the system. So maybe for some of you, it is going to take 2 to 3 minutes of time. Just wait and watch, right? How much time it is taking for me? Not more than 1 minute for my system. But yeah, for some of you, so it is going to take maybe 2 to 3 minutes of time as well. If you're using a 8 GB RAM or 16 GB RAM system, i5 or i7. And quickly, right? Quickly within a couple of minutes, my entire Hadoop ecosystem will be ready. This is how easy it is, right? This is how easy it is. Although I'm going to show so that you can practice. So here, let me tell you what you will be able to practice. So you will be able to practice a HDFS command. You will be able to practice a basic Linux command. You will be able to practice basically, I would say, Spark, but Spark older version is available. 1.6 is available. So you can try to upgrade it to the latest version. You will be able to practice Hive inside this one, Scoop inside this one, MySQL inside this one, HBase inside this one. You will be able to even observe Spark UI. You will be able to observe the entire jobs. You will be able to observe a node manager, and whatever I taught you with respect to a Hadoop cluster or Hadoop architecture, everything you will be able to observe it. You will be able to even practice Uzi over here. And then it's a Linux machine, right? So if something is needed, if you would like to install something on top of it, you can do it. So almost on a verge of completion. Yeah. And like I said, you will not be able to find it over the internet. So I'm keeping this file since many years, so that I can share this with my. You can try to even build a Docker image. But again, so bringing all of those services in one Docker image, it's a little bit tough task, and a lot of things you will have to manage in terms of version and in terms of installation and configuration. So it's better to use a stable Cloudera Quick Start VM. I will even try to show you that how you can try to open up your virtual machine network, and you will be able to transfer a file from a Windows machine or maybe a Linux or maybe from a Mac machine to this machine. So this is a virtual box, right? So this is the separately different instances, you can say, machine inside a machine. So I'm going to teach you that part as well. Not in this video, maybe in a next video, immediate next video. Okay, so welcome to Cloudera. This is a screen that we have been looking for. This is the screen that we have been waiting for. And yes, this screen is available. This is something that you need. It's a Linux machine, so now you can try to update it. You can try to install. You can do whatever you want. You have a machine inside a machine. And here, so if I'm going to open up a browser, right, open up a browser, so you will be able to find out Hue. Okay, Firefox already running but not responding. Okay, leave it. Not an issue. So you will be able to find out Hue, you will be able to find out Hadoop, and whatever things I taught you with respect to Hadoop, I'm going to explain it, don't worry, one by one, each and everything. HBase is available, Impala is available, Spark is available, Uzi is available, Cloudera Manager is available. So everything is available in one single place, guys. Yeah, everything is available in one single place. So okay, it will start. Let me click on Hue, and here the username, which is the default one, is Cloudera. Yeah, I think this CLOUDERA, Cloudera, Cloudera. So basically Hue is nothing but it's a UI interface, and with the help of basically Hue, here itself you will be able to write a query by using a different editor. So maybe a Pig, Java, Spark, MapReduce, Cell, Scoop, Impala, Hive. So just in this UI itself, and it is giving you even a terminal. So if I would like to launch maybe a Hive, so I can try to launch a Hive over here. If I would like to launch maybe a HBase, so I can launch a HBase over here, right? So HBase Cell, so Hive, yes, I'm able to launch. If I would like to launch maybe a Spark, I can launch Spark. If I would like to run maybe a HDFS command, so yes, I will be able to run HDFS command. If I would like to run maybe a pick command, I will be able to run each and everything over here in one single place. And if I would like to run something from Hue, I can run that as well. So Hue is nothing but it's a user interface which has been given to you, a UI interface which has been given to you. As far as this HDFS is concerned, so I can try to observe my name node, I can try to observe my data node, I can try to observe my snapshots, startup utils, which I taught you in a theory, right? So file system image, and then edit log I was talking about, a checkpointing I was talking about. So everything you will be able to observe it in one single place, guys. Everything in one single place. Plus, you will be able to even browse your file from a UI interface. So wherever your file is, you will be able to browse it. You will be able to check it that, okay, fine. So this is the file that I have. And yeah, so everything means literally everything you will be able to observe it with the help of this UI interface. So as we are going to progress, so we will keep on exploring all of these things one by one. This is something that we have to learn, right? So this is, if you would like to learn something about a solar engine, you can learn even that over here. And if I have to maybe update something, so I can come over here and then I can try to update it. And this is how easy it is to set up a Hadoop system. Even in EMR, so it is not going to take much of time, but yeah, it is going to cost you money. Even in case of HD Insight over Azure, it is not going to take much of time. They have made it very, very easy. And doesn't matter whether I'm looking for 2-3 nodes or I'm looking for 200-300 nodes, I will be able to spin a machine without spending much of time, but it will cost me a money. So for practice, this is a best possible environment that you all will be able to see, that you all will be able to get. So we are good with respect to the installation. So in our next video, I'm going to talk about a file transfer basically. So how I can try to transfer a file from my local system to this particular system, because we will end up doing a lot of file transfer in between, back and forth. So this to this and this to this, right? So we will be doing a lot of file transfer. Not just that. So in the, again, upcoming videos, I'm going to even talk about a complete ecosystem introduction, and then a Linux command, and then a HDFS command I will be talking about. Till then, thank you so much everyone. Take care and see you again. Do the setup, do the installation. Okay, so welcome back once again, guys. Now in this lecture, I'll be talking about that. Let's suppose we have a VM, right? So we have already installed a Cloudera. And if I have to transfer a file from my local machine, from my Windows machine to this Cloudera VM, so how I will be able to transfer that particular file? So you have to do a couple of changes. You have to do a couple of settings. And with the help of that, you will be able to do it in a easiest possible way. By default, it is not going to support. So the very first thing that all of you have to do is go to Google. I'm going to attach this particular link, so don't worry about it. So go to Google and try to download a software called as WinSCP. Yeah, so WinSCP for Windows, and you can try to download it. And then once you are able to download it, you will be able to transfer a file from a Windows to a virtual machine to your Cloudera setup, and then vice versa from Cloudera setup to your local machine. You will be able to transfer a file. So first of all, guys, download it and install it from the link which I have given to all of you, right? And once you are able to install it, just try to search for WinSCP. Yeah, so just try to search for WinSCP. So that it's a very small file. So just download and install it. And let's suppose if I am going to open up my WinSCP, right? So this is how. Let me show you the full screen, by the way. Yeah, so how my entire things will look like. Just a minute. So yeah, so WinSCP, fine. So this is how it will look like. Yeah, so here it is going to ask you for, first of all, a host name, and then it is going to ask you for basically a port number. It is going to ask you for a username, and it is going to ask you for a password by default. Yeah, now, so you have to do a couple of changes basically inside your VM itself. So first of all, you have to shut down your Cloudera. You can try to click on file, close, and then you can try to shut down. Once you are going to shut down, so just go to your VMware or your VM setting, by the way. So let me close it. So file, close, and then power off. Okay. So I have just closed it, and I have to get a host name, but I can try to close it, keep it closed as of now. That's completely fine. I'm here inside my VM. So this is my VM Cloudera Quick Start, right? So I can go to a setting. Now inside settings, so I can go to a network. Inside network, I can try to click on adapter 2 and then just enable it. Yeah? By default, it won't be enabled. So it will be like this. So just try to enable it. And then from this list, just try to select host only adapter. Fine. Host only adapter. So this option you have to select and then try to click on save. As simple as that, and then click on start. So once you are going to start, once you are going to spin a machine, then I'm going to show you that how you will be able to get an IP address. So once you will be able to get an IP address, then from WinSCP, you will be able to log in and you will be able to transfer a file from VM to a Windows and Windows to a VM. All of these things you will be able to do it. So just wait for like a couple of minutes, maybe 1 or 2 minutes, and so that my Cloudera machine is going to start. Okay, so my Cloudera VM is up. So maybe I can try to open up a terminal. Let me increase a size a little bit, and then you can try to type IP-ADDR address and show. Yeah. So here it is going to show you this IP address. So it is going to show you even localhost IP address. It is going to show you even this particular IP address. So now this particular IP address is basically required for you to log in into a WinSCP. Let me show you how. So here is my WinSCP, right? So I can try to click on new tab, and what is my host name, by the way? So my host name is going to be 192.168.56.101. So 192.168.56 and 101. I believe this was the one. Yeah, so 192.168.56.101. So 192.168.56.101. Username is going to be CLOUDERA Cloudera. Password is CLOUDERA Cloudera. Fine. And then try to log in. So it will try to connect. And here, so you will be able to find out that on one side, right? This is basically one on side, it is showing you all of these files from a Cloudera, and on other side, so it is showing you all of this file from your local system. So let's suppose if I have to select some like a D drive, and then from D drive, so if I have to transfer some of the file from here to here, so I can try to transfer this file from here to here in a easiest possible manner. So as you can see, this FreshDesk file that I have transferred from here to here, it's available now, right? It's available now. So this is going to make your life very, very easy, guys. So if you have a WinSCP, so that you will be able to transfer a file from here to here in a easiest possible manner. See, I'm able to transfer a parcel file from here to here in a quickest possible way. So WinSCP, just try to install it, try to download it, and keep it inside your system, so that whatever file you are going to download it inside a Windows, you will be able to transfer it easily inside your VM machine, and then you will be able to eventually process it. You will be able to use it. So with that, thank you so much, everyone. Take care and see you again. Okay, guys. So welcome to Euron once again, and welcome to the lecture. Now in this lecture, guys, I'm going to talk about a basic Linux command, because we are going through a big data lecture. So obviously we are going to use a Linux based system, and inside that we'll be having a HDFS, and we should be aware about some of the basic Linux command so that we all will be able to use it in our day-to-day basis. So let me share my screen, and here, so let me close this particular terminal. So here you will be able to find out a terminal icon, guys, and just click over here and you will be able to get into a terminal. Now let me increase a size of the terminal by doing a Control Shift plus plus, and then let's start with some of the Linux command. So see guys, this is a Linux operating system, right? Inside that we have a HDFS. So there are a separate HDFS command you all will be able to find out. And this system, the terminal that you are able to access, so here you will be able to find out a Linux. Inside Linux there is a HDFS. So once I'm going to talk about a HDFS, we'll try to understand it more. But first of all, let's try to understand just a basic Linux command which you will be able to execute. So here the very first command that I would like to discuss is called as pwd, a present working directory. Yeah, so if I'm going to press pwd, so it is going to show me that what is my present working directory. And if I would like to create any other directory, I will be able to create it. So which I'm going to show you very soon. Now here, so first command is pwd, present working directory, and try to practice it at least 5 to 10 times so that you will get used to all of these commands. Now there is a command called as ls. So basically it is going to list all the file into this particular directory, the current one. So in whatever directory you are, in this directory as of now you are available. So here whatever file or whatever folder will be available, so it is going to list down with the help of ls command. So list the entire file over here. Now let's suppose if I would like to list the file but with the details of the file. So here I can try to press ls and then space and then -l. Now this is going to give me basically the complete detail list of the file with a file permission. You will be able to see, so read, write, or maybe execute. So X means execute, and then R means read, W means write, and then wherever you are able to find out this D, it simply means that it's a directory, it's not a file. So wherever we are not able to find out the D, so basically it's a file. So some of the file system we are talking about, but here, so D simply means that we are talking about a directory over here. So it is going to show you like a file permission. First of all, it is going to show you even a size, it is going to show you even a date. So here you will be able to see the file, owner, permission, date, each and everything it is going to show you with the help of ls-l. Okay, that's cool. Now there is another command called as ls and then -a. Yeah, -a. Now, so what A is going to do? So basically A is going to show you all the files which are hidden. Hidden means, so whatever file that you are going to create with an extension or which is going to start with, right, which is going to start with a dot. So it is going to show you all of those files. So here you will be able to find out that files are starting with basically dot. The rest of the things are basically like a folder, but yeah. So here whatever files which is starting with a dot, so it's basically a hidden file, and A is going to show you all of those files. Maybe if I would like to show it in a list way, so I can try to write maybe -la. Yeah, so list and then show me all of these files. So show me the list in a form of list basically, and then show me the file. Okay, that's cool. Now if I have to clear the entire screen, so I can just write clear, clear, and I will be able to clear all the screen. If I would like to see that what in all command that we have executed so far, so there is a command called as history. Yeah, history, and with the help of history you will be able to see all the command that we have executed so far. Fine. Yeah, okay, so again let's try to do clear. Now here, so let's suppose if I have to create a directory, if I have to create a folder, so how I will be able to create a folder? Or let's suppose I have a folder, so let me do ls over here. I have a folder called as documents, and I have to get into this folder. I have to like see something which is available inside this folder, or I have to jump into this folder. So how I will be able to jump? So here I can simply do cd docu, and then you can even try to press tab so that it will be able to do a auto completion. Yeah, auto completion, press tab. So cd documents, and now we are into a document directory. Fine. Now again, if I'm going to do ls, it is going to show me all the file which is available inside a document directory. As simple as that. So cd means change directory. Simple. Yeah. CD means change directory, and you will be able to see like or you will be able to change any kind of a directory inside a Linux system. Now there is a command called as cd dot dot. Now if I have to come one step back, yeah, let's suppose I'm into a directory, let's suppose if I have to come one step back, so I can try to do cd space dot dot, simply means that one step back. Yeah, so one directory back. So here I'm just coming out of the document directory, as you can see. Yeah, document directory. Again, let me go into a document directory. So docu, so cd cd document document directory. Now here if I'm going to do pwd, so what is my present directory? Home Cloudera / document. This is my present directory. And if I have to go one step back, I can do cd dot dot. If I have to go to a root directory, for example, if I'm into a directory, and if I have to go into a root directory, then what I can do, cd space /, and then I will be into a root directory, by the way. And here if I'm going to do ls, so this is my root directory. So where you will be able to find out all this root folders, by the way. Yeah, root folders, by the way. You all will be able to find out. So this is how easy it is, guys. So it's a very intuitive. It's very much easy to understand and again write a command inside a Linux. And once you are going to practice this commands for a couple of times, you will be able to find out that it's kind of a habit that you will end up forming. So this is how this Linux command is, by the way. Okay, so let me show you a couple of more permutation combinations. So as we are into a root directory and we have a home folder, right? Let's go into home folder. Yeah. So now I'm into a home folder. Let's do ls. So inside that we have a Cloudera. So cd cloudera Cloudera. And now if I'm going to do ls, so I'm into a same directory where I had started. Yeah, where I had started. So if I'm going to do pwd, present working directory, so it is going to show me home / Cloudera, as you can see, right? It is showing me home / Cloudera. Okay, so let's clear this out. So now we are able to understand a change directory. We are able to understand cd dot dot. We are able to understand cd /. Everything we are able to understand so far. Now moving ahead. Yeah, moving ahead. So let's suppose our present working directory is this, right? So home / Cloudera, and inside that I would like to create a folder. I would like to create a directory. So here the command is mkdir, make directory. Yeah, mkdir, and here I can try to give a name. So I can try to give a name Sudhanshu, and it is going to create a directory for me. For example, if I'm doing ls, I will be able to find out a directory called as Sudhanshu. Yes. So I will be able to find out directory called as Sudhanshu. Now let's suppose if I would like to get into Sudhanshu, I can get into this one. And let's suppose if I have to create another directory inside the Sudhanshu, so mkdir and kumar. Yeah. So now if I'm doing ls, so there is a Kumar directory inside Sudhanshu. It is able to create. As simple as that, right? Very simple. Now, if I have to go one step back, so I can do cd dot dot. Fine. And if I have to again get into Kumar, I can get into kucd, sorry, so pwd, and I'm into this Cloudera, and cd Sudhanshu, and then cd kumar. I was into Sudhanshu, by the way, right? So if I have to go one step back, cd dot dot, so I will be into Sudhanshu directory. See, so there was Kumar, and now I am into Sudhanshu directory. Fine. So cd dot dot. Now again going into Kumar. Yeah, going into Kumar. Now so pwd. So I am into home / Cloudera / Sudhanshu / Kumar. So I am into this particular directory. Now if I have to go into a root directory, so again cd / and directly I will jump into a root directory. So now if I'm going to do pwd, I'm into a / means I'm into a root directory. Simple as that. Yeah. So I have to get into this directory once again. So how I will be able to go cd and then paste, sorry. So cd / home / cloudera Sudhanshu kumar. Now I'm into again Kumar directory. So jumping between directory is not a big deal, by the way. So I can come from one directory to another directory. I can jump from one to another in a easiest possible manner. Now let me clear the screen. Okay. So now we are able to create a directory mkdir. We are able to jump in between a directory, and most of the time you will be using that. Yeah, most of the time you will be using that. Now, so let's suppose if I have to remove a directory. Yeah, so for example, I am into Sudhanshu directory, and if I am going to do ls, so there is a directory called as Kumar. Fine. There is a directory called as Kumar. So now if I have to delete this directory, or if I have to remove this directory, and for example, this directory is basically empty. Yeah, this directory is basically empty. So in that case, I can call rmdir, remove directory basically, and then I can try to write basically Kumar. And now if I'll do ls, there is nothing. Yeah, there is nothing. Fine, there is nothing. Now, so again, let me create mkdir, one more directory, and kumar1, right? So ls, I'm into this location. So I'm into basically Sudhanshu location. Now let's go one step back. Yeah, let's go one step back. So we know that inside Sudhanshu, right? Inside Sudhanshu, so we have a directory called as Kumar1. Yes, we have a directory called as Kumar1. Now let's try to delete this Sudhanshu now. Will I be able to delete, by the way? Let's see. Yeah, so rmdir, I have written Sudhanshu, and it is telling me that failed to remove Sudhanshu, directory is not empty. So last time it was able to delete it because my Kumar directory was empty. There was no file as such. But this time it is not allowing me, because inside this Sudhanshu, which I am trying to remove as of now, so we have a directory called as Kumar1. So how I will be able to delete a directory? So where we have another directory or maybe another file. So to do that, right? To do that, so you have to call a command rmr. So in a recursive mode, rmr. So just delete this Sudhanshu, and here, so descend into a directory. So yes. So Kumar1, yes, yes. So now if I'll go and check ls, my Sudhanshu directory has gone, and yeah, so it has deleted this entire thing. So inside Sudhanshu, we have a Kumar1, and even Kumar1 is wiped out. Kumar1 has been deleted. As simple as that, right? So now we also know that how we can delete a directory if there is a file which is already available inside a directory. Okay, so now let's clear the screen. Yeah, clear the screen. Now, so multiple times we try to, create a data. We try to create a file. We try to create some sort of files where we try to create write-ups, or maybe we try to write a code, or many things we do, right? Many things we do. So how I will be able to create a file? Let's try to understand. There are multiple ways, and even to write a data and to save a data, there are multiple ways. So there is a command called as touch, and let's suppose if I'm writing test.txt, right? Now if I'm going to do ls, so here you will be able to find out that it has created a file. It has created a file called as test.txt. So touch is a command by which you will be able to create a file. Simple. You are just trying to create a file over here. And we are not keeping anything inside the file. I have just created a file. So only file creation has been done. Apart from that, nothing has been done so far. It is just trying to create an empty file, a pure empty file. It is trying to create over here. As simple as that. Okay. Maybe I would like to create a Python file. So I can try to do touch, and then maybe a test1.py file. Yeah, test1.py file. So here, if I'm going to do ls, I will be able to find out a test1.py file. So any file with any extension, if I would like to create, I can try to create it with the help of command called as touch. Yeah, touch. So this is just going to create a empty file. Okay, that's cool. Now we have a file called as cm_api.py. This is the default file which is available. So I have not created this file. Or we have this JSON file. We have this JSON file. Or if you will go into some other directory, you will be able to find out again different kind of files over here, right? So how I will be able to check that what is a data which is available inside this file? So what I can do cat cm, and then it is going to show me all the data which is available inside that particular file. So cat is a command, by the way, guys. Cat is a command. So cat and then file name, and it is trying to show me whatever things are available inside that particular file. So with the help of cat, you can try to cat it. Cat it means you will be able to see the entire data set which is available inside that particular file. Okay, that's cool. Now we have a case CLEAR, clear. So let me do ls, and let's suppose whatever data is available in this file, right? I would like to copy this data into my test1.py file as well. How I will be able to copy it? Yeah, how I will be able to copy it? So to copy file to file, we have a command called as cp. Yeah, we have a command called as cp, and here I can try to give one file name, a source file name. So from where we are trying to copy the data, and then destination file name I can try to give over here, that okay, so try to copy a data from this file to this file. Command is what? Command is cp. Now let's hit enter, override, yes. So now if I'll go and check my, if I'm going to do cat on test1.py file, I will be able to see the same data, right? I will be able to see the same data over here. Very simple, right? Very simple. So I'm able to move a data of one file to another file with the help of what? With the help of basically cp. Yeah, with the help of cp. Okay, that's cool. Now let me do a clear over here. Let me show you some other situation. So here we have test1.py file. Fine, we have test1.py file. Now I would like to rename this file, let's suppose. Yeah, I would like to rename this particular file. So how I will be able to rename? There is a command called as move command. So I can try to call a file which I would like to rename, and I can try to give a new name to it. Yeah, I can try to give a new name to it. So let's suppose a new name is xyg.py file. So what it will do, it will try to rename this file to this one. Fine. So let's hit enter. If I'm going to do ls, so my test1.py file is gone, right? It has renamed the same file to xyg.py file, the name which I had given. Yeah, the name which I had given. Now if I'm going to do concatenate xyg, you will be able to see the same data, cat basically, not concatenate. So you will be able to see the exact same data. So let me do the clear now. So even move is like completely fine. Now again, with respect to move mb command, I would like to show you a couple of more things. So let me create a directory called as sudh and mkdir sudh, fine, and then mkdir sudh slash kumar. Yeah. So now ls. So there is a sudh directory, and if I'll go inside sudh, I will be able to find out Kumar, right? So this directory is completely fine. cd dot dot. So come into this state, pwd is equals to home/cloud data. So I'm just moving back. Now here, so I have a case where I have to move this xyg.py file. Let me clear my screen once again. Let me do ls. So here I would like to move this file xyg.py file where? To sudh, and inside sudh we have a Kumar directory. Yeah, Kumar directory. So I would like to move that file into that particular directory. So how I will be able to move? Let's try to understand that. So here I can try to write a move command, and which file I would like to move? xyg.py file. Where I would like to move? So I can give sudh/kumar. So inside this directory I would like to move my file. It is telling me that there is no such directory. So let me remove this one. Yeah, it's working, right? So move xyg to py file. Now if I'll go into sudh, if I'll go into Kumar, if I'll do ls, I'm able to find out this xyg.py file. Very simple, right? I'm able to find out xyg.py file. So here cd dot dot. Now ls, my xyg.py file is gone. I have already moved this file from here to the another location. Simple. So this is again, if you have to remove the file, so you can try to call a rm over there, and that's completely cool. Yeah, that's completely cool. Now there is a command. Let me clear my screen. Yeah, there is a command called as echo, and this is my first echo. Yeah. So this echo is going to do some sort of a print inside your terminal. So this is my first echo, whatever text which I have written. So it is trying to print that particular text over here. Now let's suppose I'm going to do a echo. That's completely fine. But I would like to store this one into some of the file. Yeah, ls. So I would like to store this information into file called as test.txt. Test.txt I have already created. Yeah. If not, you can try to create it with the help of touch command, touch. Touch command, you can try to create it. So I would like to do a echo, and I just don't want to print it inside my terminal. So what I wanted to do is that echo. Yeah. So I would like to store that text or store that string into test.txt. So here my name is sudhnshu, and here, right? So here I can try to give a open triangle, right? And it simply means that it is going to override. So if something will be available inside the file, it is going to override it. And here I can try to give a test.txt. Now, if I'm going to do test.txt, cat of test.txt, my name is Dhanshu. So that is already available. That data is already available. Now echo and with single, right? With single triangle is going to override, means whatever data will be available, it is going to wipe out. But let's suppose I don't want to do that. I wanted to keep my previous data and I would like to append a next data on top of this one. So how I can do it? Same command, but here, so I can try to use maybe a double triangle. Double triangle means my name is Dhanshu, right? And I used to teach data. Hit enter. Now if I'm going to do cat test.txt, now see, it has not deleted my previous one. That is also available, and it has appended the next one, the new one which I have sent it to this particular file. So double triangle, yeah, double open triangle. So with the help of that, you will be able to attach a data. Now, so this is fine. Let me do clear now, and let me do ls. Now, touch is to create a file, an empty file, and then with the help of echo, with the help of copy, I will be able to copy a data, or I will be able to echo means append a data, or maybe override the entire data set. That's completely fine. But let's suppose I would like to open this file into an editor. Yeah, I would like to open up this file into an editor, and then I would like to do something. Maybe I would like to add some sort of information inside that. Yeah, how I can do it? So to do that, you can try to use first command called as nano, nano, and then test.txt. Now here you will be able to find out that it has opened up your file into a editor. Now you can try to write whatever you want. You can try to write whatever you want, and then you can try to save it. Simple. So how you will be able to save, first of all? So to save it, just do Control O, right? And it is telling you that file name to write test.txt, just hit enter. And then if you have to take a exit, Control X. So you will again come into your terminal. So nano, Control O, Control X, simple. Control O to save and Control X to exit. Come into the terminal. As simple as that. If you are using nano editor. Yeah, if you are using a nano editor for any kind of a file. Very simple. Now if I'm going to do this cat test.txt, you will be able to see all the data that I have added just now. Yeah, all the data which I have added just now. So in this way, you will be able to open up a file into a nano editor, and then you will be able to edit it. Now, nano is not just the only editor which is available inside a Linux. There is another editor called as Vim. And again, I'm using a test.txt. There is something called as Vim editor. Now hit enter. Again, you will be able to come into the same location and same file, right? And you will be able to see all the data. Now, if I would like to add some data, right? So before adding some data, you have to press I. So I means now you can start inserting the data, start inserting a data. Now to save this data, or to save whatever I have done now, right? Whatever I have done now, as you can see, I'm adding a lot of unwanted data over here. Now to save this one now, what you have to do, so for nano, Control O, Control X. Yeah. For Vim, so escape colon W Q, escape colon, escape tab, sorry, escape button, then colon, and then WQ. So basically it will save and quit. And now hit enter, you will come back to your terminal. So escape colon WQ, simple. That's a sequence that you have to execute so that it will be able to save it and it will be able to come out of this one. Means it will be able to write it and then it will be able to come out of that one. Okay. Now if I'll do cat, so obviously it is going to reflect all the latest information which I have added, or whatever junk information which I have added inside this particular file. Now let's clear it. So let's clear it. Okay, so cleared. Now I have a file, and inside that file there are too many lines, right? There are too many rows, there are too many lines. So if I would like to see only first 10 rows or maybe last 10 rows, so how I will be able to see that? So there is a command called as head. Cat means cat is going to show you all the data. Yeah, but I don't want that. I just want first 5, first 10, something like that. So head, and then I can try to give a number of lines that I would like to see, and from test.txt. So it is going to show me first 5 lines. Simple, first 5 lines. Head means first 5 lines. Now if I have to see last 5 lines, then what I can do? So tail and then test.txt. So last 5 line it is going to show me. Simple. So even if it is going to be empty, that is going to be considered as a line, as simple as that. So last 5 line it is able to show me. So last 5 line, 50 line, 10 lines, whatever you want, you can try to do it. You can try to do it in a easiest possible manner. Now let's talk about like a find operation. So let me clear, and there is a ls, right? So let's suppose if I have to, find some of the file. So how I can do it? Command is find for that. So find dot and space by name I would like to find. So NAME, by name I would like to find. And here, so I can try to give a regular expression kind of a syntax that whatever file which is coming with the extension .txt, just give me those files. Yeah, just give me those files. So it has started searching those files, as you can see, right? It has started searching those files and it is able to show me those files. So whatever file with the extension of .txt, so yes, it is able to find all of these files, right? All of these files it is able to find out inside my current directory. As simple as that. Fine. Now, so here, inside a file, right? Inside a file, let's suppose I'm able to find the file. That's completely fine. Now, inside a file, if I have to search something, right? That whether this is available inside this file or not. So command is what? Command is grep. For example, grep, grep. And here, so I would like to search Sudhanshu. Inside which file? So inside my test.txt file. So yes, Sudhanshu is available. So wherever Sudhanshu will be available, it is going to give you that particular line, right? So grep, and let's suppose if I'm searching for Sudhanshu Kumar, it's not available, right? So it is not going to give you anything, but it is not going to give you even any kind of a error over here. Simple, right? Simple. So grep means if you have to find something inside a file, so you can try to give it to it and then it will try to do a search. Let's suppose if I have to maybe like search all .txt files. So I can write like this one. So grep, and in a case sensitive manner, basically, let me remove this one. So because it will become a case sensitive. So Sudhanshu, and then just do one thing. So try to search all .txt file, all file with the extension .txt, search it. So yeah, it is able to find out only this data. Let's suppose if I'm writing, just try to search for Linux in all file with the extension .txt. There is no such file. There is no such data which is available inside my system. So this is again one of the command guys that you all will be able to find out. Yeah, you will be able to find out. Now let's suppose if someone is not able to understand about grep, if I'm looking for a help that how grep works, so you can try to call a command called as man. It is going to give you a help basically, grep, grep, and it is going to give you the help about a grep, that what grep command is going to perform by the way, and what are the extension of the grep command, because almost all the command inside a Linux comes with the extension. Yeah, comes with the extension. So basically man is going to show you the entire help of the particular things. Yeah, particular things. Now, so here, let me do a clear once again. Let me do ls and let me do ls -l. Fine. Now here we have a test.txt, right? We have a text.txt, and you must be able to see that we have a read write, and the read permission. Now here, so owners will be having all the permission, but let's suppose if I would like to give permission to everyone, whoever would like to access this file, to perform a read, write and execute operation. So to change a permission, I can do chmod, change the permission, chmod 777 means anyone and everyone will be having read, write, all kind of a permission. Yeah, chmod and then test.txt. Now if I'm going to do lsl, right, you will be able to find out that it has changed. So read, write, execute, read, write, execute, read, write, execute, right? So for others as well. So everyone will be able to perform read, write, execute, read, write, execute, and read, write, execute. If I would like to change the permission, that only owner will be able to perform a read, write, execute, but other will be able to perform only read, write. So to do that, chmod 755 and then test.txt. Now if I'm going to show you ls-l, you will be able to find out that only owner is having a read, write, execute, other is having just a read, write kind of a permission. As simple as that, right? Okay. Now, so coming to the next one, yeah. So let me show you a couple of more command, guys, yeah, with respect to a disk. So clear, clear, yeah. Now, so there is a command called as disk free or df command, so which is going to show you that how much your like a directory is available or how much disk space is available, and it's going to show you something in a clumsy manner. Now if I would like to see each and everything in a human readable format, so I can fire a command called as df-h, so that it is going to give you everything in a human readable format. Yeah, so size is basically for this root directory, yeah, so it's this much. For this temp directory, this much. For this directory, this much is the size, and then used is this much, available is this much, used percentage is this much. As simple as that, right? So it is going to show you the human readable format, and here file system information, size information, used, avail, used percentage, mounted on, all of these information you all will be able to find out. Fine, everyone? Yeah. So now if I have to check that what is how much space a directory or file are using into my current directory, so how I can do it? So disk uses -sh dot, so for a current directory, it is going to show you that, okay, so this current directory is trying to use this much, right? This current directory is trying to use this much of space, by the way. Yeah, so this much is the size this current directory is trying to use it. If I would like to show not just for current but for all, so it is going to tell me that, okay, this file is using this much, this file is using this much, this file is using this much, this is using this much. So whether it's a file or directory, it is going to show you a space or size of each and every file. As simple as that. That's very simple, right? Very simple. Now, so most of the command we are able to learn. And if I'm going to do history, there is a like tons of command that we have executed so far, right? Tons of the command we have executed so far. So just try to practice this command, like I said, 5 to 10 times, right? And believe me, it will be on your fingertips, right? It will be on your fingertips, and you don't have to worry about anything. Everything and anything that I have discussed over here, you all will be able to execute inside your Linux machine, any Linux machine, not just inside the Cloudera QStar VM, but inside any Linux machine. So with that, thank you so much, everyone. Take care, and see you again. Just practice once. Yeah, just practice. So with that, thank you so much, everyone. Take care. Okay, so welcome back once again, guys. Now in this lecture, I'm going to talk about HDFS command. So let's get started. So I believe we all have done the installation, and if you have not done the installation, so please go through a video which I have already uploaded, and try to do a setup, try to do an installation, so that you all will be able to execute a HDFS command. Now here we have a Linux system, right? We have a Linux system, and then on top of that, so we have a HDFS, Hadoop distributed file system, and command is going to be a little bit different. So when you are trying to store a file, when you are trying to remove a file, when you are going to search for a file, so these commands are going to be a little bit different with respect to HDFS. Now HDFS is a layer which sits on top of your Linux system, yeah, on a Linux system. So let's get started. Let's try to open up a terminal and let's do Control Shift plus plus so that I can increase a size a little bit, and let's start talking about HDFS command. And these are the only command which is required going forward as we'll progress inside the class. So obviously we'll try to explore more and more HDFS command. So here the first HDFS command that I would like to execute over here is to check Hadoop version. So let me do Hadoop version version. So this is the command, and this is going to give you a version that I'm using as of now with respect to a Hadoop. Now, so generally with respect to a Linux, we try to do ls, and ls is going to list down all the file which is available inside my present working directory. Simple, right? Now, so like I said, Hadoop or HDFS file system is a layer on top of Linux operating system, right? So this is a Linux system. Now, if I have to do a ls with respect to a Hadoop system, so how I will be able to do it? So command for that one is very simple, HDFS, right? HDFS and DFS, and then try to do a same command, try to write the same command. So HDFS DFS hyphen ls and then slash. So this is going to show me all the file which is available in a root directory of a HDFS file system. So Linux is having its own file system, and HDFS is having its own file system. HDFS is sitting on top of Linux, and now by doing HDFS DFS ls is a command coming from a Linux itself, and slash means in a root directory. So here if I'm going to hit enter, it is going to show me that these are the file systems. So benchmark, HBase, Solar, and temp and user and variables. These are the file system, or these are the directories which is available inside my root directory of HDFS. Very simple. So everywhere you have to append HDFS DFS. Yeah. So now let's suppose if I would like to create one of the directory inside a user directory. Yeah. So let me do HDFS ls, HDFS DFS and then ls slash user. Yeah, slash user. So let me check. So what are the file which is available? So here there are so many directories which is available inside this user directory. So Cloudera, History, Hive, Hue, Jenkins, Uji, Root, Spark, all of these directory. Now inside this user directory inside HDFS, if I have to create one more directory, so how I can do it? Again HDFS DFS and mkdir was a command to create a directory inside a Linux. So it is going to be the same command, mkdir, right, slash user slash sudhnshu, and it is going to create one directory inside a user directory. So here you will be able to see another directory, by the way. So let's hit enter. And let's try to check that what is a directory available. So now you will be able to find out that there is a directory called as Sudhanshu which is available inside, right, inside my HDFS file system, not inside Linux, but inside HDFS file system. This directory is actually available. Okay, that's cool. Now let's suppose, right, let's suppose we have to basically place a file, we have to basically store a file inside HDFS file system, and I believe theoretically we have already discussed about it, that whenever you will try to store a file, it will try to break it down into a blocks, and then it is going to store it with the replica factor, right, to achieve a fault tolerance. Now here, so if I have, let me clear my screen, clear, and I have a file, let's suppose called as test.txt over here, right? Now I would like to store this file. I would like to store this file in a Sudhanshu directory inside a user directory that I have created in HDFS, yeah, not in local. So in local it's already available to me, so inside a HDFS directory. So what will be the command? So HDFS DFS and then hyphen put is a command to put any file. So which file I would like to put? Test.txt. Where I would like to put? Inside user, inside sudhnshu. Now hit enter and it will be able to store that file. Now I can go ahead and I can try to check it. So HDFS DFS and then ls, I can try to do ls user slash sudhnshu, and here so it should show me a file called as test.txt. So yes, my test.txt is available now inside a Hadoop system. Yeah, now inside a Hadoop system. not just in a Linux, but inside a Hadoop system, so that I will be able to use a distributed computation. I will be able to use every feature of a HDFS and I will be able to process it. Yeah, I will be able to process it. Okay, so we are able to place this particular file inside HDFS. So by using a put command, right? Put command and file and then destination. So wherever you would like to store this file, so you can try to give a destination, it is going to store that particular file. Now here, so if I have to download that file, if I have to, like, download this file from HDFS to any of my directory, how I can do it? So let's suppose in a local, I'm going to create one directory called as mkdir test. Yeah, so cd test. So now my present working directory in my local is home/cloudera/test, and this file I would like to download. This file I would like to download inside my local directory. So if I'm going to do ls, there is nothing as of now. Yeah, there is nothing in my local. File is available in a Hadoop system. I would like to download it. So what will be the command? HDFS dfs and then get. Put to place a file, get to download the file or to get the file. So get what? So get this particular file. So I can write user /sudhnshu /test.txt. So I would like to get this file. Yeah, I would like to get this particular file in my local. So I can try to just give a /permission denied. Okay, so let me just give a dot over here and then do ls, and now this file is available. Yeah, this file is available to me. As simple as that. Now let's suppose I would like to get this file, but I would like to get this file in a different file system, test something like this .txt. Let's see so whether I can do it or not. So here, see what I'm trying to do. So I'm trying to download this file, yeah, into this new file name that I have given, not with the same file name, but a new file name I have given. Now if I'm going to do a ls, this file is available. This file is available to me, a new file it has created, and now it has copied all the data which was available here inside this particular file. So that is also possible. Yeah, that is also possible. So get to download or get the file. Now let's suppose there is a file which is available over here and I would like to see the content. Whatever file is available in a HDFS, right? Not in local, HDFS. So cat was a command in terms of a Linux. So here I can try to use a same cat command. So HDFS dfs and then cat /user /sudhnshu /test.txt. And it will be able to cat the entire file, and I'm able to see the data, whatever data was available. Yes, it's available to me. I'm able to see all of these data. So cat command was working in my local and it is working even in a HDFS. The only difference is HDFS dfs I have to append so that it will be able to work with the HDFS as well. Fine. Okay. Now, so let me clean the screen. Now I would like to remove that file. Yeah, so whatever file which I have uploaded, I would like to remove that file. So what will the command? For a local, command was rm. For HDFS, it is going to be HDFS dfs, right, -rm, and then user /sudhnshu /test.txt, and it is going to remove that particular file. So as you can see, deleted this file. Now if I'm going to do HDFS and then dfs and then ls /user /sudhnshu, there won't be any kind of a file available. There is no file, right? There is no file which is available over here. As simple as that. Yeah, as simple as that. So here, most of the command, guys, most of the command which was working into a Linux, it is going to work even with respect to a HDFS. The only differences that you will be able to find out is HDFS dfs. Simple. It's a different file system mounted on top of Linux operating system or Linux file system. Okay, now, so let's do one more thing. So let's try to place some file. So let's try to put test.txt into /user /sudhnshu. Let's try to put the file once again. Yeah, and let's do a ls. So this time it should show me the file. So yes, test.txt is available. Now, if I would like to know the block label information with respect to this file, because we know that whenever we try to store our data into SDFS, it try to breaks it down into a block. So to do that, I can write a command hdfs dfs, and then there is a command called as stat, and then percentile o, and then here I can give a file name. So sudhnshu slash test.txt, and it should be able to show me the stats. So this is the block, right? This is the block information it is trying to give it to me. Now, so if I would like to know more about this, so I can try to do one more thing. I can try to call here hdfs fsck, and then here, so I can try to write that give me information about files, give me information about blocks, and then give me information about locations. Yeah. So it is going to give you all of these information with respect to this particular file. Yeah. So fsck is the command, and I'm saying that give me information on file, block, and the location. So it is giving you all of these information. Total size is this much byte, total directory is 0, total file is equal to 1, symlink is 1, total block, average block size is 657. If you are going to take a big file, then it is going to break it down into a block of size 128 MB. Minimal replicated block is equals to 1, because by default I'm keeping replication factor is equals to 1 inside a Cloudera. Now, over replicated block, so all of these information, guys, it is going to give it to you. Very simple, right? Very simple. Now, so like I said, and like I have already discussed, a head command, like I've discussed about the tail command, so it is going to work in the exact same manner without any kind of differences. So hope all of you are able to understand a difference between HDFS and a Linux file system. And whatever is working with respect to Linux, it is going to work with HDFS as well in majority of cases. I'm not saying in all the cases in the exact similar manner, no, but yeah, in a majority of cases it is going to work. So if you are aware about Linux command, you will be able to do the exact same thing even inside a HDFS, but with HDFS DFS, as simple as that. So with that, thank you so much everyone, take care, and see you again in my upcoming lecture. Okay, so welcome back once again, guys. Now in this lecture, I'll be talking about a complete overview of a Cloudera VM. So as we are already aware about Linux command, as we are already aware about the Hadoop command, so let's take a look into this Cloudera VM. So to do that, there is this particular browser which you will be able to find out, a default one. Click over here, and here, so you will be able to find out a multiple option. So first of all, try to click on a very first option called as Hue. For the very first time, if you are going to log in, so it is going to ask you for a user ID and password. User ID is Cloudera, password is going to be Cloudera. So Hue is basically a UI interface which people have created, and with the help of this UI interface, let's suppose I don't like a command line, those black white screen. If I don't like it, I'm looking for something so which is going to help me out in terms of, you know, writing my query using all the services which is available inside my Cloudera. So I can try to use a Hue over here, and you will be able to see a query editor. So if I'm writing a Hive query, I can do it. If I'm writing something for Impala, I can do it. Pig, Java, Spark, MapReduce, Scoop, everything I will be able to do it inside this one, right? This is how amazing this Hue is. And here, so I can just, I'm going to use it. I'm going to use it almost in every section of my classes when I'm going to show you a demo. So here you will be able to write a query. For example, if I'm going to write a Hive query, I can select Hive and Hive will be selected. And here, so you will be able to see a list of all the databases. If you are going to create some database, you will be able to see that. You will be able to see the table, and all of these operations you will be able to perform. Not just that. So if you have submitted some sort of a job, so you will be able to see a job as well. If you have created a workflow, or maybe if you have scheduled something, everything you will be able to see it in one single place, in one single screen, right? That's a beauty of using a Hue. Yeah, that's a beauty of using a Hue. Apart from that, so you will be able to use you will be able to manage a user. So let's suppose if you would like to give an access to some other user, you can try to click on add user, and you can try to add it. You can try to provide a user ID and password, and other user will be able to use it from here itself. If you would like to create a group of the user, you can do it. If you would like to control a permission, you can do it. everything inside this UI interface. So it's an amazing UI interface which has been created for all of us, and I can just go ahead and I can try to use it. Task history. So if I'm going to schedule some task, I will be able to see that particular task from a hue itself, right? From a hue itself. Okay. So this is a user interface which I will be using so many times, right? So which I will be using so many times. Now here, so on this left hand side, if you are going to click on these 3 lines, you will be able to browse a document, files. So let's suppose I'm going to click on documents. So I will be able to browse a document, I will be able to upload, I will be able to download. I can do everything. I can do everything just with the help of this hue. Now the second one which I would like to show you is a Hadoop tab. Again, by default it will be available. I can click on HDFS name node, and whatever theory that we have discussed, you will be able to correlate all of those theory over here. So we had a name node, right? And we had a data node. So it is going to show you all of these information. So how much DFS, like a distributed file system you have used, what is the remaining one, how many number of node is live, how many number of node is dead. Every information you will be able to see. Plus I talked about a FS image, right? And I talked about a edit log. You will be able to see that as well. Yeah. And where this name node is trying to store its FS images, you will be able to see that as well. So all this investigation you will be able to perform from a single browser. Now click on data node. So it is going to show you all of the information about a data node, everything, right? Everything, and at which port this is live, everything you will be able to see it. Now if you are going to click on data node volume failure, so if there is some failure, it is going to show you that report as well. Snapshot if you have taken, so that is going to show you over here. Startup progress, so at a start what it is trying to do. So it is going to load a FS image. I believe this is what we have discussed in theory, that the main power of this name node, or you can say a master node, comes from a file system image. So whenever you are going to spin your machine, so obviously it is going to load a latest FS image, right? It is going to load the latest FS image. It is going to load a latest edit file. It is trying to do a checkpointing concept we have already discussed, right? Checkpointing concept we have already discussed. So again, those information you will be able to find out. Now utility. So here inside this, you will be able to see browse the file system. So for example, just now I have stored in my previous lecture. So I have stored basically a file inside Sudhanshu directory, and that was available inside a user directory. So I can click over here, and here, so there is a directory called as Sudhanshu that you all will be able to find out, right? This directory, and inside this, if I'll go, I will be able to see my test.txt, and this is the block size by default. So, and replication factor is equal to 1, which I'm keeping as of now. If I would like to change, I can change it. But yeah, so if I'm going to click on this file, so there is only one block. This is the block ID. This is the block pool ID it has created. All of these information, you will be able to see it just with the help of UI. Again, with the help of command, you will be able to see the same. But yeah, with the help of like a UI, you will be able to do the exact same thing. And then logs. So whatever operation that you are doing, so for everything, you will be able to see a logs over here. So this is all about a name node. Now, there is something called as secondary name node. So if you would like to get some information about the secondary name node, you can get it over here. Data node, so you can get it over here. So data node is live at this particular port number. Now, Yarn, which was a resource manager. So you can try to even come over here and try to check about a Yarn. Whenever you are going to submit any kind of a, we all know that Yarn is a resource manager, right? It is going to manage our resources. It is going to allocate our resources for all the jobs and all the operations which I'm going to perform. So here we have a Yarn, and you can try to check what in all job you have submitted, what in all job is running, what in all job is finished, failed or killed, and plus a scheduler, right? Plus a scheduler, you will be able to see it over here. Now, so here again, configuration, local log, server, stack, every information just with the help of UI, which we will be using it, right? Which will be using it. Then Yarn resource manager, and then for a node, there is a Yarn node manager. So you will be able to see even information about a Yarn node manager, actual worker node or actual resource where your task will be executed. Then there is a HBase. So HBase is basically a NoSQL databases. So here you will be able to see their information. Impala, so again, you can try to write a query and you can try to check each and everything in a Impala tab. I can do it even from a Hue, right? Plus Spark, so you will be able to see a Spark history server, and you will be able to see all the history with respect to Spark. Uji, so Uji is basically a scheduler. and we are going to use a UZ couple of times inside a classes, inside a lectures. So you will be able to see that as well. So this is all about just a glimpse of this entire Cloudera ecosystem. So anyhow, it's sitting on top of your Linux operating system, right? But yeah, with the help of UI interface itself, you all will be able to access it. You all will be able to browse it, and you all will be able to manage all kind of services just with one single interface without any kind of a hassle. And that is a beauty of a Cloudera Quick Start VM, or Cloudera, you can say Cloudera distribution. So with that, thank you so much everyone. Take care and see you again, guys. Okay, so welcome to lecture once again, guys. Now in this lecture, I will be talking about a Scoop. So Scoop is one of the service which is available inside a Hadoop ecosystem, and which is going to help you out in terms of transferring a data from SQL system to a Hadoop file system, or vice versa, from Hadoop file system to a SQL system. So let's suppose I have a table, and inside a table, so I have so much of data, but I would like to process those data with the help of maybe a Spark by writing maybe a MapReduce code, or maybe I would like to process those data by writing a simple Pythonic code, but that data should be available inside a SDFS system, so that I will be able to go ahead with the distributed computation, because that is a specialty of a Hadoop ecosystem. And this is where Scoop comes into a picture. So it's a very small service, but it's a lethal, it's a very, very impactful and a effective service that you all will be able to find out inside a Hadoop ecosystem. So let me show you a demo about that, by the way. So first of all, guys, you have to open up your terminal, and let me increase a size of my font size of the terminal. Now, so like I said, that Scoop is basically a system, SQOOP, as its name suggests. SQL to Hadoop or Hadoop to SQL. If I have to transfer a data, I can try to write a Scoop job, or I can try to write a Scoop command. Eventually, with the help of that, I will be able to perform this operation. Now, to perform this operation in my system, MySQL must be available. Yeah. HDFS or Hadoop must be available, and Scoop must be available. Now, so if I'll talk about a Cloudera, so this distribution which I'm trying to use as of now, and I have already shown you a setup. So if you have not done a setup for this particular Cloudera system, so maybe you can try to go ahead with the complete setup, and then you can try to do this experimentation. So inside that, all of these things are already available. So MySQL is already available, HDFS is already available, and Scoop service is already available. So you don't have to do any kind of an installation. And even if you are going to spin your EMR cluster on AWS or HD inside on Azure, you will be able to see the exact same thing. Okay. So let's go ahead, guys, and quickly let's try to see the lot of demo in a practical manner. So first of all, I'll have to check my Hadoop version, or Hadoop is available or not. So I'm going to write a command called as Hadoop version. And yeah, Hadoop is available. Similarly, Scoop, and I can try to type Scoop version, and yeah, even Scoop is available, as I can see over here, right? Scoop is also available, Hadoop is also available. Now let's try to log in into MySQL, and then try to see that whether MySQL is available or not. So to log in into MySQL, command is going to be MySQL, and then user is going to be root, right? And then I'm going to log in it through a password. So hit enter, and password is going to be Cloudera, Cloudera, Cloudera. So just type it, it won't be visible. So MySQL is also available. Now let me clean my screen. So inside MySQL, if you have to clean the screen, then you have to write system clear, and it is going to clean your entire screen. Now here inside this MySQL, so first of all, I'm going to create a database. Yeah, inside database, I'm going to create a table, and then inside that table, I'm going to keep some data, and then eventually I'll try to transfer those data. So as I have already discussed, inside MySQL, I'm going to create a table. I'm going to create a schema over here, and then inside that, I'll try to keep some sort of a data. I will be writing a Scoop job over here, right? Scoop job over here. Now this Scoop job is going to take a charge, and it will try to transfer a data from here to here. In a HDFS file system, it is going to transfer data, and eventually we'll be able to verify those data set. Okay, that's cool. So let's go ahead, and first of all, let's try to create a database over here. So create database, and if not, EXISTS, if not exists, S by the way, and then retail database I'm going to create. Okay, so now retail database is available. I can even write so data bases, so databases. So these are the database which is already available, and out of that retail is one of the database which is available to me. I can try to use this database. So use retail, use retail, and don't worry, I'm going to give you all the command inside a file so that you won't be like doing anything by typing this, all of these things. Maybe you can do a copy paste and you can do the experimentation, and this is how we should do it, right? This is how we should learn it. So here, let me clear my screen. So system clear, and yeah, so database is ready and I have already selected a database. Now let's go ahead and let's try to create a table over here. So first of all, guys, I'm going to create a customer table. So here, let's create a customer table, and inside this customer table, I have a column called as ID, I have a column called as name, I have a column called as email ID, I have a column called as created at, and ID is basically auto increment column, right? So it will try to like, as we are going to insert the data, so it will keep on incrementing the entire ID. Now let's try to insert some of the data. So insert into customers, and here name, email ID, created at. So name, email ID, created at. So these are the information which I'm going to insert. Like I said, ID is in a auto increment mode, so it will be able to insert the data automatically. Okay, so it has updated. I can try to even check. So select star from customers. Yeah. So customers. Now there is a data which is available to me. Some of the data which is available to me. Fine. That's cool. Now let's go ahead and let's try to create another table. And let me do a system clear, by the way. System clear. Okay. So let's go ahead and let's try to create another table called as order table. Yeah, order table over here. Now inside order table, I have a ID column, I have a customer ID column, I have a product column, I have a quantity column, I have a price column, order date column, status column, and then this table is basically connected to the previous table which I have already created, right? So customer table. Okay. So order table is already created. Now once it is created, let's try to insert some of the data. Fine. And let's do select star from ORDERS. Yeah, orders. So even inside the order table, I have a data, and even inside the customer table, I have a data. So I have created basically two tables. Although it's not required, I can try to do experimentation even with respect to one single table, but that's fine. I have just created two tables, and inside that I have inserted the data set. Okay. Now, so once I'm able to insert data, right? Once I'm able to insert a data, now what? Now what? So as per our like, I think it's became messed up. So let do one thing. Let me open up my Scribble link, right? Over there, I can try to like show you the exact same thing. Okay. So yeah. So here, like I said, so inside my SQL system, we are able to create two tables, right? One is a customer table and one is basically order table. Yeah. Now, so I have to, excuse me, I have to write basically a scoop command, so that it will be able to transfer a data from MySQL to HDFS file system. Fine. So this is the requirement that I have. So I have to write a scoop command, and with the help of that, I will be transferring a data from maybe one of these table to a HDFS. And in that way, I will be happy, right? I will be happy. I will be able to run the experimentation. Now to do that, right, inside HDFS, so let's go ahead and let's try to create a directory. Yeah, let's try to create a directory, by the way, so that I will be, transferring all the data inside the directory. So let's try to open up another terminal, right? And I'll just leave my SQL terminal as it is. And here, so I have already prepared the command, and I think we all are aware about HDFS mkdir command, right? So I'm just trying to create a mkdir, and then here, so I'm going to create a directory, right? I'm going to create a directory. So, okay, let's go ahead and let's try to create a directory over here. Now, if I have to cross check that whether this directory has been created or not, So I can do ls and then I will be able to cross check. So let me remove this p. Okay. So yeah, it is not giving me any kind of error. It simply means that this directory is already available. If you have to cross check once again, so maybe you can remove the last folder name and then you can try to check. And this basic import directory is already available over here. Fine. Okay. Now what is next? So once my directory is already available and scoop service is already up and running inside my system, so I can try to do a scoop import. But before doing that, let me explain you this scoop import, how it looks like, by the way. So what scoop import is going to do? So a scoop which is going to invoke your scoop services, and here I'm writing in import. Now to import this entire scoop, so you have to basically connect. So here I'm going to like call JDBC MySQL. It is running inside my Cloudera and at 3306 port. And I'm trying to hit a retail database. Yeah, I'm trying to hit basically what? I'm trying to hit basically a retail database over here. So it will be able to connect. And then I'm trying to provide a username. Username is root and my password is basically Cloudera. So these are the information I'm trying to provide so that it will be able to see my table inside a database, right? And here I'm providing a table name. So now it will be able to connect. It will be able to see the table. So this is one part. Then here I'm trying to provide a target directory. Means, okay, do one thing. So go to this database, go to this table. I have already given you a user ID and password. And then we are giving a target directory that, okay, so just try to transfer the data from that MySQL or the SQL table that I have created to this particular directory. And this directory is basically a HDFS directory that we have created just now, right? So this is a directory that we have created just now. And here, so number of mapper means a number of executor which you are supposed to call is equals to 1. You can try to give multiple mapper. That's completely fine. Field terminated by a tab, right? And then compress. So now if you are going to execute this scoop import inside your Cloudera VM, it is going to, right? It is going to start a job and it will take some time, right? It will take some time. It is going to run the mapper and everything will be visible to all of you. And one by, so as you can see that it has started running a job, right? It has started running a job and it has started calling a mapper and reducer. And again, so if you will go inside your browser, right? If you'll go inside the browser and if you are going to check that what and all jobs are running, so you will be able to check that particular part as well. Yeah. So snapshot startup progress, that's completely fine. Let's go inside a okay, so now if you will go inside a Hadoop Yarn resource manager, you will be able to see a cluster job. And let's suppose if I'm going to click on finish job, so I'm able to see that yes, it has called this application, and it is trying to run some map reduce job, right? And status is basically finished. You can try to check, you can try to run it once again, and then you will be able to check it once again that in a new job, so it has been submitted. And again, the status will keep on changing. Status will keep on changing automatically as my job is going to progress. And I can try to click and then I can try to even dig deeper into that particular job. I can even try to check its respective log. So here now if I'll go back this one, so it is telling me that, okay, so it has done all the operation and I'm able to see all of these logs, how many byte it is trying to read, and then it is able to write what was the job ID, each and everything I will be able to see it over here, right? Each and everything. Now I have to cross verify that whether my data set is available or not. Yeah, I just have to cross verify. Now to cross verify, maybe I can do a Hadoop ls and ls into a basic import. Fine, Hadoop ls into a basic import. Let me decrease a size one step back. Okay. So here, if I'm going to check this directory, you will be able to find out that there is a folder it has created called as order.txt. And I believe this was the folder which I have asked it to create, right? Order.txt. Now, if I'll go and do a ls of this order underscore text text, I will be able to see my file. Okay, so it was orders, not order. So yeah, now I'm able to see this file, right? So it has basically created this file and part file basically, and it is able to store a data over here, right? It is able to store a data over here. So this is how I'm able to transfer data, guys. So successfully we are able to run the job, right? Successfully we are able to run the job. Now, if I would like to see some of the data which is available here, so I can try to do even HDFS DFS cat command, and cat command is going to give me some of the data which is available inside this particular file. Now the reason is very simple. Why my file is available into a compressed format, because when I was running a command, so I have given this compress. Now if I'm going to run a command without this compress, for example, right? So without this one, so it will not try to create a zip. It is going to create a part file, because if data is available into a zip, I have to unzip it, means I have to bring it to a local and then I have to unzip it. Then only I will be able to see the data. So let's run this command once again. And once again, it will go to my SQL system. And in between, so I can, okay, so data order txt already exists. That's a problem, not an issue. So let me do one thing. Let me delete that, or maybe I can try to change my command over here. So order text, so make it S over here, right? Make it S so that it will be able to run. So clear clear, and then try to run this command. It is going to create a directory called as orders txt, and inside that it is going to save the job. Now if I'll come over here and if I'll just try to check that what are the new job which has been submitted, or what is like a job which is running as of now. So you will be able to see there is one job, there is one application ID which is still running, right? It is running inside the container, and yes, we are running the job, and now it has been finished. Yeah, now it's been finished. Now it is able to store all the data inside that particular directory. Okay, that's cool. Now if I have to see the data, that what kind of a data it is able to load inside this one, I can do one thing. So I can try to write HDFS DFS basically, and ls, and then this directory. Yeah, so it should show me the part file. Yeah, this time it has not compressed it, so it is showing me basically a part file. Okay, that's cool. Now if I have to check that what kind of a data which is available inside this part file, so I can try to check that as well. So let's do it. So here I'll just change this ls to a cat. Let's change it to a cat, by the way, cat, and then at the end give this complete path of this file. Yeah, so here order slash, not here, so at the end order slash, and let me move my screen. Yeah, so here slash text, and file name is part hyphen m hyphen 1 2 3 4 5. Fine, let's do it. So yeah, this is the data, guys, that we are able to see, right? This is the data which it is able to store into a part file format, and part file is nothing but it's a HDFS file format. So successfully we are able to transfer a data from a MySQL system to a Hadoop system. We can do it vice versa as well, which I will show you in a later stage. But yeah, so successfully we are able to transfer our data from one system to another system, and that looks cool to me. That looks cool to me. So successfully we are able to do the experimentation with respect to a scoop system. With that, thank you so much everyone. Take care, and see you again. Okay, so welcome back once again, guys. Now in this lecture, I'm going to show you that how you will be able to transfer a data from a SQL system to a Hive. So again, Hive is a data warehousing solution, data warehousing tool, which sits again on top of HDFS system, and Hive will be able to process a data, right? You will be able to create a complete dump inside a Hive, and then Hive will be able to call internally map reduce operation, and then it is going to process our data in a fastest possible manner. So here inside my SQL system, I already have a data, right? I already have a data which I have already shown you. Now what I have to do is that I have to transfer those data into a Hive table, and automatically it should create a Hive table. So let me talk about a scoop command for that first. And it's a very easy command, I would say, right? So here, command wise, if I have to transfer a data from scoop to Hive, so these are the connections. So let's suppose I am like hitting my customer table, and here, so you have to write Hive import, and then I'm going to pass a parameter called as create Hive table, and Hive table name is retail customer table, and number of mapper is equal to 1. So only this much you have to do. Rest of the things are completely okay, and it is as equivalent to the previous one, right? As equivalent to the previous one. So here, let's try to call this one, and I'm going to paste this command. That's it, and let's run it, and it will be able to basically transfer a data into a Hive table. And yeah, so it has already created a job. My job is running. Let's see. Just wait for some time. Okay, so now my log looks good, by the way. And yeah, so time taken this much second, and successfully I believe it is able to transfer the data. Now I can go into a Hive and I can try to check. So let's go into a Hive. So just try to like write Hive over here, and it is going to give you a Hive terminal. So now we are into a Hive. System clear. Okay, so clear is CLS. Okay, not an issue. Let me check the command. So shortcut is basically Control L. I can try to write, and it is going to clear my screen. Now here, so if I'll come and if I'll try to check that show tables, yeah, so tables. So retail customer is a table, and I believe this was the table which we have created, right? Retail customer table we had created. And now if I'll go and check that select star from this RE TIL retail underscore CUSTOMERS customers. So it should show me a data, and yes, it is showing me the data. So successfully from a SQL system, my data was available into a SQL system, and from a SQL system, I'm able to transfer a data into a Hive by what? Just with the help of Scoop, right? Just with the help of Scoop services. And command wise, I don't think that any one of you will find any kind of a difficulties with respect to the command, right? It's just a scoop import that we are trying to do. Nothing much, by the way. So with that, thank you so much, everyone. Take care, and see you again in my next lecture. Okay, so welcome back once again, guys. Now in this lecture, I'm going to show you that how you will be able to achieve a parallelism inside a scoop, basically scoop data transfer. So here again, I have a same continuation of the example. So let's suppose I'm talking about this scoop import. Yeah, this is scoop import. Now, technically what we have changed over here. So obviously I have changed a directory, by the way, so that I will try to transfer data into a new directory. But here, so I have basically like created a number of mapper is equals to 4, so that it will be able to do a data transfer in a fastest possible manner. And if I have that many number of system which is available, so that it can assign the task to a different system. And here, so I'm trying to give a split by ID column, right? So we have a order table. Inside the order table, so we have basically a ID column, right? So what it will do, it will try to allocate a different IDs to a different mapper. That okay, so you transfer this data, I'll transfer this data, you transfer that, I will transfer that. So basically this is something that it is going to perform. And let's run this scoop command, and then we are going to check basically this particular directory. Yeah. So now to run this particular command, let's try to open up a new terminal. Let me increase a size and then try to execute this particular command. Let's see. Yeah. So now if I'm going to hit enter, it is going to run 4 mapper, and a different like IDs or different job you can say will be assigned to a different one. And obviously the whole objective is to make my entire task parallel. Yeah, make my entire task parallel, make it faster, as fast as possible. So just wait for some time. Mapper is equal to 0%, reducer is equal to 0%. Okay. I can try to check over here. So now system is like hanging a little bit. So running, I can click on that, but I'm not able to refresh it as my job is running and it has occupied my entire resources. And basically this is a single node system, right? So, okay, still running. I'm not able to like click it. So we'll have to wait for some time, guys. So, okay, mapper 50% done. Okay, so basically it has launched a map task is equal to 4, as you can see. And yeah, so basically it is able to transfer the data. Now I can maybe go and try to check that how many file it has created on this location. Yeah, because this was the target directory for me. So I can write over here that HDFS, DFS basically, and LS into this directory. Fine. And let's see. So here you must be able to see that it has created 4-part file, right? It has created 4-part file, and as we have launched a 4 mapper. So in parallel, so it has started importing our data, and in parallel it has created this particular file. And if you will see this entire file, so it has already named it as a 0, then 1, then 2, and then 3. So in this way you will be able to achieve a parallelism. You just have to increase a number of mapper, and then you have to basically give that, okay, so what should be the split criteria? Means whenever mapper is going to run, so mapper will be able to decide that, okay, fine, so I have to carry a load or I have to carry a data, but based on what? And that's the reason, so I have given split by ID over here. Okay, so hope this command is fine, and hope all of us are able to understand that how we will be able to transfer data, and that too in a parallel manner with the help of Scoop. So with that, thank you so much everyone. Take care and see you again. Okay, so welcome back once again, guys. Now in this lecture, I'll be talking about how we can do an incremental update. So for example, I have a table, right? I have maybe a order table, and inside that I have a data till this point, right? And let's suppose someone is going to store, or someone is going to insert more and more record. So let's suppose till time t, whatever data that I had, I have to transfer that data into a SDFS system. But after time t plus 1, so after time t basically till time t plus 1 or t plus 10, whatever it is, if user is trying to insert the record, so when I will start doing a import of the data from a MySQL system to a HDFS system, it should not import a data which it has already imported, right? So it should always try to import a data so which was basically available, so which was added newly inside the MySQL system. So that is something called as incremental load. So let's try to understand how we can do a incremental load, by the way. Yeah, incremental load. It's not going to be tough, by the way. So it is going to be very, very easy. Yeah, it is going to be very, very easy. So here to do that, so far we were trying to do a scoop import, right? But this time what I will do, so instead of doing a scoop import, what we will do, we'll try to create a job. So we are going to write a script. Basically, this is the script, and this script is going to create a job. So here I'm creating a job with the name order inc append, incremental append into the order. So whatever name that you would like, so you can try to give that particular name. And I'm trying to create a job, by the way, and whenever I'm going to call this job, so this job is going to perform a task for me in terms of like loading a data into an incremental manner. So till this point, so we are just trying to connect. Yeah, we are trying to connect to a table, and then we are trying to set a directory over here, and we are trying to call incremental. We are trying to call this parameter called as incremental append. So whenever new data comes, just try to append into a file, and check a column is equals to ID. So whenever it has to identify the incremental load, so it will go and it will try to check that whether something has been increased inside the ID column or not, because ID column is basically in a auto increment mode. So it will try to check, and last value is equals to 0. So it will try to basically like check whenever you are going to start it for the very first time, that okay, so the last value is equal to 0, and then next time, so it will try to check for the new ID. Number of mapper is equals to 1. I'm trying to give. Now let's go ahead and let's try to create this particular job. So here paste it, and yeah, so it has created a job, by the way. It has created a job over here. Now, once this job is been created, right? Now, once this job has been created, so how I will be able to execute this job? So to execute this job, command is very simple. So scoop job execute and the job name. Yes, job name. So, okay, let's try to execute it. So here enter the password. Okay, CLOUDERA, Cloudera. Now it has started executing it. It started executing the job. Okay, so it has basically finished a job. Now, once it has finished the job, I can go and I can try to check over here that what kind of a data we have inside this one. So we can try to write Hadoop or HDFS, DFS hyphen ls, and then let's try to basically write this path. So yeah, there is a part file it has created. You can even do a cat operation and you will be able to check what is there inside this file. So you will be able to see like data which is available so far. So maybe I can try to write append slash prt part hyphen m hyphen 00000. Yeah, and sorry, not I should not do ls, by the way. I should do a cat to see a data. So hyphen cat, fine. So now this is the data which is available. So ID is equals to 1, 2, 3, 4. Okay, that's cool. Now do one thing. Let's go back to a SQL, right? Let's go back to a SQL and let's try to insert a couple of more record over here. So paste and then insert couple of more record. Okay, so cloud data. Okay, so now let's try to insert the record. So that's fine. Select star from orders. So no database selected. Fine. Select. So use basically retail. Fine. Now select star from orders. Now it has updated a couple of more records. So previously there was like 4 records, right? And now it has basically updated 2 more record number 5 and record number 6. Okay. So if this is the new record which I'm able to get, now how I will be able to transfer that into this particular file? Because so far I just have a 4 record which is available to me, right? So to do that, what I can do is that I can try to run the job once again, the scoop job which I have created. So scoop job execute order incremented append, and let's see. So whether, so password CLOUDERA cloud data. Okay. So let's see. So whether it is able to do an incremental load or not. So it should not bring the entire data, by the way. So it should always try to bring a data which I have appended recently, right? So that is something that it is supposed to do. Okay, that's cool. Let's try to check this Hadoop cat and let's see. So whether we have data or not. So it is not showing me a data, the latest one. Maybe I can try to do ls first. Yeah. And yes, it has created a new part file, and inside the new part file, as you can see, so I will be able to see the record, right? Because this is been done at this point, and now this is the next job which it was trying to execute, and there is a new part file it has created. So let me check this part file. So yeah, we have a new record, right? We have a new record and it is not trying to bring all the records. So see guys, I just had only one mapper and I have not done any kind of a mapping with respect to the ID column mapper, right? So it has not created a split file, by the way. So it has created a new file just because there was some new record it was able to find out. And it is trying to keep only 5 and 6 record, 5 number records and 6 number record over here. So it is not trying to bring a record from a 0. So that is the beauty, and this is how we are able to achieve, by the way, incremental load inside a scoop. So hope all of you are able to understand. So please try to execute it. In case of any kind of a concern or doubt, don't forget to reach out to me. Yeah, with that, thank you so much, everyone. Okay, so welcome to lecture once again, guys. So as we are able to understand job creation inside the scoop, as we are able to understand the import operation in terms of a scoop. So now let's try to understand that how we can try to export a data, right? Export a data back inside MySQL, means from Hadoop to a SQL, how I can do a data transfer. And again, it is not going to be very difficult. It is going to be very easy one. Now, so let's go to my MySQL and system clear. Now, so here I can try to create a table. So let's create a table. Create a table. ORDERS, orders underscore EXPORTED, exported, just like the order table. So it is going to copy the schema and it is going to create the table, by the way. Fine. So orders exported. So this is a table that we are able to create, and this schema of this table is just like a order table, as simple as that. And I will be exporting a data inside this order exported table. So to do that, command is again very simple. So let me show you the command. So here, instead of doing an import, you have to write the export and then connectivity, right? Then connectivity, and then you have to write Unicode, use Unicode is equal to true character encoding, because you are trying to read from the part file and then you are transferring a data back, right? So this is something that you are trying to do, and my data is already available here. So the last time that the import that we have done, right? So our data is already available over here. So from this directory, it will try to read your part file, which is already available. It will try to parse that particular file, and then it is going to load a data, right? Load a data into this particular table. This is how easy this entire command is, by the way. And yes, people have made this scoop very easy to understand. So let's run this one. Yeah. And if everything is going to be fine, then it is going to give me a data into a newly created table. And in between, so maybe you can try to check whether there is a data inside this table or not. So here I can try to check, select star before my command execution gets finished. Oh, so basically, like it has already finished it, right? It has already finished it. So because of that, it is showing me a data. Otherwise, it would not have shown me a data, by the way, right? It would not have shown me the data. So before running this command, if you are going to check this table, the newly created table, you will be able to find out that there is no data inside this particular table. But yeah, so as I'm able to run the command, so it is able to read a data from the directory that I have given, this directory, right, where data is available in a part file format, which is basically a HDFS file format. And now it is transferring a data to my MySQL table. So now fully we are able to cover a scoop. So SQL to Hadoop and Hadoop to a SQL system. We are able to transfer a data successfully. All of this command, guys, I'm going to give it to you so that you will be able to execute it inside your system, and then let me know if you have any kind of a concern, if you have any kind of a query. And obviously I'm here to solve that particular query. With that, thank you so much, everyone. Take care. Okay, so welcome back once again, guys. Now in this lecture, I'm going to talk about Kafka cluster setup. So see, guys, there are multiple ways by which you can do a Kafka cluster setup. So maybe into a local system, or you can try to use a managed cloud platform. Now, so people generally ask me a question that which is going to be a suitable option for me. So whether I'm supposed to do a Kafka setup into a local system, so maybe into a Windows machine, or maybe into a Mac machine, or maybe into a Linux machine, or shall I go ahead with the managed cloud platform, maybe Azure, AWS, or GCP, or maybe do we have any other options? So that option I'm going to show you in this particular lecture. So let's try to understand. So here, just go to Google. Yeah, go to Google and try to search for Confluent Kafka. Now, Confluent Kafka is a managed cloud platform, so which is known for dedicated Kafka cluster. So here you will be able to get even a free credit of $400. Obviously, you have to add a card in a beginning, but yes, you will be able to get a free credit of $400 as well. And setup is pretty much easy. So you just have to go click create a cluster, inside a cluster, create a topics, and then you will be able to connect programmatically with that Kafka cluster. So let me show you that setup approach, and then in our upcoming classes, obviously I'm going to show you that how you will be able to create a producer and how you will be able to create the consumer. So here, just try to click over here and click on start for free, and just go ahead with the Google sign up. So here I'm just trying to do a Google sign in. Okay. So my account is already there, by the way. So I have already created an account and I have already done the experimentation. So now it is not going to ask me for a card because I have already added my card over here. I can't show you that information, but yeah, even if you are going to add your card, if you are not crossing $400, so in that case, they are not going to charge you anything. So you are not supposed to worry about anything, by the way. So here, just come to your environment, and from this environment, so what you can do, you can try to click on maybe a default, and then from here, so you will be able to click on add cluster. So by the way, this will not be available. Yeah, this will not be available. A cluster 0, which you are able to see me inside my system. So it will not be available by default, but yeah, so you can go over here, add cluster, and then try to select a first one. I think this one is one of the cost effective, and I think it's more than enough for you to do any kind of a setup or to experiment any kind of a Kafka things. So here we can try to name this cluster as maybe Euron underscore cluster cluster, and then you can try to click on launch the cluster. It is going to take some time. Yeah, it is going to take some time, maybe like a couple of minutes it is going to take, and then it is going to set up your entire cluster. Yes, it is going to set up your entire cluster. Now, once this cluster setup is done, so maybe you can try to come to this API key option. So again, we have a networking over here. So all of this IP address is basically whitelisted. And here, so cluster is available over a public internet so that you will be able to access it from anywhere. There is a API key option. And here, so you have to go and you have to create an API key, because this is important. This is important for you to connect with your cluster. Unless and until this API key is not available, you will not be able to connect with your Kafka cluster. So just try to click on create API key. It's a easiest step, and click on my account, by the way, click on next over here. And then this is a key and this is a secret which is given to you. Now, try to maybe like give some sort of a description. So Euron key, KFK, Kafka, and then download and continue. Now, once you are going to download it, it is going to give you a key detail as well as it is going to give you the server detail. So as you can see, so this API key which is required, this API secret which is required, the resource is required, and this server detail is required. Yeah, this server detail is basically required. Now, if you have all of these information, you will be able to connect with your Kafka cluster, and you will be able to create a producer, you will be able to create a consumer. Not just that, I would say. So yeah, this is something which you have to keep it with you. Yeah, this is something that you have to keep it with you. As simple as that. Now, so you can try to come over here and then you can try to check a cluster setting as well. So whatever default setting which has been given to this particular cluster, so you will be able to find out, again, you will be able to find out a bootstrap server, a REST endpoint detail over here, and then maybe you can try to like change this particular name if you want. I'm going to cancel it. Plus here we have something called as topic. So I can come over here and I can try to create a topic where I have to like store a data, where I have to store information. So basically topic is nothing but just a name that we are going to give so that we will be able to send our data to this particular topic. So maybe I can try to like give test as a topic name, and then I can try to like start sending our data. So create with a default partition is equal to 6. If I want like a less partition, so I can try to choose that option. I can even try to click on this advanced option, and then I can try to change all of these settings. So I can just try to click save and continue. And here, so it will end up creating my topics, as you can see. Yeah, so this is the topic that it has already created, and whatever I'm going to produce, right, whatever I'm going to produce, I will be able to see all of these messages over here. As of now, it is showing me that my topic is empty because I have not produced any kind of a data. But obviously very soon I'm going to show you in an upcoming lecture that how I will be able to produce a data to this particular topic, and then how I will be able to consume this data. And then it's done, right? Because roles and responsibility of this entire Kafka is nothing but produce and consume. So basically it's a messaging system, and yeah, so I will be able to do that. Apart from that, so inside this Confluent Kafka, you will be able to see a couple of more options like a table flow or maybe a connector. So where you will be able to connect with the multiple services, which is already available out there in this entire world. So they have given you enough number of connector, by the way. So you will be able to connect with any of the services, and then you will be able to, stream a data, as simple as that. So maybe you can try to connect with the S3 bucket step by step. And again, these steps are pretty much very simple, right? These steps are actually very simple, which we all are going to explore in our upcoming classes. Simple, yeah. So hope all of you are able to create a Kafka cluster. Leave the setup. I don't want this one as of now. I will learn, maybe I'll need this in a future, not now at least. So I can try to create a cluster, and once my cluster is up and running, if my cluster is ready, it's done. Yeah, it's done. So fine guys, with that, thank you so much everyone. Take care and see you again in my upcoming lectures. Okay, so welcome back to lecture once again guys. Now in this lecture, I'm going to show you that how you will be able to create a producer, so which is going to send a data to a Kafka cluster, and how you will be able to create a consumer, so which will keep on consuming our data, maybe data from a beginning or maybe data from latest. Both option is possible. So let's do it in a practical manner guys. By the way, so here is my Kafka cluster. What I will do, I'll go over here and I'll try to create a new topic. I have already created a topic in my last lecture, but yeah, let's go ahead and create a new topic. So here add topic name I'm going to give. So let's suppose prod underscore consume consume a test. So this is the topic name which I am giving, and create with default, and leave it as it is. Fine. So as of now, the topic is created, topic is available, as you can see, prod consume test, but there will be no data that you will be able to find out over here. So this topic is completely empty as of now. Now what I can do, so maybe I can try to write a Python code, so which will start sending a data over here. So I can try to call a VS Code, and then inside a VS Code, so let's try to create a folder over here, and yeah, so let's try to create a folder big data underscore code. Inside that, I'm going to create a folder Kafka demo. Fine. And inside this, what I will do, I'll try to create two Python files. So let me close this and let me close this one. Now it's clean. Now here, so let's try to create two files. So first of all, try to create a producer underscore kfk.py file. Fine. And then try to create another file and name it as a consumer underscore kafka.py file. Fine. So we have two files. One is a producer, so which will keep on producing some messages, and one is a consumer, so which will keep on consuming a messages. Now, so here I'm going to show you a producer, and your producer can be anything. So whichever system is trying to produce a data, so that system is going to be a producer, and whichever system would like to consume those data or take those data and do some sort of operation, so that will become a consumer for me. So here I'm going to create a custom producer and a custom consumer. So let's see these things guys. So here, if I have to create a producer and consumer, so I need a credential. And if you remember in my previous class, when I was trying to create this Kafka, right? So at that point of a time, so we have created this particular access. So API key, API secret, resources, and bootstrap server. So these things will be important so that you will be able to connect, and then topic name. Yeah. So this is going to connect with your cluster, the cluster that you have already created. So let me show it you once again, the cluster that you have already created, for example, Euron cluster that we have already created. And then we have created a topic, right? So we can give a topic name. So in this way, it will be able to reach out to the cluster, and then it will be able to reach out to the topic. Fine. And you will be able to access it. So here to do this operation, so first of all, inside a producer, try to import. So from Kafka or here Confluent Kafka. So import producer, and then import maybe like a time over here. Fine. So this is the import that you have to do, so that I will be able to create a producer inside this particular file. And then you have to give your configuration. So configuration, why? This is the configuration that you have to give. Bootstrap server. So again, coming from where? So coming from here. So here is my bootstrap server, right? And then we have a security protocol. So SSL basically mechanism plane. Username is going to be again, so this is going to be my username. API key name is going to be my username. Fine. And then password. So password is going to be what? So API secret, as simple as that. Fine. So this is something that you have to give as a configuration, and in this way it will be able to connect. And then let's try to create an object for the producer. So here producer object I'm trying to create. Fine. Producer object, and with the help of this one, Now, once this is done, then try to give a topic name. So topic name, and what is the topic name, by the way? So my topic name is basically prod consume test. So just try to copy this topic name. Yeah, whatever topic name that you have given. So replace it with this one. So here, this is my topic name. So once I'm able to give a topic name, right? Once I'm able to give a topic name, so maybe I can try to create a callback over here. So callback means whenever message delivery is going to fail, so it is going to tell me something. Okay, fine. Now, once this is done, so what we can do, we can start creating, or we can start running some sort of a loop which will keep on producing a data for me, right? And then I will keep on writing. For example, I would like to write that my name is Dhanshu Kumar 1, 2, 3, 4, 5, 6, 7, 8, something like that. I'll keep on sending this data again and again and again and again. So for sure, I have to run these things inside a loop. So here, let's suppose I'm writing I is equals to 0. Yeah, so here I'm going to write I is equals to 0, and then I'm going to write while true. Yeah, while true. And then here, so I'm going to write a message. So maybe I can write over here that my name is Sudhanshu, right? And I is equal to 1. So while true means it will keep on running these things inside the infinite loop, by the way. And my name is Sudhanshu. So 1, 2, 3, 4, 5, 6. It will keep on running it unless and until I'm not going to stop. So it will be inside an infinite loop unless and until I'm not going to stop. And here, so producer object that we have created. So producer dot produce what? Topic name I have already given. So it will be able to go there, and the producer is already connected to my this configuration, means server. Yeah. Now, so message encoded UTF-8 callback. So if there will be any kind of a error, so it is going to do this one. It is going to call this method, and whatever we have written as a error handling, so it will try to print that one. And producer dot polling. So we are trying to just call polling over here, so that it will try to stop for some time, and then we are going to call I is equal to 1, 2, 3, 4, and so on, and then time dot sleep. So just try to sleep for 1 second and then do it once again. So this will be my producer. Now, to execute this entire producer, what I'm supposed to do, by the way. So first of all, just go to your a terminal, and then you have to install this Confluent Kafka. So unless and until this Confluent Kafka is not installed, it will not be able to do it. For the very first time, you have to do it, whatever environment that you are using. So here, let's try to hit, and yeah, so in my environment, it's already installed. So let's try to clear this one. And here, so what I will do, so I can try to call Python producer kafka.py file. Now, once I'm going to execute this, it will start running it into a infinite loop, message delivered to producer this, right? So it has started running this entire things, and yeah, so it is trying to print this particular message, that message delivered to this topic and then this partition. So topic and the partition. So this topic and this partition. So I'm trying to print it. Fine. I'm trying to print it because of this callback. So whatever is happening in between, so I'm able to print it. Now what I will do, I'll just go and test it. So here, once I'm coming over here, prod consume test. Now I have so many messages as you can see, right? 42 messages. So again, I will keep on receiving these messages over here, right? So these messages over here, simple, right? So let's keep it from a beginning. So yeah, and here, so I have created 6 partition for this particular topic. So in whatever partition it is trying to send, so it is showing me partition, it is showing me offset, it is showing me key is equal to null, I have not provided it, and then value is equal to this one. So I'm able to get, or I'm able to see this particular data, as you can see. Simple, right? And this is my message, by the way, right? This is my message which I'm able to see it, and in which partition, what is the offset of this message, each and everything I'm able to see it. Now, so I have started producing the data, and in real time it is producing a data. A lot of data it is able to produce, as you can see. It is keep on producing the data again and again and again. Now, so let's do one thing. So as of now, just stop this producer. Just Control C and then maybe clear. So stop this producer, and maybe I can try to write a consumer now. Yeah. So again, consumer is not a tough task. So it's a very, very easy one to write it down. So first of all, you have to call from Confluent, C-O-N-F-L-U-N-T, Confluent Kafka, import this time consumer, C capital, C-O-N, consumer. Fine. Just try to import a consumer over here. That's it. and then you have to do the configuration. So configuration is important so that it will be able to reach out to your server. Now here configuration wise, so again server URL, simple, protocol is same, username is same, password is same, and then group ID my Python consumer I have given, and then here so offset reset wise you can try to give two options. One option is a earliest and one option is a latest. Earliest means, let's suppose if you have started consuming this data for the very first time, so it will start consuming it from the beginning, so whatever data which was already produced. And if you are going to give a latest, so it will not start from the beginning, it will start from the current one, so whatever data that you are sending. So I'll try to keep it as a earliest, as simple as that. And then let's try to create the consumer, and then this is my like consumer test. Yeah, topic name is prod consume test, and then here I can try to write that consumer.subscribe. So subscribe to which? Subscribe to this particular topic. I can try to give a multiple topic name, that's completely fine. But yeah, so I would like to like subscribe to this particular topic as of now. So here now let's start producing this data. So maybe I can try to like write waiting for a message, and then I can try to basically like write over here that try, and then let's keep it inside the exception handling, and then while true. So continuously I'll run these things into the infinite loop. So while true, message consume dot poll is equal to 1 second. So it will wait up to 1 second basically. This is the meaning of the polling. If message is none, then again run it from here. Wait for like this one. Message is equal to error. So in that case, try to give me this, and then again continue, means keep on looking for the data. As simple as that, right? Keep on looking for the data. And if it is able to receive the messages, if there is a message, then in that case print. Simple, right? Print. So fine, try I have already written. Then let's try to write the except over here. So except is equals to keyboard interrupt, and then I'm going to write the pass. Just keep it pass. I think that's more than enough. Nothing is required. Fine. And just try to do Control S. So this is my consumer. Now here, so if I have to run my consumer, so what I can do, I can try to write Python, Python, Python consumer Kafka. And yeah, so I have given earliest. So technically it should start consuming data from the beginning. And as you can see, so it has started consuming a data, right? It has started consuming a data. Now parallelly, I can run my producer and consumer. I can try to like open up my command prompt, and then here, so I can try to write Python producer.kafka. So continuously it will keep on producing and it will keep on consuming the data, and I'll show you that part. So see, it has started producing the data, right, continuously, and here, so you will be able to see that it will keep on consuming the data. Fine. Keep on consuming the data one by one, one by one, one by one. So it has started consuming the data for me. Fine. So one is producing the data and one is consuming the data. So this is how easy it is, guys, right? So my source can be anything, my sink can be anything. Going forward, I'm going to show you like so many different kind of connectors. But yeah, so from anywhere I can consume the data, and from any places I can try to produce the data. Maybe like from any places I can produce the data and send it to a Kafka cluster, and then from any in any system I can consume the data, and then I can try to do a data processing, and I can do whatever I want with those data, right? So this is an example of a producer and consumer with respect to Kafka. So hope guys, all of you are able to understand this entire application practically, and as you can see, so yeah, everything is working in a real time. So with that, thank you so much everyone, take care and see you again.